A very good morning to distinguished guests, ladies and gentlemen. Warmly welcome all of you to the conference Zak World of Façades, the second in Vietnam and the 107th global edition today. Ladies and gentlemen, my name is Chuk, the host for the event today. And first of all, on behalf of the organizing committee, we would like to send our gratitude to all you present here today. And we also wish you good health, happiness, and do hope that all of you have a meaningful day with this event. Thank you everyone today. Xin nồng nhiệt chào đón toàn thể các quý vị đại biểu, quý vị khách quý. Chúng ta đã cùng tới tham dự sự kiện hội nghị Zak World of Façades lần thứ 2 được tổ chức tại Việt Nam cũng như lần thứ 107 trên thế giới. Và lời đầu tiên, thay mặt cho những người làm chương trình, xin được gửi lời cảm ơn chân thành tới sự góp mặt và hiện diện của toàn thể quý vị trong chương trình của chúng tôi ngày hôm nay. Kính thưa quý vị, trong quá trình chúng ta theo dõi chương trình, xin được mời toàn thể quý vị chúng ta sẽ cùng chuyển điện thoại sang chế độ im lặng để chương trình không bị gián đoạn. Ban tổ chức xin trân trọng cảm ơn. Kính thưa quý vị, mở đầu chương trình ngày hôm nay, ban tổ chức xin được trân trọng kính mời ông Ahmed, giám đốc chuỗi triển lãm và hội nghị của Zak sẽ có đôi lời phát biểu chào mừng tại hội nghị của chúng ta ngày hôm nay. And now, ladies and gentlemen, please welcome on our stage Mr. Ahmed, Director of Zak Exhibitions and Conference, for welcoming speech. Please welcome.
Right. So, good morning, everyone. Welcome to this 107th edition of the Zak World of Façades Conference. My name is Ahmed. I'm part of the organizing team here at Zak Exhibitions and Conferences. I'll just give you a quick introduction of the Zak World of Façades Conference series, and then we can get straight into the conference agenda. We organize the Zak World of Façades Conference series in 35 countries around the world now. We started this back in 2012 as a small networking event, but it's grown into a large series of events across the globe. We talk about different trends, different innovations in the world of building envelopes, doors, windows, facades, roofs. So that's what we've been doing. The major growth factor of this event was the facades becoming more complex. They are no more your simple window wall or your glass box structures. Shapes are becoming complex. There are more user requirements such as thermal performance, natural ventilation, fire safety has also become a big concern. So because of all these reasons, we've been able to organize these events because facade engineering as a profession itself is relatively new. So this has helped us accelerate the conference series across the globe. As Truk mentioned earlier, this is our second event in Vietnam. We had a nice event in 2019 in Ho Chi Minh City. We wanted to do this event in 2020, but did not happen for obvious reasons. But now finally we are here. We have a very good agenda. I want to thank our event partners who have supported this event and have been patient because it was an old event of 2020, could not happen. I'd like to thank all of them. Let me start with them one by one. Our presenting partner, Shuko. So Shuko is a global leader in aluminum door, window, curtain wall systems. They've been present in the Southeast Asian market from decades, and they have a strong presence in Vietnam. It's a subsidiary called Shuko Vietnam. You'll be hearing from them and most of our other sponsors later today. Our associate partners, starting with AkzoNobel. So AkzoNobel is a leading manufacturer of coating for doors, windows, and facades. So they have liquid coating with the brand Interpon, and they have, powder coating in the brand Interpon, and liquid coating with the brand Trainar. BM Windows is one of the leading facade contractors based in Vietnam, doing projects in Vietnam and across the globe. China Southern Glass are a leading value-added glass processor out of China with several reference projects in Vietnam. Elval Color is a Greek manufacturer of non-combustible aluminum composite panels. Kinlong is one of the world leaders in glass hardware, fitting and tools out of China. So Curare is the mother company of the laminated glass interlayer brands Trocifol and Sentry Glass. Schiele is a specialty grade German facade engineering facade contractor doing specialty stuff. They are known for their work on the Apple stores globally. Siderice is a British manufacturer of cavity barriers for curtain walls, so it's a passive fire protection product. They've been present in this Southeast Asian market from the past few years. Tekronil is a Indian manufacturer of modular railings for buildings. So they have some nice range of stainless steel and aluminum based railings. 2690 is a distributor of GE sealants and STI Firestop solutions. Vector Foil Tech is again a German company specializing in the design, engineering, fabrication and installation of ETFE. You will be hearing from them later today. Orga Data is a German software manufacturer into estimation of doors, windows and facades. So these have been our partners for the event. So Orga Data is our technology partner, so all the ones having a red badge will have a USB stick. That USB stick is courtesy Orga Data. The USB stick also has the brochures of all our exhibiting sponsors. So we are not giving the bag anymore. So we've decided to put all the brochures in a soft copy. Of course, as I mentioned, we are doing events all around the globe. We've got 2 more left for the year. That's edition 24 and 25. So our next one is in Dallas 2 weeks from now in the US. We've got one last one in Saudi, in Riyadh, end of the year. And then, of course, we restart with Southeast Asia with Singapore. We've got 2 in Australasia. So Melbourne's on the 16th of February. Auckland is on the 23rd of February. And of course, in the Asia Pacific region, we've got events in Seoul, in Shanghai and Hong Kong planned for East Asia. And then for Southeast Asia, we will return with the Ho Chi Minh City event next November. We've got Singapore in March, and we've got Jakarta in August. And of course, the Australasian events. So this is what we've been doing with the events. We've got a fabulous response to all our events all across the globe. Facade engineering as a profession is becoming well known, and facades itself are getting complex, so they need much more detailing, they need much more understanding, and today's presenters, I hope, will help you take away a few things which you can then use in your upcoming projects. Basic housekeeping rules, Truk has already mentioned to you, but I'll just reiterate. Most of the speakers will be speaking English, but those who are speaking in Vietnamese, you've got the headsets on the table. We won't be taking any questions. If you have questions for the speakers, you can ask them in the networking break. And all our sponsors have a booth outside. Request you to meet them in the breaks, network with them. Maybe their solutions could be of use for you in your current and upcoming projects. So thank you all. That's it from me. I'll call Truk to start today's event and start with our first speaker. Thank you.
Xin được trân trọng cảm ơn phần phát biểu và chia sẻ đến từ ông Ahmed. Thank you very much, Mr. Ahmed, for your nice welcoming speech for our event today. Kính thưa quý vị và quý Trúc, xin phép được lưu ý đó là trong quá trình các vị diễn giả của chúng ta trình bày các bài thuyết trình thì chúng ta sẽ không có phần giao lưu hay hỏi đáp trực tiếp trong quá trình bài thuyết trình cũng như tại phía sau bài thuyết trình. Tuy nhiên thì quý vị, nếu như chúng ta có bất cứ những câu hỏi, những thắc mắc nào thì xin mời quý vị chúng ta có thể liên hệ với các diễn giả của chúng ta trong quá trình chúng ta tham quan triển lãm, tham quan booth và đặc biệt là tại các phần networking section cũng như là các phần nghỉ giải lao. Ladies and gentlemen, I would like to mention that we do not have any direct Q&A section during the presentation or after the presentation. However, please feel free to visit our exhibition, our booth, and especially if you have any concerns or Q&As with our speakers, please contact them in the networking section in a tea break. Thank you. Kính thưa quý vị, và ngay bây giờ xin mời toàn thể quý vị chúng ta sẽ cùng đến với bài thuyết trình đầu tiên với phần chia sẻ và trình bày của Mr. Steve Van Aelst, giám đốc kiến trúc sư tại Van Aelst Nguyen and Partners với chủ đề kỹ thuật mặt dựng ở Việt Nam, công nghệ và tính trọng yếu. And ladies and gentlemen, please welcome on our stage the first presenter at our conference today, the Director, Architecture of Van Aelst Nguyen and Partners, Mr. Steve Van Aelst. Ladies and gentlemen, please raise a big applause, please.
Thank you for the very kind introduction. Normally we should have presentation with myself and Tony Nguyen, but he's unfortunately sick, so I'm going to try to take you through the whole presentation by myself. Today we're going to show 7 projects around certain themes that we laid out over here. Small projects, bigger projects, some architecture related, some facade engineering. Our first project is a small one. It's the Eco School in Hanoi. This is a project that's been finished about 1.5, 2 years ago. We had to wait a little bit till the plans grew up in the facade, but they are done now. And it was the ambition from the Ministry of Construction to have a school building which has like exemplary performance when it comes to ecology and energy use and sustainability. This project, based on traditional architecture but translated into a contemporary way, where we use the terracotta elements and some of the green elements into the facade. This is how the perspective, how it looked like, and then how it came out in reality. For this project, there's a few green initiatives. There's a strong focus on using a mix of natural ventilation and also some mechanical ventilation, which reduces the energy quite a lot. We also use like solar, wind, and water strategies, where we reuse the actual the water, where we have solar panels. Even we have like a little wind turbine on the actual building, and we reuse the water back into the building as well. And then a little bit more advanced things that we don't see so much in Vietnam, where we use the CCA technology, actually have tubes in the slab who cool down the building when it's warm and warm up the building when it's cold. And these are connected to wells that are in the ground, so to also to balance out the temperature. So that means, in essence, and thank you for Boydens for this one, for the energy calculations, that for this project we save about 71% on energy consumption compared to standard school projects. The next project, a little bit bigger, is the Viettel headquarters. Maybe some people have seen it if you drive around in Hanoi. This is a project, complexity, 3-dimensionally. It's 2D curved, but also it's like 3D curved. So actually it's a project that we had about like around 330 different types in the facade to make it as simple as possible, whatever that means within the geometry of the building. Concept designed this one by Gensler. Gensler, who made the architecture concept for this one. And what we did is we took, for the facade engineering, we took the project all the way from the beginning to the end. We do reflective study, especially because of the shape, because there's a lot of reflection, especially with the concentric geometry of the building. And then we study for inner facade. We also study for the outside of the facade. We do all the heat load studies to make sure that we put the right glass type at the right location with the right performance. And then we study all the modulation and the shapes of all the louvers, the depth, the spacing, to make it sure that it works at the different locations of the building. This is a small video, so I give the overview, how we cut through the building and how we get from the overall large picture into the small detail. Actually, the inner side is a little bit more simple. The outside is like it's even stepped, so it's 3-dimensionally stepped at the same time as well. So that's how that looks like with and without the louvers. And these are all the types that we study for the building to make sure at every location it's deserving the performance that it should have. On that basis, we propose all the glass type for the building. One of the special things for this project, it was that the Viettel demanded that all the materials would come from G7 countries. So that means glass, this one is Viacon from US. Then we had a frame system coming from France, and then the fixing coming from Germany. All put like a little Lego box, put together, bring to Vietnam, and then over here, BM Window, they put it all together and they install. All the shading study also internally to see inside the building, to reassure the user friendliness for the people that actually have to work over there, because at the end, we design for people. And then some details on how we go from model into, and there you can see the stepped condition that gives that level of more complexity to it. From the PMU to the factory visit, samples, and then actually how it's been built on site, when it was being manufactured and installed on site. Some large glass panels. The glass panels, some of the glass panels that you see over here, they're about 11 meters, which as far as I know, one of the more heights available in Vietnam. So that was interesting. A few broke on the way to Vietnam, but it's been done. And then we have the final, or nearly the final images, where we go from rendering to actually how it looks like. So I think it looks quite close. Third project within the framework of more like historical project. It's a project which is a museum in Long An, museum and library. Very different, nothing to do with high tech, as low tech as possible. And we look into, we design the future with the past in mind. So we look into what's specific for Long An, how does it connect to its history. We checked various disciplines, from archaeology, nature, culinary, etc., and then see how we can have like a traditional program and translate it into something that's designed for the future. So we look into like traditional roof, and then we sculpt the roof, we shape it, we cut it open to provide light for the spaces for exactly what it needs. And then we apply that to the whole project, to something that starts with traditional input to have something that looks not so traditional. However, the material palette is quite traditional because we use bricks, we use tiles, we use concrete, so nothing fancy so much. Typology is done in a way that's also quite traditional, where we design a right courtyard, have all the different programs around one central courtyard. So for people that have some knowledge about traditional architecture, you'll find quite a few houses where you have individual buildings around central theme. This is the entrance view towards the museum. Some interior views from the museum. Courtyard views where you can see the roof, doing the movement which it does. Day and nighttime view. And an interior view from the library. So it's basically like a celebration of bricks, concrete, very simple materials, but that can be used like in a very different way. Then the fourth theme is contextual. It's a project that we do in Hanoi, which is currently under construction. It's a gallery project, part of the Manor Central Park. So we use the idea of the Hanoi autumn leaves, and then we take green, we celebrate, and we literally elevate the park context and the way how we integrate. So we look into traditional architecture. Vietnam, you'll find a lot of like screening, where you have ventilated bricks to allow cross-ventilation into projects. And we combine that with the idea of the park. And we translate that from the leaves into the panels. These are UHPC panels. So in Vietnam, it's always wise to, from our experience, to look into materials that are feasible in Vietnam. Because many times it's easy to fancy materials coming from Australia and from Germany and so on, but they don't always necessarily fit in the budget. The slogan mostly is make it look luxurious, but cost efficient. So this is like fully UHPC. Low-tech material with fiber concrete that we basically slide over the building. And then in between the building, the glazing, and then the screen around, then we provide a lot of green. So people that use the building, they always have like a view towards the green and plants and have nature actually elevated and included part of the building. So this is some of the work in progress and the images as it's under construction at the moment. The nice thing with UHPC, you have a lot of freedom when it comes to shape. You make the molds, and you can basically make whatever you want. Just have to make sure you control a little bit how many types and how many molds you have, because if you have 20 different molds, it may be a little bit more expensive. These are steel molds, but normally they should be more like plastic molds, but that's how we went ahead. But these are the screens as they're being manufactured. So it's quite basic. Then we have natural. This is a resort project in Com Dao. The site is very specific. at that location where you have a lot of like rock formation and pebbles. So what we do is we look into what can we use from the actual site, from the DNA and the soul of the place, and how can we translate into like a design in the resort design. So we take the amenity buildings, that's sort of like the image of the project, and these ones, they become the main theme of the project, and we translate the idea of the pebbles into architecture, into shapes and materials. So we use the same material and the same geometry. And that's how we express into the actual amenity buildings, which is the pool bar. You see like villa with eco materials, and then actually the rock formation. That's like that goes along the island. Then this project, this is the wing hotels. So this one technology for this project, AW2, they do concept design from Paris. So we do the technical design and facade engineering. And something that made me quite happy is that when I come to Vietnam in 2010, 12 years ago, facade engineering, maybe 1 or 2 towers, maybe 3 maximum. But now it's like much more common that developers, they work with facade engineer, which I think is good news for a lot of people, even to make sure that technically buildings are correct, but also the glass performance, that it works for a hotel, especially when it comes to orientation. So we're doing with, for the wing hotels, this is the first one in Ho Chi Minh, and this one is the next one, which has just been built. So if you go to Da Nang, you can go check out the wing hotels. Technology matters. This is a good example where we have 2 hotels, and each are, if you're familiar with Da Nang, they are each on each side of the river, but the orientation, the left one is what we call Wing Chan Phu, and the other one is under construction, Wing Chan Hung Dao. And if you look into the site map, the location, they are exactly on the other side of the river, but the orientation is like perpendicular. So one hotel is like north-south oriented, and the other hotel is like east-west oriented. So there's a big difference when it comes to performance, especially to glass performance. So we put these 2 projects next to each other, where you can see the orientation, and then also the sun study. And once we go to this one, you see that the energy requirements and the performance and the impact on the building is very, very different. So we study these ones, and then we do all the details. Obviously, it needs to be technically, it needs to be sound, and make sure there's no leaks, which they don't have. We check the sun shading study, and we go through all the calculations to make sure that the impact and the glass specifications are different. So they're very different for the 2 projects. Even though it's the same window, just basically I punched windows with like hoods, window hoods around it, but the orientation makes it very different. So we need very different glass specification for this one, as we show over here. Then we go to all the calculation, etc., etc. And one of the things, also thank you for Boyens for this one over here. And I think to our experience many times with people, especially on client side, I mean, I know there's many professionals over here, but it's always like, oh yeah, laminate glass, yeah, double glass expensive. But actually the prices are not too far from each other. But if you look into the blue line, if you look into the energy saving and the energy consumption reduction, it's quite substantial. So we know from experience that when you do like residential and you sell the apartments, most developers wouldn't care so much, but if you're like the hotel owner and you have to pay the energy bills, you can see there's a significant change when it comes to actually heat load reduction and energy cost. And if you do that, you know, it's always a little bit tricky to do return on investment because you have to check the lobby, public places, but if you do into the hotel rooms, definitely makes a big difference, and the return on investment actually is quite short period of time, so it's not like 5 or 10 years, much less. Okay, we do all the testing. That's how it looks like. Last project, Urbanity. In this project we designed, it's currently 1 to 500. It's like Himlan Twin Towers. So Himlan Twin Towers, this one is in Bac Ninh. For people that know Bac Ninh, it's like satellite city from Hanoi, so it's not so far from here. But it's a quite high building, it's 45 floors. The chairman, this is his hometown, so he said we want to have something that's like different. We want to have something that looks like impressive, but please also make it cost efficient. Maybe sounds familiar. So we looked into this one, looked into the project. We did quite a bit of study, single towers, double towers, triple towers, 4 towers, and all these things. We go to these one, make assessment. And then we look into the actual program, and then we start to play around. Residential on the lower floors, then we have the hotel on the upper floors. And then we shape the tower in a way that the 3-bedroom units, the highest values, that they have the best views, which is very important for this developer. And we sculpt the floor plates in a way like that. And also there was a question to, because it's his hometown, to have like a very nice view over Bac Ninh. So people, they can go over there, they can just take the lift and go up and then have a look, which is about, top of my head, about 135 meters, and then they can look all around Bac Ninh. So. And then we activate the ground floor, and this is how that looks like. So again, we have to look into how can we find a balance in between quite straightforward construction. This is like plaster and paint, except for the bridge, it's a bit more like complex. And then that's all like how that looks like. So even though that these apartments are like natural ventilated, because many times when you see natural ventilated, you get all square blocks, like tuk, 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 tuk. We try to work with natural ventilated, but also in a way that we can offer like something that looks very different than what most buildings would have. So, all right. So this is my presentation. So thank you for your attendance and for your interest.
Xin được trân trọng cảm ơn phần trình bày và chia sẻ đến từ ông Steve Van Aelst. Thank you very much, Mr. Steve Van Aelst, for your insightful presentation at our conference today. Kính thưa quý vị, và tiếp nối chương trình, xin mời quý vị chúng ta sẽ cùng nhau tìm hiểu về nội dung cũng như chủ đề tương lai của kiến trúc mặt dựng thông qua phần trình bày và chia sẻ đến từ ông Timothy Soebroto, Phó Giám đốc của My Heart Facade Technology. And next, for the second presenter, I would like to warmly welcome on our stage Mr. Timothy Soebroto, Associate Director of My Heart Facade Technology. Please welcome.
Good morning, everyone. Xin chào. Hopefully I pronounce it correctly. First, I would like to take this opportunity to thank the organizer, Zak World, for inviting me to speak in this conference. But before I start, allow me to introduce myself. My name is Timothy. I'm from Manhattan Facade, which I have been with for the last 16 years. Manhattan Facade is a part of Manhattan Group, and this is our global footprint and some of our project portfolio, mainly in the high-rise building. And here is some of Manhattan Facade portfolio, some in high-rise buildings, some in low-rise special projects, such as a museum, here is airport, resort, shopping mall, and so on. And here are our projects in Vietnam, in Ho Chi Minh, Hanoi, Da Nang, and so on. Couple months ago, actually, we are experiencing extreme heat in the all over the world, and this one easily generate the fire incident, which happen a lot in Europe, and in U.S. and Europe, it's recorded the highest temperature that happened in the history, and this one not only happened in Europe, but on the other side, a lot of rain as well in Pakistan, which is kill a lot of people, and flood also. Probably we think that this flood happened because we don't have a good infrastructure in Pakistan, but heavy flood also happened in Australia, which is have a very good infrastructure. This phenomenon also happened in the Southeast Asia region. Singapore expert did mention that Singapore will be having more heat in the future. Also, another floods in central Vietnam. The point is the weather become chaos and very extreme. And the problem with us is because the weather is become extreme, the energy used for the building to maintain the human comfort level will be higher as well. This graphic shows that energy consumption for the building and construction industry is 36%, while the emission contribute is 37%, higher than any trade, transport, industry, and so on. So actually, the construction industry and building considered is the culprit for the high energy and the emission contribution. According to the World Economic Forum, reducing the carbon output from building and construction industry is very essential. So, what we can do? Everyone sitting here certainly involved in the building or construction industry, I'm sure. So today, we will think what we can do in terms of the facade. That's the reason probably we can explore what are going to be facade in the future. I'm sure that you saw this one. Anybody see this movie? I was requested by my daughter to watch this movie. This is awesome because my daughter is teenager. It's very seldom teenager asks his father to accompany, right? So, Doctor Strange, Multiverse of Madness. And there is one episode in this film show this one. What do you think? When I saw this one, it's something like clicking my mind that the future of the facade might be a lot of greenery, not only in the roof, but also in the facade itself. If you have no chance, watch this movie again. So the future of the facade, the first one probably is the integration of the landscape to the facade. For the last decade, actually, green roof and green facade are steadily gaining importance and increasing being applied. And the importance will continue to raise as the architect designing the building by keeping focus on combining energy efficiency and habitability. So the first building that I do in Singapore is resort work. They have a very massive green roof. Everywhere they put a greenery on top of the roof. And this one could be the first, another good example for the greenery. One project in Düsseldorf designed by Inghofen architect. This is, you can compare this building compared to the next one, totally different. They have a lot of greenery in this building. Another example that you can do this, we can study, this one is Park Royal building in Singapore. We were involved in this building. This building got a lot of awards, Green Mark Platinum, LEED, Leading City Hotel, Leading World Hotel, thanks to the numerous greenery on the building, especially on the facade. And in here, you can see it's a very good solution that they do by lifting up the slab level on the swimming pool area, probably double or triple volume, allow wind to flow without any hindrance. Another project that we could see is this one. The latest development by Swire Property, again in Singapore, together with Manhattan Facade, is they have a lot of landscape on the balcony, something like become a hanging garden, especially in the city of Singapore, which is very, very dense. Here is very good, very nice, a view from the internal to the external with a very large operable panel. And by having this large operable panel, we can have external experience while you are internal, on the internal side. And this one done by our sponsor Shuko. And this kind, after the pandemic, actually, Manhattan Facade get a lot of requests from the client, architect. They want to have a very large panel or windows in the facade, which is now is very viable because of the technology. There are many ways to do the greenery on the facade. First is a ground-based system, which is the plant grow from the ground. Second is facade bound system, and by using a small media on the facade or mix. What we can do here, this one we should working together with the landscape consultant. From the facade point of view, there are two important things that we need to study. First is the loading from the landscape to the facade. Second, we have to consider the material durability carefully. The second item is the second characteristic for the future of the facade is BIPV integration on the facade. And the integration of solar energy in the building has been available several decades. However, until now, a lot of buildings don't have this one, have not implemented this one in the facade. As shown in this image, actually in the beginning, photovoltaic affected aesthetic negatively. It's very ugly and expensive as well. And this one still in people's minds until today. In the last decade, thanks to the major research, industry have made huge progress technically, but on the other side, the price keep on decreasing and significant as well. This image shows very nice example, the integration between BIPV, photovoltaic or solar cell, and the ceramic frit, developed by one supplier from Europe, and giving the freedom to architect and the client to design their building, achieving energy efficient without sacrificing the aesthetic. You can see in this image, the top row is signage, right? But actually that one is BIPV panel. This project is completed 2 years ago before pandemic and can contribute the power around 20 kilowatt power. In conventional system, photovoltaic was only placed on the roof, and the system is not really very effective for the high-rise building. The main reason is because high-rise building, we have a limited roof area. Especially roof is very dense, and sometimes we have to fight with the M&E consultant to get the BIPV on the roof. So the conventional system cannot provide a lot of energy. That's the reason why we implement BIPV on the facade. The facade in here, the photovoltaic, not only installed on the roof, but on the facade, skylight, walkway, canopy, and many areas. And this one can contribute more, can provide more energy to the building. And as a result, the energy generated will be very significant. The main reason, because the total facade area will be much more than the total floor, roof floor or building footprint itself, and might contribute to the net zero energy building. This one is very good example. This one is not Manhattan facade project, but I have to say this one. But personally, this project is very nice, very good. 50-story building in Seoul, Korea, owned by Federation of Korea Industry, designed by Adrian Smith and Gordon Gill. This building is very unique. They have they put the solar cell BIPV on the spandrel area, and the design is replaceable. So in the future, the BIPV can be replaced when the new technology become available. You know that actually the progress of BIPV design is very fast, and the efficiency increase significantly as well. So, and here the BIPV is installed on only 2 elevation. They study the shadow analysis and everything, because Seoul is located in the northern hemisphere. The nice thing actually, they angle the facade. The spandrel is angled 30 degrees towards the sun to maximize the collection of the lighting, but the vision was angled 15 degrees toward the ground, and by doing this one, minimize the amount of direct sunlight, radiation, and glare, while maximizing the view as well. This is what the architect do for the building. The building also have a very expansive rooftop atrium garden, which contribute to the solar energy for the building as well. In here, another example is this building, Tampines Grande in Singapore, with Manhat facade was involved. In here, we designed the integration of BIPV to the facade. And here, BIPV was installed in the roof, on the facade, in the spandrel area, and it contribute the power up to 107 kilowatt to the building. But this one is a couple years back, and this one is the first building that received the LEED Gold in Singapore. Recently, we have another project in Jakarta, and for this one, our involvement is not only doing the integration of BIPV but to the facade, but we also study the BIPV itself. And for this one, actually, the client has intention to have innovative design in their building, and one of it in the facade. Hence, they design to have BIPV integration on the facade. The building have not been built yet, but still under study. Will be built early next year. And for this one, the building is very small, only 25 story, considered small. And the BIPV only installed on the facade. There is no BIPV on the roof because there is no space on the roof. And in here, the BIPV was installed in the spandrel area from level 3 to level 25 and on the crown level. Because we have a very limited area, what we first need to study is we have to study the extent of BIPV panel, where the BIPV can be installed. In here, with the architect and the client, we managed to have 6,800 BIPV panel. And the second, what we need to study is we conduct a shadow study. This one is very, very important for the building located in city or dense area. If you see the red building, which is the project, is located nearby much bigger, much taller building. Another that we have to study is irradiance analysis to understand the energy received from the sun. In this study, we will understand the applicability of the BIPV, power generation analysis for each area, for east, west. In here is the power generation from the spandrel glass, power generation from the crown area, also every single elevation. And the last, we study from the commercial or financial issue, investment, in order to understand whether this BIPV is feasible or not. At the end, for this project, the total power contributes is a lot. If you compare to the previous one, is 7 times. The reason because of the technology, 750 to 800 kilowatt power, reducing carbon dioxide 324 tons per year, equivalent to the plant 17,000 trees, a lot. This hotel is located in a lot of trees. I'm sure that it's not more than 17,000 trees. So you can see the impact of this one. And the good thing for the architect, you can see, the top one actually is BIPV. You don't see dot dot, ugly dot dot again, but it's very nice. Looks very close with the lower one, which is sufficient glass. This is the thing that very important from the architect since the day one. They want to put the BIPV, but they want to have consistent look on the facade. Another characteristic, the last one, is probably recycled facade material. This one is not many, but one of the extreme example is this building in Czech Republic. The owner is furniture factory, and he used a very unique unused chair as a sun shading. Very unique. Couple years back, I went to Bali. Anybody went to Bali before? And I was impressed with this potato head building designed by Oma, architect from Netherlands. And the facade is very unique. But today I'm not talking about the facade. What struck me, what interesting me, is this one, the sun shading. After several research, the sun shading is under the glass. After several research, I found that actually this sun shading is made from woven plastic, made of mineral bottle garbage. And the unused, this one. So the unused garbage could be used and recycled to very unique and impressive material. However, if we want to use this one for the massive product, for the larger project, more R&D have to be studied. I hope that this presentation can enrich us, and if you don't remember all that size, you just remember this one. As a client, don't be afraid to be the first one. Thank you very much.
Xin được cảm ơn phần trình bày và chia sẻ đến từ ông Timothy Soebroto. Thank you very much, Mr. Timothy Soebroto, for your presentation today. Kính thưa quý vị, và tiếp nối chương trình, xin được mời toàn thể quý vị chúng ta sẽ cùng lắng nghe và theo dõi phần trình bày liên quan tới chủ đề, đó chính là cách sử dụng nhựa ETFE mang đến hiệu suất cao, gọn nhẹ, hiệu quả và bền vững về kết cấu cho lớp vỏ ngoài của tòa nhà, thông qua phần trình bày và chia sẻ của Mr. Matthew Penrose, Phó Chủ tịch điều hành của Vector Phoitech. Ladies and gentlemen, for the next presentation, please enjoy the presentation from the speakers, Mr. Matthew Penrose, Executive Vice President from Vector Phoitech. Please welcome.
Thank you. Good morning. Welcome to our presentation on ETFE building envelope technology. So let's start. What is ETFE? ETFE is an acronym, ethylene tetrafluoroethylene. And what's critical is that it's not from petrochemical. It is not oil-based, it is mineral-based. So it's sustainable, it's recyclable, it has good fire properties, it's very good with UV. So all these things are associated with fluoropolymers. That was a project, probably one of the most selfied pictures before COVID at Chengde Airport, the Jewel. Now, ETFE's been around a long time, about 80 years. And it was our founders who took ETFE from the space industries and aerospace and brought it in to the construction industry and architecture. Now, how does this work? It's a simple principle. 2 layers of ETFE inflated with normal air, and it's that air that gives the strength, gives the unique shapes, the high thermal performance, but critically, all extremely lightweight. Now, if you looked at an ETFE system from below, you would see these ETFE panels welded at the perimeter and fixed into an aluminium frame or a mullion. The only way you know it's ETFE is because in the corner you might see an inflation pipe. And from above, exactly the same, like giant window panes, and those small wires are typically what we need for Europe. They're anti-bird wires. And for you facade consultants, just to note, yes, ETFE is lightweight, but it's watertight, it's airtight, it allows for thermal expansion, it allows for structural movement, and it has a secondary drainage channel. So it's a very advanced system. We also have a single layer system where instead of the air providing the strength, it's actually cables. And this is good for canopies and linkways where you just want some sun and rain protection. Now, is ETFE strong? Yes, it's lightweight, but it can bear 400 times its own weight. So this was from 20 years ago, during the Eden opening, and it's just to prove that ETFE can not just take high loads, but the loads can be distributed and shared across the cushion. So don't worry about using it in typhoon locations, hurricane conditions. It all works. Now let's look at some of the most famous projects we've done. The Beijing Water Cube is currently the largest ETFE-clad building in the world, about 100,000 square meters. And the ETFE is about 7 meters in diameter. Now what's interesting is the ETFE is a double skin. So the outer facade roof is in ETFE, and then the inner finishes are also clad in ETFE. One of the few Olympic buildings that makes money. It's a very big tourist attraction. And also the practice pools were converted into a water theme park. Now, the largest building we're building now, and I'm not allowed to show you photos, it's 120,000 square meters. It is a botanical gardens called King Abdullah's Gardens in Riyadh. And I hope to share this with you soon, but it's there to protect the people and the plants from 50-degree summer heats. And one of the most famous projects, obviously from Europe, is the Eden project. These domes were opened 21 years ago now, and at the time were hinted at the 8th wonder of the world. They are almost 55 meters high, 100 meter wide, 200 meters long. Now, with a lightweight, flexible facade, in this case, they're almost 8-meter hexagonals. You also get very lightweight and efficient steelwork. And today, steel has never been higher. So the savings using ETFE are often saving the budgets for many developers at a time when costs are rising. Now, this was the largest private real estate project in US history, Hudson Yards, and the developer wanted a showpiece. So he has the entire building envelope, telescope in and out, to double his convention space, to allow for a lot of flexibility in his events, but really it's just for the show. He wants people to talk and notice his project. We don't just work with architects and engineers, we work with clients direct and people like Disney Imagineering. This is in Shanghai, Tron, a 6,000 square meter complex canopy. If you imagine what else could do this, what could form three-dimensional, give you a lightweight steelwork, give you a daytime identity, and also come to life at night. So this is what's quite unique with ETFE. Because it's a cushion, once you put light into it, it glows. So in the day, you have this daytime identity, the prints are silver, and it protects you from the sun. And at night, simple lighting, that ETFE comes alive. Very important for retail and leisure projects. Now, we're also very environmentally friendly. This is the first LEED Platinum transportation building in the US, and largely because of the ETFE is the lowest carbon footprint of any of the transparent materials, also sustainable and recyclable, but also we could reduce greatly the weight of the steel and the supporting structure. As I said, in the daytime, the prints are unique on the ETFE. It makes the building appear solid, and it's shading you from the sun. And at nighttime, suddenly the building becomes transparent, just with simple lighting. So I want to talk about different buildings by sector. This is obviously, ETFE is used in facades. This is a 15-story luxury car vending machine. And it's full of Lamborghinis and Ferraris, and you press a button and the car comes to you. But it's also become a very big marketing event. Okay, move on. Come and see us later, we can show you this. Really nice facades. Now let's move on to airports. We do a lot of airports and transportation buildings. This is Changi Airport. We've done, this is the jewel that connects 3 of the existing terminals and is a sort of nature-themed shopping mall. We did the drop-off canopies outside, but also in the middle is that image I showed you earlier. It's the world's largest indoor waterfall, and right at the heart is a 12-meter wide ETFE cushion. You can imagine it's almost the width of this room. And all of the drop-off canopies as well. The Beijing Second International Airport, all in single-layer ETFE when you arrive. And in Cebu, probably some of the highest wind loads we've ever had to use, over 300 kilometers per second, because this building itself would be a shelter. And it was, they had very bad, I think it was Typhoon Odetta, which really made havoc in Cebu. Didn't touch the ETFE because it can just flex in the heavy winds or if there's flying debris. We do a lot of stadiums. This is Singapore, National Stadium at Singapore Park. Now, the ETFE is a 20,000 square meter moving roof, which has integrated 20,000 LEDs, so it also becomes Singapore's largest flag. They use the ETFE because it saved thousands of tons of steel in the supporting structures. We also do a lot of renovations to stadiums. So this is Amsterdam's largest stadium, and we were able to add a whole new facade and a link bridge and a view over the city without any structural reinforcement to the actual building itself. Stadium stayed open, roads stayed open, and over a course of a few weeks, we transformed the whole stadium. Now, we do a lot of high wind load areas. This is Ocean Park in Hong Kong. This is their new all-year-round water theme park. And in areas, the wind load was up to 5 kPa, or 500 kilograms per square meter. We were one of the first people to bring in a no-truss roof. If you go to Hong Kong, everywhere's trusses. So we did the lightweight design, and the ETFE cushions are about 3 meters wide, about 25 meters. They also have 40 integrated smoke vents. Often smoke vents are very unsightly, very ugly. Again, all clad in ETFE, so when it's closed, the whole roof looks consistent. Now, this is our latest project in construction in Manila. It is a new concept of shopping mall for the Philippines. It's naturally ventilated, naturally lit spaces all in between the air-conditioned malls. So these were the renders. This is the work ongoing, about 300 meters long. And in the corners, the mock-up we're just doing for the lighting. That's just simple strip lights, LEDs on the steelwork. And you can imagine what that's going to look like when it's finished. Again, massive wind loading. And we've managed to do it all with our lightweight engineers without trusses. Now, moving on, we do a lot of leisure. This is Korea's first integrated resort. And really, the ETFE's here in the winter, it's open. It wants to collect the heat to keep you warm. And in summer, the opposite, to help keep you cool. But the real future, this is Center Parcs in France. And it's all about that long-span glulam structures. This is truly going to your carbon neutral or beyond it. Resorts World in Singapore, so this is a $5 billion integrated resort, 25,000 square meters of ETFE to keep the people moving and shopping. That's what this is for. It's there to protect people, but at the same time, make sure they're spending 24 hours a day. And again, simple lighting, they have a lot of themes at night. And even the Universal Studio, where the ETFE is used slightly differently. It's themed to match the zones that it's in. American Dream is a Nickelodeon theme park, and on the left was the render. This is still America's largest indoor water pool. Education, ETFE is used a lot in this part of the world to protect the children from the sun, UVA, UVB light. So all of the breakout areas, the play areas around this school, which is the world's largest kindergarten in Singapore, is there to protect the children. Parents don't have to worry. Shopping malls, we do a lot of retail. If you go to Kuwait, there's only one place you go, the avenues. We've done 117,000 square meters of ETFE over 4 phases. And the ETFE is there to keep you cool. And the theme is a city, obviously, within the actual ETFE. And right across, ETFE used in all different forms. Now, the ETFE will keep you cool, but one of the critical things in Kuwait, sandstorms, some of the worst sandstorms in the world. And the reason they keep using the ETFE, here's an image of glazing on the top, and on the bottom's ETFE. Because of the non-slip surface of the ETFE, they don't need to go and maintain and wash all the sand off the building. Obviously, just taking that a bit further, a mixture of glulam beams, twisted steel, and the ETFE is wrapping around. And again, solid in the day, protecting you from the sun, and a beacon of light at night. We do a lot of work. This is a big mall with IKEA in Malaysia. Now, the shape of the roof is not just to look good. It helps promote movement of the air. There's parking all along from the vehicles, and it helps ventilate and cool the space. So let's get to some of the technicals. This is Clarke Quay in Singapore, coming up to about 20 years old. We're upgrading this as we speak. Now, how do we inflate this system? I said it's full of air. This little box there, the size of a suitcase, inflates that whole roof, 1,500 square meters. And inside, it's very German. It's fault tolerant. Everything has backups. If one blower goes down, a second one overtakes. And we inflate the ETFE to 250 pascals. If the air escapes, the system tops it back up. So most of the time, the inflation system is off. ETFE is actually transparent. So this is a view from above and below. You can see the prints on the top are reflecting the heat and providing shade, but on the underside, they're nearly visible. They're just a tint. So we can change the intensity from medium, light, dark, and the shapes to change the thermal performance. And then we have all of your G values, solar heat gain values, all detailed. We can change the number of layers in the ETFE to change its U value. 2-layer, similar to double glazing, 3-layer, triple glazing. But each layer is only 1 kilogram. So we've got 95% less weight than glazing. We can play with the colors within the cushions to form shapes. We can add color to some of the ETFE to again add more contrast. And longevity, this is our first building on the left, almost 40 years old. We've took samples, it hasn't changed mechanically or chemically in 40 years. So the ETFE didn't age over a 40-year period. The surface is self-cleaning, so under the action of rain, the top surface will self-clean. And in fire, remember, this is not a plastic, it's a fluoropolymers, which are incredibly well behaved. The ETFE moves away from the heat and self-extinguishes. No drips, no smoke. It actually makes a smoke vent. We have all of the testing. We're on the product listing schemes in Singapore. We have test certificates from all over the world. Obviously, a lot of American code is followed in Vietnam. And critically, this is truly sustainable. And we're able to give you all of the LEED certificates or BREEAM or whatever you're using to help you with your publications. Just a quick, keep going. I just need an extra minute here. So this is a quick discussion about how we do our jobs. So this is in pavilions, 7,000 square meter canopy. This is what the architects gave us. This is what we work with. We design, supply, install, and maintain. So that's our render. That's reality. We did the full scope, including the steelwork. You design ETFE just like glass, steel, or concrete. You design to the local code, to the worst case load combinations. We develop the structural systems, look at the structural analysis, built, in this case, using the tower cranes. These are built-up steel beams. And we actually install the ETFE on safety nets. In this case, these are the largest, longest ETFE cushions in the world. And that's the finished product. Thank you very much.
Xin được trân trọng cảm ơn phần phát biểu và chia sẻ cũng như trình bày đến từ Mr. Matthew Penrose, Phó Chủ tịch điều hành của Vector Voitech. Kính thưa quý vị đại biểu, quý vị khách quý, Vector Voitech là một trong những đối tác của chúng tôi tại chương trình ngày hôm nay cũng như các hội nghị khác. Vì vậy, nếu như quý vị chúng ta có bất cứ những câu hỏi, những thắc mắc nào liên quan tới Vector Voitech thì xin mời quý vị chúng ta có thể tham quan booth của Vector Voitech tại triển lãm ngày hôm nay cũng như đặt câu hỏi trực tiếp đến cho ông Matthew Penrose cũng như những người cộng sự của ông tại phần networking section. Ladies and gentlemen, once more down, thank you very much, Mr. Matthew Penrose, for your presentation. And as you may know, Vector Voitech is one of our partners for this conference and other conference, and especially if you have any concerns or questions related to Vector Voitech, please feel free to ask the question and contact Mr. Matthew Penrose and his team at the Vector Voitech booth in our exhibition. Thank you. Kính thưa quý vị, và tiếp nối chương trình, xin mời quý vị chúng ta sẽ cùng lắng nghe và tìm hiểu về chủ đề với nội dung đó chính là kết cấu của tích hợp kiếng và thép có dạng 3D thông qua phần trình bày và chia sẻ của Mr. Andreas Geyer, Giám đốc điều hành của Aelst Đông Nam Á. Ladies and gentlemen, for the next presentation, please welcome on the stage speaker Mr. Andreas Geyer, the Managing Director of Aelst Southeast Asia. Please welcome.
So, good morning, everybody. It's really good to be back in Vietnam after so many years. I think last time it's 4 years ago I've been here, and I really, really missed it. So today I am sharing with you 2 non-compromise projects which we did in New York recently. I purposely chose these 2 projects because they are absolutely top-notch technology and complexity. So I think it could be quite interesting to see what's happening on the other side of the planet there and to what extent people go to finish and to do their projects. A quick look into what we do in general. This here is a project we finished in 2016 in Melbourne. the Chatstone Shopping Center. It is a steel and glass grid shell project. Seele itself is a company founded in 1984 in Germany, between Munich and Stuttgart. I think we are, of the global player in facade, we are one of the smaller ones, maybe even the smallest. We have approximately 300 million euro turnover a year. Of these 300 million, around 10% are made here in Southeast Asia. So here you see our dependencies all over the world. As I mentioned, it's a Germany-based company. Here in Asia, we have 4 companies. One is in Hong Kong, another one in Thailand, Malaysia, and in Singapore. I'm stationed in Singapore. We have another branch in India and another branch in Australia, which is all managed from Singapore. So let's have a look what Seele is actually doing. I would say it's business as usual. We are a facade contractor. What makes us maybe a little bit different from others is here the R&D, because we indeed do a lot of independent research and development. So we are really looking into developing our own products and not just do what the architects are asking us to do. We come up with our own proposals, our own product ideas, which we then distribute in the market. So, and from there we go into the engineering and design, project management, testing, manufacturing, logistics, and installation. Now our projects are very, very special and very complex. So most of these subsidiaries you saw here on the map are not big local companies, because for the complex projects we need to do the engineering in our European headquarters. Now this is where the engineering know-how is, and this is where we keep it. And our projects are not very regular in one country, so we are jumping from country to country all the time. I'm currently doing projects in India, Malaysia, Singapore, and Australia. So I could impossibly open a new company there with all the engineering and so on in these places. So we are working very centralized from our headquarters. Also the testing, manufacturing, logistics, and installation is to a large degree managed from the headquarters and also executed. But we also buy from third parties, obviously, but a certain degree of manufacturing we do obviously in-house. So again, to the left top, we see the Chatstone shopping mall. On the right-hand side top, you see Icon Siam in Bangkok, which we finished there in 2018, around 6,500 square meters of supersized glass panels in a jagged arrangement on the facade. On the bottom left, you see a cable truss system. We also do a lot of cable truss systems. This one is also in Bangkok. You can see it's a very minimized sub-construction here in this triangular glass area to do a kind of a slimline design. We call it slimline design, and you also will recognize we don't use the spider technology here anymore. We try to reduce the fixing technology to a minimum. But I come to that later. On the bottom right, you see a unitized facade. That is the European Central Bank. Double skin facade, extremely high specs. We are not really offering this kind of unitized facades here in Asia. We are simply not competitive here. So this is for countries where they have very, very, very high specifications, and obviously the price ticket is accordingly high then. So now let's have a quick look at a project that's 33rd Street Penn Station entrance in New York. It's a cable facade, as you can see, or a cable construction. It's the entrance to a MRT station there, to a subway station. And let's have a look a little bit into the technicalities of that project. It's a 105 tons of steel construction, 277 square meters of cable net, 13 meters high, and 139 double curved glass panels. Here you see how the whole thing is built up. On the bottom, we have the 45-meter edge beam. We also call it the horseshoe. That is this part here. Now, then we have the hockey sticks here going up. Between the hockey sticks, we have a cross beam. On the cross beam, we have a crown. That is basically the steel components we are using there. Now, for a project in New York in such a exposed situation and place there in New York, your program is extremely tight. You don't have a lot of time to install that. You have to be through with it in a couple of weeks. So you cannot start solving the problems on site. You have to solve all the problems before you come on site already. And you need to know what to do on site exactly and how to make sure that you can finish in 3 to 4 weeks. Not easy. So then here we can see the cable net and we can see the glass. Glass is anti-clastic shaped glass. You can imagine that like a saddle of a horse in 2 directions, curved. Quite expensive glasses. The point fixing here, as I mentioned already, we don't use the spider style of glass fixing anymore. This is 1990s, 2000s, but nowadays we always try to reduce it to the minimum. So here the saucer, you see we keep the glass in its corners, in the 4 corners of these glasses here, and the saucer has a diameter of only 180 millimeter. This is pretty small if you consider that the whole construction is actually quite flexible and it's moving. And you have to avoid that there is any stress in the glass that could lead to glass breakage. So you really have to know exactly what you do there, how your construction is behaving, how it's moving in the installed position. We'll come to that. Now let's have a quick look into the steel fabrication. We fabricated that steel in our workshop in the Czech Republic. The Czech Republic has a very old steel tradition. They are very proud of high quality, super precision steelworks. And I think I can say that this workshop in the Czech Republic is at the moment the most advanced and sophisticated workshop for architectural steel on this planet. Here you can see the fabrication of the spandrel panels of on the left-hand side. It's huge steel panels that are curved and twisted at the same time, and that all to extremely minimal tolerances. And then here in the background you see the hockey stick I mentioned before. That's the 2 arms that are going up in that construction. This is a picture of the crown, the holes you see here. That's the holes where later the 12 cables will be fixed into. And then after that, we are welding other components to that crown, and then it is coated, and here it's already ready now for the delivery. So let's have a look at the pre-assembly. I just mentioned that it's quite tricky to install that all in a super compressed program. So what we have to do, we have to test it all, and we have to be sure that it works before we go even on site. So that was a little bit of the glass testing here. That's not so important now. But this is an interesting one. In order to achieve this time schedule, we cannot afford to start welding on site. So we have to go there with 0 welding, which then means again we have to bolt. But the forces we have to take there are so immense that we cannot just go with normal bolting. So what we are doing here, this is the bolt that is connecting the horseshoe to the hockey, to the hockey stick upwards. And we are testing it here. What we are doing here, we are penetrating 2 steel elements. We put through the massive bolt, and then we are extending with a hydraulic system the bolt to a length where we know now it can supply the pressure that is necessary to put these 2 steel components together. So we are hydraulically expanding the bolt, and then we are closing the nut against it, and then we release the hydraulics, and you can be sure you have exactly the connection force that you need for the structural integrity of the system. Now you see here the pre-assembly. We do the pre-assembly also in the Czech Republic. On the left-hand side, you see the cable net is already coming in, and on the right-hand side, we are already pre-stressing the cables. Now, another challenge of that thing is that all these nodal points here need to be 100% on their position. Otherwise, the glass will not fit, or you will get stress in the glass and you have potential glass breakage. So we are using a 3D laser tracker here, 3D laser tracker in order to bring all the nodal points perfectly into position. After they are in After they are in position, we are marking the cables, and then when we are in New York for the installation with the markers on the cable, we will know exactly how to position them on this cable net to make sure that the geometry is achieved. But obviously the geometry can only be achieved if also the stress in the cable, the pre-stress in the cable is exactly the same as we had it when we built it up there in the Czech Republic at the first time. So we need to know exactly what force do we have into this cable system. And here you can see the the stressing system there. So we also use hydraulic cylinders. And into these hydraulic cylinders, or below the fixing point, into the cables, we have sensors inside. And these sensors, they can give us the exact value of the tension in the cable. And these sensors, they can be read by computer. So we can exactly reconstruct what we had in the Czech Republic. And by that, we can be sure that the geometry is 100% the same and the glass will fit. And this monitoring system is also now active. It's permanently on. We can permanently monitor the values in our headquarters in Germany. So in case there is an earthquake or anything like that, and there might be a certain movement in the construction, we can live see what is happening to the tension in the cables. And if it's necessary, we can go on site and correct. So it's a permanently monitored system. So installation. Here you see the hockey sticks coming on site. Then here the crossbeam is coming in. The crown is coming on top. The cables are coming in here. The cable stress, as I mentioned, everything was prepared beforehand in the Czech Republic already. The glass is coming in and the A-frame is glazed. That's the second layer of glass here. And then here we go. And all of that was installed in the record time of approximately 4 weeks. You have to imagine, on site. Couldn't be faster. Then after that, the balustrade cladding came in. That is below the horseshoe, where it's going then down underground here with the escalators. And later, New York was then laminating the map of New York onto these balustrade claddings there. You remember the balustrade cladding was the huge steel panel I showed in the beginning in the fabrication in the Czech Republic. And this is the result. 33rd Penn Station, New York. Sorry. And here the structurally most challenging point. Now this is the one where we had to use that technology with the bolt that was pre-stressed and then fixed with a counter nut. A very quick video to that. The welding in Czech Republic. You see how precise those components have to be manufactured. In most of our projects, we have internally agreed on a tolerance for this kind of steel companies. From whatever point you measure to whatever other point you measure, the tolerance shall not be more than 1 millimeter. That's kind of an internal thing we have going on there regarding the tolerances. Here the hockey beams, the pre-installation in the Czech Republic. The pre-stressing of the cables, nodal points. So now let's have, we have another 5 minutes left. Let's have a look in a second project in New York, which is similarly ambitious, I would say. This is the Moynihan train hall station, the central train hall station in New York. Here we constructed all these 5 grid shells here, this one here and those 4 here. Steel glass construction again. In this case, the glass is not directly on the steel, there is an aluminium subframe in between. So it's a steel aluminium glass construction. Here an impression from the inside. To the right-hand side, you see a bit of the assembly here for these glass elements, but we will come to that. So we have 1,116 square meters of freeform steel glass roof, 3,384 insulation glass units, 670 tons of structural steel work. On the left-hand side, again, we do the steel because it's a super high precision steel. We do it in the Czech Republic and we ship it over to the United States. So you can see we already pre-assemble it to ladders. Now it's already pre-assembled components that are later lifted then on the scaffold, on the propping. On the right-hand side, you see the preparation of the aluminium units for the semi-unitized glass system that is later then on top of the steel. Here you see the glazing of these aluminium frames. Why do we have now here aluminium frames, and why don't we put the glass directly on the steel? On the Chatstone shopping mall that I shared in the beginning, this complex 3D roof in Melbourne, here the glass is directly on the steel. But here in New York it's not possible because we are dealing with a huge temperature difference of nearly 70 degrees from winter to summer. So the whole construction moves dramatically, and this movement has to be taken somewhere. So we take it between the glass and the aluminium to keep the glass itself, between the steel and the aluminium to keep the glass free of stress. Here you see the ladders then going to the United States. On the right-hand side, you see the pre-framed aluminium elements going on site. Then you have here the space scaffold, and on top we have the propping. Then the ladders are coming. They are pre-constructed to the whole thing. And then the glazing is coming in. Sorry, too fast. Never mind. A little bit of the technical background. I mean, people always ask, why is this kind of construction so expensive? I mean, there are good reasons. You already saw it in the previous project. There's a lot to be done before it even comes on site. Here for that project, it's much more even or much worse, because now we are talking about a concealed space, so we also are dealing with these huge temperature differences from inside to outside. And we have to make sure that everything works properly. So here you see the two test mock-ups in our performance mock-ups that we built up in our headquarters in Germany. And the one to the right-hand side will then later be encapsulated in a little house, so to say. And the outside and the inside will have different temperatures to check how the whole construction is behaving. So here you see the list of the tests that we are doing. We have load-bearing test first on 50% of the dimensioning load, then thermal cycling, condensation, air tightness, water tightness dynamic, load-bearing test 100% load. Then we have asymmetrical load test, load-bearing connection to the building structure, and then load-bearing test on 150%. All these tests have to be done. It took 5 months to do the test. Here, just to show you a little bit about the thermal testing from minus 18 degree to plus 66 degree, while on the inside we have permanent 24 degrees. We have different tests running there, and then you have to build that house, that housing around the test mock-up. Here are the generators to produce the heat and the cooling. And that is then how it looks on the inside. Now we are doing a cycle test, so we are going up with the temperature, go to minus temperature, go to plus temperature. We have 3 cycles, while on the inside of the thing, the temperature remains constant. And then we have to make sure that along all these tests, there is no mechanical damage to the system, no water leakage, no other stress in the glass or whatsoever. So there are also a lot of mechanical sensors to the system to check that permanently. Then we do the wind testing and everything that is related to it. And then this is the final result, finished just over a year now. Again, let's have a quick look in how we did it. That's the headquarters in Germany. That's a view into the engineering area, and in the background you can see the fabrication area there. In Germany we do mainly aluminium, whereas in the Czech Republic we are doing the steel and stainless steel. So here in Germany they are preparing these pre-manufactured aluminium frames with the glazing. Here is the pre-assembly. Also aluminium welding, of course, yeah. And each and every of this element is unique. There's 0 repetition on the project. It's also important. So every element is different. You can imagine what kind of a logistics is behind that to put all these pieces there together. Tens of thousands of different pieces. In each of it has its specific place in the project and doesn't fit anywhere else. So time is over, unfortunately. I don't know, can we finish the video another minute? Half a minute? Just a small moment. No, it's too long. Maybe we stop it. It's another 2 minutes, I think so. Ken? Okay. So here you see the pre-manufacturing of the letters in the Czech Republic, the nodal points, 3D engineering. And now we go to the installation. The glass sucker lifting the glasses. So these things will be fixed now on the steel construction. And here you see it's not a flat surface. No? It's the elements are also three-dimensional here in the surface. Now the ceiling, the last thing to do on every project. And here we go. That's the final result. So thank you very much, everybody, for your attention. I hope it was interesting. Thank you.
Xin được trân trọng cảm ơn phần trình bày và chia sẻ đến từ ông Andreas Geyer. Thank you very much, Mr. Andreas Geyer, for your presentation. Kính thưa quý vị, Aelst cũng là một trong những đối tác quan trọng của chúng tôi trong chương trình hội nghị ngày hôm nay. Vì vậy, nếu như quý vị chúng ta có bất cứ những câu hỏi, những mối quan tâm nào dành đến cho Aelst, thì xin mời quý vị chúng ta có thể đặt trực tiếp câu hỏi đến cho Mr. Andreas Geyer tại booth của Aelst ngày hôm nay tại quầy triển lãm. Ladies and gentlemen, Aelst is also our partners at this conference and other conference, and especially if you have any concerns or Q&A section, please feel free to ask Mr. Andreas Geyer or his team at their booth at exhibition. Kính thưa quý vị, và như vậy là chúng ta vừa rồi đã khép lại ở phiên đầu tiên trong buổi sáng ngày hôm nay. Và trước khi chúng ta cùng nhau chuyển sang phiên thứ hai trong buổi sáng ngày hôm nay, thì xin được mời toàn thể quý vị chúng ta sẽ nghỉ giải lao trong khoảng thời gian là 30 phút để có thể thưởng thức tiệc trà cũng như tham quan triển lãm và các booth ngày hôm nay. Ladies and gentlemen, before we coming to the second section in this morning, please feel free to enjoy the networking section and the tea break at the exhibition. And please have a look at the exhibition, especially our booth. Thank you very much. Kính thưa quý vị, và cùng với đó xin được mời cả 4 vị diễn giả. Trong phần đầu tiên, chúng ta sẽ nán lại phía chương trình ngày hôm nay để cùng đến với phần tri ân và chụp hình lưu niệm.
Lava Architects. I know it's a tough spot after the coffee break, but I hope we're all coffeed up. So while people are coming in, I want to talk a little bit about our company, of course, but I also want to talk about facades as the soul of the city. So Lava is an architectural company founded in 2007, and we have offices around the world, in Germany, in Sydney, Australia, and for the last 7 years now in Vietnam, in Ho Chi Minh City and Hanoi. We always like to think that architecture is about nature and technology, and if you follow the principles of nature and implement latest technologies, then you have a chance for contemporary architecture. This idea of the facade, the window to the soul of the city, comes from this thought that architecture around the world starts looking a lot the same everywhere. And architecture really should respond to the culture, to the climate, to the people, to the materials available, and kind of talk of its place. And so, similar to the human eye, which is kind of the window to the soul, we like to think that architecture also gives you a window into the history, into the past, into the future, into ancient civilizations maybe, into business, into politics. Hong Kong as this amazing kind of cosmopolitan melting pot of cultures. Beijing is this amazing, emerging, now fully emerged city that came out during the Beijing Olympics. And thinking about how architecture in Switzerland, of course, is completely different to architecture elsewhere. It has to respond to the climate, has to respond to snow. Architecture in the desert has to respond to extreme heat, so you have different types of material, different types of living. Architecture in the Antarctica can't be the same as architecture in Berlin. And Sydney, where my office is based, of course, we have a beautiful climate, and the architecture is all about natural ventilation, and systems like this breeze facade by Renzo Piano come out of that, or these ventilated roof gardens. Or if you know this project by Jean Nouvel, as you may know, in Sydney, the sun is sort of on the wrong side. Sun is in the north, and Jean Nouvel kind of counteracted this with this deflector, which essentially collects the sun and reflects it back into the courtyard of this development. Framing beautiful views, Bondi Beach, and we had some speakers from Singapore. It's a great example how architecture can really reflect the climate, the temperature, and the kind of, also the politics of the city, where Singapore is declared a green city, and by official decree it has to incorporate facades into landscape into facades. In the Arabic world, of course, the sun is very hot, it's very dry, so it's all about shade and creating a comfortable indoor climate. At the same time, I think that this concept of this high-rise tower with the curtain wall facade, the modernist kind of extruded tower, is a concept of the past, and we need to embrace technologies that in all other fields of life seem to have come into play, but not so much in architecture. So learning from nature, in structure, in facade, learning about systems in nature, translating into building systems, and learning from materials, from space industry, from Formula One racing industry, and materials such as ETFE come right out of space industry. That combined with new technologies, 3D printing, robotic fabrication, and eventually flying robotic fabrication should eventually lead us to completely new forms of architecture and completely new results, an architecture that speaks of its time and of the future of humankind. This project has comes up in every facade conference. I was very fortunate to be a project architect at PTW Architects in 2003 to 2008. And this project kind of epitomizes this idea of nature and technology, breakthrough facade materials, learning from microbiology, translating that into a giant steel structure of hundreds of thousands of steel members, clad in a lightweight membrane that is thinner than anything else imagined before, supported by air, and giving you a complete new look and a complete new space, which is what architecture is all about, creating spaces for our times. And this is also the first building, to my knowledge, that can change its appearance based on a text message. So a light art installation that changes colors based on the feelings of the citizens of Beijing. Since then, we worked on many projects, and I just want to show a couple of them. This is the Office of the Future for the Green Climate Fund in Bonn, Germany. And in the past, you used to do buildings like the ones in the background, sort of a square block with tiny little windows, what I call design by Excel spreadsheet. So you have offices, 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 coffee machine, offices, offices, offices. And that's the design. In this design, we try to bring nature into play, we try to bring movement into play, we try to encourage people to move around between levels and to really embrace new technologies, new forms of working, at the same time as new building technologies with energy-producing facades, etc. This project in Jeju Island in Korea is a very large resort project on a volcanic island. And the idea is that actually the landscape is a very big part of the facade and the identity of the building. So using these terraced facades with Korean kind of cherry blossom landscape all of a sudden transports you to Korea, even in this image. Similar project in Malaysia for the Forest City, which you may also know about, a very large project where the idea is that essentially from every apartment you can see nature. The building is complete, or the whole development is completely wrapped in nature. There's a lush kind of rainforest park in the center, and so from the apartments you either look out to the sea or you look into the rainforest. And talking about ambitious projects, you may know this one as well, which we started in 2011, the Hainan Ocean Flower Project. And so when we started this project, 11 years ago, we didn't exactly think this was going to happen. But then slowly the client started to dredge the sea and build this amazing flower-shaped island. And build, and indeed, 10 years later, it was complete. Just before COVID, and it's one of these sort of miracles in architecture and master planning where you have an ambitious client, maybe a little bit over-ambitious, in a situation, as I said, China kind of rising from its past to this high-speed kind of capitalist future, building this within 10 years. We recently celebrated the Dubai Expo, where we designed the German pavilion called Campus Germany. And the German pavilion is kind of about this idea of responding to climate and responding to space program. It's a number of kind of stacked internal spaces which house the building exhibition, and it's wrapped into different kinds of facade fabric envelope that allow you different climatic zones, allow you natural ventilation as well as air-conditioned spaces or soft-conditioned spaces, as we call them, and most of all, create an internal circulation space and an experience for the people. So this is looking through the atrium, and a quick section through the atrium is naturally ventilated and naturally lit, and ETFE also plays a role in the facade and operable elements that allow the building to open up in the cool evenings. The only problem with this building was it was so popular that you had to wait 8 hours to get in during the Dubai Expo, for those of you who have been. A similar kind of project in the Middle East, where we use an opportunity to create a shaded facade with an open internal atrium. So this is in Saudi Arabia. And essentially in Saudi Arabia, people still build glass buildings and glass facades, and then you have an enormous effort in air conditioning to cool down these buildings. The idea here was that the outside has tiny little windows that shut out the sun, and on the inside you have a full-height atrium where all the kind of communication and exchange and natural ventilation happens. So the cores of the building, which are in 99.9% of the buildings in the center of the building, the cores are here in the corners, and they allow for the central atrium and for this pixelated facade, which is built out of GRC prefabricated components. There you see some construction shots. The project was recently completed, but we haven't got the final pictures yet, but you get an idea about this internal spaces. Another project with PTW, and I think Julian is speaking later. So this was sort of my last project at PTW in 2007, where we designed a master plan in Ho Chi Minh City. And I like showing this project because again, maybe 99% of all buildings in Vietnam are square boxes, in particular residential buildings. The concept of this project is a master plan where the buildings are like water drops in a landscape park. And what that does, it creates opportunities for apartments inside to not have tiny little windows, tiny little balconies, but to have full-height glazing and full-height windows that you can actually enjoy the view from. So these are competition drawings from 2007, and this is the build project, was opened in 2015. And you can see that the facade is actually quite a simple facade. It's not super complicated, not super expensive. It's essentially straight up and down glazing. And then you have this recess with a balcony that wraps around with a glass balustrade, and that allows you essentially from every apartment to enjoy kind of panoramic views and step out and enjoy the natural air and natural ventilation. And some facade elements are just simple window facades or just solid facades, but by adding this layer of the horizontal ribbons, which are sort of inspired by water ripples, it creates a cohesive picture. And the second stage of this project has been completed a couple of years ago as well. There's now a total of 6 towers. Another project in Vietnam, Tin Po City, which is here in Hanoi, which we started about 5 years ago with winning an international competition. And the idea of the project was to somehow capture the spirit of Hanoi. And so for us, the spirit of Hanoi is all these tiny little 3 meter, 4 meter, 5 meter wide terrace houses, which have all multiple use. So they have a commercial ground floor, usually a shop, then they have some residential, and quite often they have a roof terrace, which is active and public again. And at the same time in Hanoi, you have these amazing colonial villas, which are these grand kind of French, antique-looking buildings, and they're sort of scattered throughout Hanoi. But at the same time, you have these sort of developments, which is, again, sort of designed by Excel spreadsheet, so you extrude a floor plate as high as you can, and that's the design. And we try to avoid that, break down the building massing into smaller elements. And despite the size, this is a very large project, an entire city block, we sort of managed to break it up into smaller elements. So it's 4 buildings that are terraced and carved out, sort of inspired by maybe the Vietnamese mountains and caves, and overall creating this kind of green, lush, bold and prominent, but more in-keeping development. With the 5-star hotel in the front, with this piano nobile, which is sort of the public area on the 2nd floor, and a public rooftop that combines all the different buildings with each other. And then this front, which doesn't look like a French villa, but it's sort of, for us, is kind of a hybrid of this grandeur of a French villa and maybe the natural flow of Halong Bay Mountains. Another project which is very close here, and some of you are involved with it, Sahvia Facades, for example. This is called DTEC, and it's for a German-Vietnamese company, which for me is quite interesting as a German working in Vietnam. And essentially, the building in the center is an existing building. It's the current DTEC tower. And the competition was to extend the existing tower and sort of complement it with a series of towers for the future of the company. And so our interpretation of that was to create for this family business a series of 5 towers that are all interlinked, all slightly different, but all have a common language. And at the same time, we created these moments, which again, for us are these kind of moments that maybe relate to landscape in Vietnam, these caves, these mountains, and the entrance areas, the valley in the center and the sort of peak, they are the special areas. The rest of the building is a relatively straightforward building, but there's special moments. We sort of call that the 80-20 rule. If 80% of the building is pretty straightforward, you can allow for 20% the memorable moments. Today you would say the Instagram moments, but for the inhabitants, the kind of moments that really make that building special and interesting to live in. These vertical kind of green voids. Similar project also nearby is the Van Phu Tower, actually just 500 meters down the road. Again, very large program, I think 200,000 square meter on 3 towers, mixed use. And the ideas of having this combined rooftop, which is like a lush green, amazing entertainment space, having these sky bridges connecting the towers, and having this amazing terraced podium with waterfalls. And so very commercial project, also of course with timeline and budget and so on, but has these special moments that really make the building stand out from the rest. And I always think the ground floor, the public floor. In a way, that's the interface to the city. That's where people welcome or get welcome to the building, where they first approach it and first experience it. And another project, which is also actually right next to Tianpo City, and an unsuccessful project in this time, the Hangdai Stadium. So we were asked to design a renovation of the Hangdai Stadium, which you all know is an old, little bit tired stadium. And we came up with this idea of this dragon skin facade. And actually my team members from the Vietnam team, they came up with this idea. Hanoi is a dragon city, and the facade represents the scales of this dragon. And at the same time, of course, they're like a lightweight shading structure. They help adding onto an existing building without adding too much weight and without coming out too far into the street, which is very constrained at this point. And talking about stadia, and I'm sorry about all the PDW projects today, but this was in 2007. We designed a stadium for Doha, Qatar. And as we all know, there's currently the Soccer World Cup going on. So Doha, Qatar, we presented this to, at the time it was called the Sports City, Qatar. And then for a very long time, we didn't hear back, we didn't know what was happening, kind of disappeared from everybody's radar until a couple of days ago, where it was the opening stadium for the Qatar World Cup. So this stadium is obviously inspired by a tent, by a Qatari tent. That was the brief of the client to represent their traditional culture, their traditional way of living in nomadic times, and turn that into the greatest membrane structure of all times. You may say it's a little bit literal, and it surely is, but it's actually quite amazing how it translated, including the internal fabrics, which are the traditional Qatari fabrics, and how it sort of represents their culture in a very highly contemporary and modern way. This was the opening, which I assume you all saw. And yeah, so dreams do come true sometimes, and I hope that every project can somehow relate to its culture, to its time, to the economic climate, to its people, and that we can somehow build buildings for places. Talking about dreams coming true, this is the latest dream, which you probably also know. This is a project that is 170 kilometers long, 500 meters high, and 200 meter wide, city for 9 million people in Saudi Arabia. I just thought this would be good to show for a bunch of facade-related people. There's a hell of a lot facade going on here, which I don't think is designed yet. So that's the dream of the future, and I actually finished before time. Thank you very much, and enjoy the rest of the day.
Xin được cảm ơn phần trình bày và chia sẻ đến từ Mr. Chris Bosse, đó chính là giám đốc của Lava châu Á Thái Bình Dương. Thưa quý vị, kính thưa quý vị, một lần nữa xin phép được nhắc lại, đó chính là trong quá trình mà các diễn giả của chúng ta trình bày các bài chia sẻ thì chúng ta cũng sẽ không có phần Q&A section trong quá trình diễn giả chúng ta trình bày hay là sau phần thuyết trình. Tuy nhiên thì chúng ta có các phần networking section cũng như là tea break. Thì xin mời quý vị, nếu chúng ta có bất cứ những câu hỏi, những thắc mắc, những quan tâm nào liên quan tới công ty hay là các phần trình bày nội dung liên quan tới các diễn giả, đặc biệt là liên quan tới các sponsors ngày hôm nay, thì xin mời quý vị chúng ta cũng sẽ là đặt câu hỏi và giao lưu trò chuyện với các diễn giả cũng như những người cộng sự của họ tại các quầy booth. Và một lần nữa thì Quỳnh Trúc muốn nhấn mạnh về sự ủng hộ và hỗ trợ hết mình của các nhà tài trợ đã góp phần tạo nên thành công của chương trình ngày hôm nay. Ladies and gentlemen, I want to mention that we do not have any direct Q&A section during the presentation or after the presentation. So please feel free to contact the speakers or ask your concerns or questions related to the content of the speakers or anything related to presentation in the networking section. And lastly, on behalf of the organizing committee, we also would like to emphasize and mention about the role, the support, and contribution of our sponsors, because without their support and contribution, the event cannot be successfully. And one more time, I would like to send a sincere thanks to the great contribution of all our sponsors today. Thank you very much. Kính thưa quý vị, và ngay sau đây, xin mời quý vị chúng ta sẽ cùng nhau tìm hiểu về chủ đề, nội dung đó chính là vượt xa khỏi nền văn minh hiện đại thông qua phần trình bày và chia sẻ của Mr. Shuichi Ishikawa, đó chính là giám đốc và cũng là kiến trúc của Nihon Seki Global. Ladies and gentlemen, for the coming presentation, I would like to invite on our stage Mr. Shuichi Ishikawa, the Senior Director, Architecture, Global Nihon Seki. Please welcome.
Hello everyone, my name is Ishikawa of Nihon Seki, which is one of the biggest Japanese design firm. Thank you for joining us today. In my session, I would like to introduce the advanced facade of several projects in Japan, overseas, and Vietnam. And I will talk based on the theme of beyond modern civilization and 3 keywords listed on the screen. The screen is same? Okay. At first, I would like to introduce our company briefly because it's related to the theme of this session. Nihon Seki is one of the largest architectural firms in Japan, specializing for urban design, architectural design, and sustainable design. In 1967, when Tokyo was rapidly developing, our firm was established by the group of specialists who designed the Japanese first skyscrapers. And we are still pursuing the advanced design and the technology for the new skyscrapers. In the 1980s and 90s, our firm was deeply involved in improvement of urban architecture with consciousness to environment as a fundamental issue of modern society. This philosophy still continues in our firm as challenging of the sustainable design for the carbon-neutral society. After 2020s, the firm contributes to area design and maximize both spatial and financial value in urban architecture. As market for urban remodeling and global city planning intensified, the philosophy of area design became the common ground for the firm's design strategy. And we work with overseas branches and partner companies to try sustainable design that match the climate and culture of Asian countries. In Vietnam, we are challenging the project together with our partner firm Coninco. We would like to utilize the Japanese knowledge of sustainable design, and I start to introduce the Japanese advanced project at first. This project is Toranomon Hills in Tokyo, and our headquarters is here. This building is a pioneering project in Japan because it integrates highways and buildings. The skyscraper is situated on the main road of Tokyo, which connects the city center and coastal area. The overall shape of the building is composed of gentle curved surfaces which align with the road directions. It is also driven from an aerodynamic design process for prevailing the strong seaside wind. The shape of top is cut at an acute angle for emphasizing the symbolism. It combines various essential functions of new international business center, such as office, conference hall, hotels, and residences. This roof garden is located above the road. The comfortable semi-outdoor space spreads out under the large eaves that reduce the wind speed caused by tall building. This is semi-outdoor grass atrium connecting the entrance and the roof garden level. Depending on the weather and activities, the relationship between inside and outside of the grass atrium can be adjusted by opening and closing the grass door on first floor. The step garden is also on the road that makes use of the slope resulting from the underground expressway. A variety of tree species are planted at the step garden under the concept of biodiversity. The structure of the step garden is also extended into the indoor atrium. On the fine weather days, part of atrium grass wall can be slid open to create a continuous and comfortable inside and outside environment. It provides the variety of environment that meet the sensibilities and comfort of each person. The outer wall is equipped by 400 millimeter width panels which intake and exhaust air. This panel has the We use the wall-through air balance unit for the perimeter air conditioning. The heat exchange, which has the heat exchange function. The airflow system with highly airtight blinds reduces the heat load. In the top of the building, there are chapels, gardens, event spaces, and the bars of the hotel, and various spaces of the hotel are connected by the terrace, not the interior corridor. In the bar, protected by the large glass roof, visitors can feel the gentle outdoor air and panoramic view of the sea. This building provides the rare experience with the nature that stimulates the human senses. Next project is the large greenhouse in one of the biggest parks in Tokyo. This greenhouse is nestled in the greenery of the park. One of the important functions of this building is to create the optimum environment for the growth of tropical plants. Throughout the year, we focused on maximizing the natural light that is essential for the growth. In the winter, we have to maintain the warm indoor space with less energy. In summer, we should use the outside air using the natural ventilation system. The main greenhouse provides ecological environments with different microclimates under a single space. Tropical mountains, tropical ponds and swamps, and arid regions all have different temperatures, humidity, and solar radiation. Particularly, creating tropical mountain area with cool, humid, low insolation environment is challenging. It is located high in the center of the building cross-section. Locally different environment is created in an integrated space by utilizing cool air from underground cool tubes, a mist generator, and a movable shade, which shields excessive sunlight. In cool tube, air is cooled down to about 4 degrees underground and released from the cold air outlet located above the ground. In a special room with a grass screen, endangered species are protected and propagated in an isolated state, and a weak cooling system with a cool tube is used. CO2 emissions are significantly reduced compared to existing greenhouse. The grass walls and greenhouse roof are constructed with thin structural frames to ensure maximum natural light. Another important function of this building is its role as a base for environmental education, raising environmental awareness while enjoying contact with plants. Different microclimates are formed in the single-room space for the continuous experience. It is like a short night street, which passes through dry land, moves through tall trees in tropical lowland, and reaches cool mountains toward the end. The aim here is to create a space that appeals to the physical senses. Another feature of the building, is the harmony with the surrounding landscape. The gentle undulation geometry fits with the layout of surrounding the English-style garden. As described below, this large greenhouse creates the variety of microclimates and rich ecosystem for plants in one space, and it is also beneficial for humans. So next project, we use this idea into the office. This is the headquarters office in Chengde city. Chengde is called the Garden City, has a good climate, and has culture of drinking tea in semi-outdoor environment. There is a green park on the north side of the project. We wanted to make use of Chengdu's climate and culture by bringing in the present cool breeze of the park to create a healthy semi-outdoor workspace. Therefore, we stimulated the wind speed distribution and temperature distribution analysis to take outside air into the whole building effectively. We examined how to open various types of buoys. The most effective method was to open the buoy diagonally. Outside air is taken in from the low front of the building and guided along the atrium towards the upper part of the building. A step garden is planned around the atrium for creating the comfortable workspace. Using the thermal simulation, we analyzed in more detail and created the various thermal environment that worker can choose. We proposed a work style that allows workers to really choose the environment according to their mental and physical conditions. Next project is the suitable student exchange space of the university, and it is rare that people spending long hours in this space. Here, as a first toward ZEV architecture, the thermal environment within the certain range is provided through natural ventilation without complete air conditioning. In Japan, the semi-outdoor spaces that are stripped from sun with wind and rain have been appreciated from the past. We believe that passive environment techniques taken from traditional Japanese or Asian sensitivities can be applicable in modern architecture. It is not easy to set the optimal thermal environment because there is the problem of individual differences. For example, men tend to be sensitive to heat, and women tend to be sensitive to cold. We are trying to aim for ZEV by developing the idea of various thermal environment and location selectivity. Localized air conditioning equipment called spot air conditioning allows users to choose different thermal environment by themselves, solves the problem of individual differences and differences in clothing, and increasing users' satisfaction by allowing their own choices. Low temperature outside air is taken in as natural ventilation, especially at night. Spot air conditioning with a table-shaped outlet is also used to achieve a variety of temperature. This building is based on the idea that the homogeneous thermal environment of modern civilization may not necessarily be comfortable for everyone. This office is located in the center of Shenzhen, next to park on the northeast side. Shenzhen is a subtropical area without abundant greenery, so we want to create a workspace where we could feel the greenery of the park as much as possible. We analyzed the layout and height of the size surrounding buildings in the 3D-dimensional level. At the top of part of the building, we plan atrium space that maximizes the park view. We also provided a stepped indoor terrace in atrium so workers can choose their own favorite places and views. The atrium space at the top expresses the comfort and generosity of the company, and as well as its environmental awareness. The standard floor is intended to serve as a breathing curtain wall to improve health, comfort, and wellness of the workers. We also plan communication spaces in the podium. The workers can choose the location according to their daily physical mental condition. This new government office building for the Supreme People's Procuracy of the Social Republic of Vietnam, completed in 2018, stable and neat appearance is making standout presence in the new development area of Hanoi. Side facades are designed by limited opening area as a result of a consideration of reducing environment load and privacy to the adjacent sites. In contrast to simple appearance, dynamic void space is designed inside the building. Bended sectional shape of the void space enable to take natural sunlight into the building from the side. The void space is taking constantly bearing natural sunlight and wind into the building. This is the new headquarters office of the Military Commercial Joint Stock Bank, one of the major commercial banks in Vietnam. The most impressive feature of the building is the glass cylinder named Media Tree at the corner of the podium. Supported by tree-like structure and clad in a highly transparent glass cover, the media tree creates an expression that opens up to the city, while a bank building tends to have relatively close design. Rooftop garden is provided at the top of the building, where one can feel relaxing nature from the interior space. A new headquarters office for Vietnam's largest oil company, located in the redevelopment area near Hanoi Station. Crystal cut facade design expresses the concept of energy core, and center atrium provides a place for employees' interaction, communication, and health. So today, I explained about the strategy of the sustainable design in Japan, and also introduced advanced curtain wall design in Vietnam by utilizing our knowledge. I also talked about the various thermal circumstances and characteristic spaces which we can choose according to our health and sensitivity. And we think that it will be one of the solutions for realizing SDGs and a carbon neutral society. Thank you for your attention. Oh. Singh, come on.
Xin được trân trọng cảm ơn phần trình bày và chia sẻ đến từ ngài Shuichi Seki rất nhiều. Kính thưa quý vị và hy vọng rằng thông qua phần trình bày của Mr. Shuichi thì quý vị đã có thể hiểu thêm về các chủ đề cũng như nội dung liên quan tới việc vượt ra khỏi nền văn minh hiện đại thông qua phần trình bày của ngài. Kính thưa quý vị và tiếp nối chương trình, xin mời quý vị chúng ta sẽ có cơ hội được lắng nghe phần trình bày và chia sẻ của một vị diễn giả có mặt trong chương trình của chúng tôi ngày hôm nay. Đó chính là Miss Agnes Koltay, giám đốc của Koltay Façades. Ladies and gentlemen, one more time, thank you very much, Mr. Shuichi, for your great and insightful presentations at our conference today. And also coming next for the event, I would like to warmly welcome the next speakers at this conference is Miss Agnes Koltay. She is the director of Koltay Façades. Kính thưa quý vị, và trước khi chúng ta cùng đến với phần trình bày và chia sẻ của Miss Agnes Koltay, thì một lần nữa Quỳnh Trúc muốn nhắc lại đó chính là trong quá trình mà chúng ta tham dự ở hội nghị ngày hôm nay thì chúng ta cũng sẽ không có phần Q&A section. Vì vậy thì rất là hy vọng rằng chúng ta sẽ tận dụng quãng thời gian ở networking section và các tea break hay là các break ở các phần để chúng ta có cơ hội tham quan triển lãm, giao lưu và gặp gỡ với các đối tác, với các nhà tài trợ, và đặc biệt là chúng ta sẽ có những cái sự giao lưu thân mật và trò chuyện với các teams cũng như là các tabs của các đối tác của chúng ta ngày hôm nay. Ladies and gentlemen, before we coming to the next presentation, I would like to friendly remind that we do not have any Q&A section during the presentation or after the presentation. So please feel free to visit our exhibition, visit our booths, have a nice talks and conversation with our partners and sponsors, and especially support us from all the evening and also about the morning and afternoon section. Kính thưa quý vị, và ngay bây giờ không để cho quý vị phải chờ đợi lâu hơn nữa, Quỳnh Trúc xin phép được trân trọng kính mời. Ladies and gentlemen, without further ado, I would like to warmly welcome on our stage Director of Koltay Façades, Miss Agnes Koltay. Please welcome.
Thank you very much. I always happy to be on Zak conferences and especially happy to be back in Vietnam. Last time I came, it was 3 years ago before the pandemic when we did some projects there, and we had the Zak conference in Ho Chi Minh. So this is our first time in Hanoi, and very nice meeting you here. Koltay Façades is a facade engineering consultancy. All what we do is facade engineering and some facade access strategy, which is very tightly related to facade engineering. In the past 12 years, since 2011, we worked on more than 122 projects in these disciplines and helped many high-rise buildings to come to reality. Some of them are in Vietnam. Currently, we are working on a project in Hom Tom Island. We started the business in Dubai. Therefore, most of our buildings are in Dubai. All the red buildings highlighted here are buildings that Koltay Façades worked on, high-rise buildings. We are extremely proud of them. And then other projects all over the world. So who's contracting a facade engineer? It could be architects, could be developers. These are about 80% of the cases. What we do is most efficient when we can do it as a representative of the owner to specify their needs in a technical language and then to oversee whether that specification is delivered. Sometimes, about 20% of the time, we work with main contractors or facade contractors. This happens because sometimes and many times on high-rise buildings. The structure is complicated and very engineering demanding. Therefore, they reach out to us for assistance in engineering and design. So why? Why would anyone pay money for a facade engineer when they can source this information from elsewhere? So let's look at some alternatives. Architect, is in the architect's role to provide information about the facade? Yes, it is, and they would provide the aesthetic guidelines, the framework, but the detailing of it became, over the years, very, very technical and very, very technological. The architect tends to work on these multi-story, multifunctional buildings, providing and coordinating many, many different disciplines, bringing it all together. And the short design time doesn't allow for research and deep knowledge in certain areas. Therefore, reaching out to a concentrated source of knowledge could be beneficial to the building. Another alternative, suppliers, system suppliers. They provide the system, they must know everything about it, which is true. They give you extremely good advice within their product range and within their area. However, the full building envelope requires more than just the aluminum system. It has the glass in it. It has sometimes stone cladding, terracotta cladding, metal cladding, all the interfacing. And then all of that needs to be coordinated during design optimally with structural engineers and other designers of the building. I will talk about interdisciplinary coordination and the importance of it later. So the facade engineer is an independent advisor who has good relationship with all these system suppliers and may advise you on optimal selection of the systems. Other alternative, instead of a facade engineer, the facade contractor. They will build a building, ultimately, so they must know about it. And yes, they know about it. But they sometimes may have slightly controversial interest than the developer or the architect, and that's progress, fast progress, and optimizing their cost. A good specification which is clear about what the architect and the developer would like to build in terms of technical quality and aesthetics could be helpful, supporting certain arguments on different alternative materials. So, isn't it expensive? And yes, at the beginning, it's an additional consultant, so it comes with additional fees. But then, without a technical specification, a detailed coordination of the package, certain problems could come on site. For example, the cladding zone is too narrow or too large. If it's too narrow, another material has to be selected because the original one doesn't fit. If it's too large, maybe you have to fill it. Probably you will fill it with fire safing, which is more expensive than concrete slab. Maybe the slab cannot take the load. You have to design everything differently. All these comes with extension of the program, additional delay and additional time, and sometimes extra material, extra engineering, extra fee. In these decisions, the quality and the aesthetics that you achieve with the building may differ than what you originally intended, and sometimes when difficult interfaces are solved on site, it may lead to maintenance problems later. Water penetration, let's say it's a hotel, the room has to be closed for the renovation. For those days you don't have income on the hotel room, then next season it leaks again you have to close. So it's maintenance cost and also reputational loss. So ultimately, not having everything designed in advance and put it on paper and coordinate it may lead to a higher expense and may become more expensive than without. So I like what I do because facade engineering is an intersection in between architecture and engineering. It has to be very aesthetical. It is the facade of the building. Everyone will see it, and this is how you recognize a building. You look at it, it's the facade. Everything is the facade. It might be a very beautiful lift core, but no one sees that, unfortunately. So facade is a very interesting architectural topic. On the other hand, as I just tried to explain, it's an engineering task, and it's heavily technical. So there are some projects where we managed to do architecture and engineering together. These are some very special ones. One of them I would like to show you is, just briefly, is a sky slide in Dubai. It's in between 2 floors of a high-rise building, sky view, near Burj Khalifa. And it's a fully glazed slide. You can basically pay for it, tourists paying for it, and slide down in a glass surface from the whole structure is on the 54th floor. So as you can imagine, it's full glass, very, very minimal steel fixings, and those steel fixings are only for redundancy. You may imagine that this is engineering, but if you just do an engineering that works, that doesn't necessarily brings the beauty of it as well. Another project where on this one we worked on the main contractor side, where we were involved, and I'm very proud that some of the decisions we made brought higher beauty, made the building more beautiful. We managed to figure out a system which provided this fully double curved cladding to the building. These buildings, these very complex buildings, have to be heavily studied, and it's not only with our mind. It's already something that is beyond our mind and has to be scripted, and those scripts are doing analysis on the geometry and on the different cases, comparing them, and some of the solutions are only possible not by engineering but by iteration to find the optimal position, and then the traditional engineering can start. Without such an optimization, these projects would be unbuildably expensive. They are already very expensive. You can imagine what it would be without optimization. But let's not think that optimization could not apply on a more typical high-rise building. So this is actually the building that has the slide on the other side, on the other facade of the building. This is unitized system, 2-tiers unitized system connected with the bridge. We were part of the project from early schematic stage until handover. But let's say just an example. This was a very early schematic stage modulation that came from the architect, the one well, it's your left side. We looked at it, and because of the different angles in between cladding panels and different arcs, you basically need 14 different unitized system extrusion to cover the whole half building. The building is mirror symmetrical, so looking at half is basically covering the whole building. So we started looking at these angles, slightly modified the arcs, the radius of the arcs, and the meeting points of two arcs, and fine-tuned the set out. So basically, we ended up with the floor plan on the right side, which, if you look at it, it basically looks identical, almost no difference. But when you calculate the number of different extrusions necessary, it's only 10 instead of 14. So we don't know how much additional cost it saved, and we don't know if later the contractor would not have maybe not done the same, but did a little bit of additional work on the original floor plan to make it more optimized. But doing it early, we could talk to the structure engineer, so the slab edge was completely following it. If it's done later, the slab edge is already done, casted most of the time. Same building, so at early stage, when we do that study, schematic stage, we basically come up with the different facade systems needed for the building. We try to aim for as much efficiency as possible by using the same system elements in different scenarios where possible. But you still always have some different systems. So, for example, on this one, the continuous facades tend to use unitized curtain walling system, but you see the pink ones, for example, at the top of the building is surprisingly stick system, because there it was not sufficient uniformity for a unitized system in terms of the angular differences, and it was basically two pavilions. So it's rather than thinking of it as a top of the building, it's two pavilions to be built. So at system selection, the main categories for curtain walling is stick system, unitized system. For this building, for example, it could be built in a stick way. That's the upper slide, where the mullions are coming on site separately. They bring the glass, they bring the gaskets, and put everything, assemble everything on site. This needs less background in terms of the contractor's facility. It's basically just a warehouse, but does not need big machinery. Whereas a unitized system is more intense in the factory, but then the elements, individual elements coming to site can be put together like a puzzle and needs much less effort on site. We were considering a mega panel as well, which is basically three unitized panels together. So it would be a big frame, and in between it's basically stick elements. This panel becomes quite large. It was around 5 meters. So it's not necessarily practical if it's coming from another country or coming from long distance. But if the contractor is local enough and close enough, it's a wonderful solution and very quick to install. So actually, this is what happened at the end of this building. The building is an extension of Dubai Mall. We worked on all 4 towers, and this is a 12-story car park and retail. And this road below was open and very heavy traffic. So the contractor, the main contractor, did not want. You may see how many contractors needs to be coordinated for a big site like this. So definitely minimalizing site effort was a good idea. With a stick system, you have to install the cladding on the slab edges separately. So basically, you would have people outside of the building for a year continuously. Another building in Dubai, Address Hotel and Address Boulevard. And for this, I just put here a sample of a page of a tender set. So the details that the contractor receives from the facade consultant are quite detailed and basically buildable in a way with minor further development. And very important thing that we need for high-rise buildings at the early stage, let's say 50% detail design or before, is wind tunnel test. We don't do the wind tunnel test ourselves, but there are wind tunnel test facilities like this one, where they can 3D print the scaled model of the building, put it in front of a wind tunnel, and turn, with the whole environment, turn the table around for the typical wind directions, and can come up with a wind pressure map, which looks like this. So it would tell you the minimum and maximum pressure and suction at different areas of the surface. These tall buildings are not not possible to accurately calculate anymore. There are standards to do wind calculations, but those standards are assuming a rectangular building not very tall, up to 100 meters, something like that. When it comes to a more high-rise environment and more complicated geometry, the turbulences caused by the proximity of the buildings are basically not possible to humanly accurately estimate. There are computer simulations, but still wind tunnel test is the most accurate thing. So just an example, how important is it now to the exact wind pressure at certain areas? On this building, Burj Vista, the architect worked with these positive negative masses, and ideally he wanted one of these living room and bedroom facades elements to be one big piece of glass, which is 4.1 meter by almost 3. Possible, and if you build your family home, a villa, I really recommend. It's very nice piece of glass. But on a high-rise building, it was 72 floors and 28, the two buildings. It's actually not a profitable solution to buy this jumbo glass. Not to mention that it has other consequences. So the heavier the glass is, the more this, the bigger the span is, and heavier the glass, the more robust this bottom transom needs to be. That's extra cost on the aluminum. The glass itself needs to be thicker and heavier because of the span. And then, because the glass is heavier and the piece is bigger, even the maintenance equipment on the roof, the BMU that would help replacing the glass in case it's broken, would need to be more robust. So the developer needs to pay for a BMU machine being capable to carry a glass 3 times the weight of another glass, which will be used maybe once every 5 years for replacement, and no one sees it on the building. So these type of optimization questions are quite important in early phase. Out of the 3 solutions, they went with that one. You can see it on the previous slide. Okay, the very narrow piece, the second one. It's not fully it's close the best optimal solution, but it was more of an architectural decision as well at this stage. So just very quickly, for those of you who are less familiar with stick system and unitized system, unitized system does not need external access and can be done in a factory. It's very quick to install once it's starting production. Therefore, it's more of a high-rise solution than a stick system building. Another important thing that it provides for movements, much more than a stick system. I will talk about those movements in a minute. Therefore, it's more appropriate for a taller building than the stick system, where the mullion basically runs the whole height of the building and allows only minimal movements. Okay, so this is stick system. I'm not an enemy of stick system. We are using that a lot as well. And it's on high-rise, has a place where we can install it slab to slab. So here you see these balconies, terraces. The worker can go there, work safely. The inspector can go there, look at it, and that's a good application of stick system. This is a building we had. Basically, these masses are not different in terms of installation than installing a single-story family home, because they have the slabs all around for access. Again, stick system, so this is how it looks like. On this particular project, the production of the glass was delayed. Normally, you would not see the skeleton of the building that long, but it's good because now I can show how it looks before installation of the glass. This system relies heavily on even compression of this gasket that needs to be compressed, and that keeps out weather. Unitized system, there are multiple types of unitized system. These are some examples, and you can see from Norway to Qatar to Azerbaijan to India, it can be adopted in any type of climate, cold or hot. It installs in sequence, immediately gives a finished look to the building. Done in a factory, very good quality control opportunities. The glazing, structural sealant application could be done in a controlled environment. And for installation, you need inside 2 people, 3 people, and the floor above, and that's it basically. There are different types of brackets. So one unit basically comes with a half frame on one side and a half frame on the other side. That would be unit to unit, and the installs next to each other. This system does not rely on a evenly compressed gasket or a fully continuous gasket. It relies on the principle of pressure equalization, which is similar to when you are in a very crowded room and you have access to a less crowded room, and you would like to switch to that place. So what happens here, this is a typical unitized system, male-female system. So you have a pressure outside, and it's changing because a big storm just started. So here the pressure, let's say, increased. We have a chamber here, and then a gasket, and then another chamber, and then a gasket, and then we have the room inside. In between this chamber 1 and the outside, we only have this weather gasket, which is basically not a very good gasket. It has openings, it has gaps. Through that gaps and openings, this increased pressure will equalize with this pressure, chamber pressure 1, and will draw some moisture in. But once the pressure is equalized, there will be no more moisture coming in. The moisture here just drops down. And then the same happens 2 more times until the room is basically air and water sealed. Same thing on this section. And I think my time is about to go. So very quickly, this system allows movement in between the elements, horizontally and vertically. You see that it can go through, it can compress and extend, and the legs are still engaged. Therefore, it can allow very well to base building movements. Here you can see differential slab deflection, which is the biggest factor. This slab is fully loaded. This floor is vacant, let's say, and that floor is vacant, not loaded. So when this slab deflects, the joint here will open up, the joint here will close down, and similar things happens on the vertical joints. There are different types of movements. The red ones are base building movements, and those have to be coordinated early on. We have to know at the design of the panel what movements it needs to be taken up. Those movements are cyclic, temporary, they come and go, most of them, and they're taken at the panel hook. The ones in black are tolerances rather than movements. They happen only once, like the casting tolerance of the slab, and after that it will not change. In the cladding zone, which is this one, you need to allow for these movements as well. Yes, I think I finished here because I hear all these rings. Actually, this is my last slide. Different cladding zones. Okay, so different systems would end up with different thicknesses that it needs in between the slab edge and the external surface of the cladding. And let's see here, you see the red is the slab edge. Actually, this is the facade line that you would like to have. And the distance in between the two lines, it's not a clear offset. Here it has a big distance, here it has a medium distance, and in this face, horizontally, it has a very small distance. So this is the type of coordination which I suggest you to do at an early phase, so you have a very smooth construction period without problems, delays, RFIs, and questions and variation claims and sacrifices from the aesthetics and quality side. Thank you very much.
Xin được trân trọng cảm ơn phần phát biểu, chia sẻ và trình bày đến từ bà Agnes Koltay. Thank you very much, Ms. Agnes Koltay, for your great presentation today. Kính thưa quý vị, và tiếp nối chương trình, xin mời quý vị chúng ta sẽ cùng lắng nghe phần chia sẻ và trình bày đến từ ông Thomas Fruhmann, giám đốc phụ trách các dịch vụ trước xây dựng của Shuko Middle East. Ladies and gentlemen, coming up next, we will hear the presentation from Mr. Thomas Fruhmann. He is the director of pre-construction services of Shuko Middle East. Kính thưa quý vị, vì một vài lý do nên Mr. Thomas chúng ta không thể có mặt tại sự kiện ngày hôm nay. Vì vậy, ngay bây giờ xin mời quý vị chúng ta sẽ cùng theo dõi bài thuyết trình thông qua hệ thống trực tuyến. Ladies and gentlemen, for some reasons that Mr. Thomas cannot appear directly at our conference today, so he will deliver his presentation via virtual platform. Please enjoy.
Hello and welcome to Zak World of Façades, Hanoi. My name is Thomas Fruhmann, and thank you for the organizers, Zak, for making this conference possible. I'm very happy to join you here, though on a stream. However, welcome again. Good afternoon. Now, let me first give you a brief about what we are going to talk or to hear today. So we are going to talk about the Shuko offerings. So what services, what products do we offer? Very brief. Then I'm going to switch over to the pre-construction service, a service that Shuko provides to their customers, to specifiers in general. Then we are going to talk about the G2S system, and then I'm going to return and span the circle to how do we apply pre-construction service on G2S structures. And then, because a picture says more than 1,000 words, in the end you will see a lot of references that we have built with that system, so you get a flavor of what can be done in that system. Shuko. 70 years, Shuko has been the trailblazer of their own industry. So our founder, Mr. Julian, had this idea 70 years ago. There must be more to a door, to a window, than just buying bars, cutting them and put glass on it. So he had this system approach, and this is where the whole company evolved from, to have a systematic approach to products in the building skin, building envelope. So what offerings can we make? What solutions do we have? In terms of building skin, which is basically the vertical parts of the building, we do have doors, windows, we have facade solutions. In the facades, we have a traditional trans-Mullen system and in stick, and modular as unitized. The materials we work in that segment, let's say, are aluminum, steel. We do have fabric, and we do have also, probably not known to most, a UPVC product range. If we now broaden the thing from the envelope to the skin, which is basically the elements that wrap around the building, then we come to the roofs. In the roofs, we work with aluminum and steel in terms of the add-on. Now, the product range. We do have safety products, we do have security products. In the safety, we are talking about smoke sealing products, fire-rated products, and glass balustrades. Glass balustrade, why in the safety? Because they predominantly prevent people from falling from heights. Security, we do have burglar-resistant, bulletproof, and blast-resistant. But more on that, we do have even combinations thereof. So we do have blast-resistant with fire-rated, and for that we have a specialized 100% subsidiary company. It's called Seltzer. They do have these very high secure and combined safety products on offer. Yes, PCS service, pre-construction services. What can you expect from that service and why are we doing that? It is a service that Shuichi provides to, as I said before, to their clients, to their customers, to specifiers in general. And what we aim for is to put you in a position to give an informed decision. How do we do that? So first we listen and connect. We listen and connect to understand what is the intent of your design, what is the intent of the designer's wish, how he wants to deliver a design. Once we have listened and connected and understand the design, the next step is we just seek and try to understand where has the project, where has the process been, the design process, where has it reached. And from that we pick up and then we provide our added value, we provide solutions. Because, and why we are doing that, because we don't want that two people are speaking about the same, yet about a different product. Now, jumping into how did we apply that? The first project I want to show you is this building, which had a very significant iconic scoop, as we called it, at the entrance. So what was the architect's designer's wish? What did he wish for? He wished for an iconic feature in that place. He wanted to have it modular. So his understanding of modularity was unitized curtain wall. He wanted, obviously, a smooth transition between the units themselves, and obviously, like many others, he wanted to have that done cost efficient. So when we came to the project, the site basically was ready for that. And so where did we start? Again, listen and then understand where it has been reached. And then what we do there is trying and manage the expectations. Because the specifier's understanding of unitized or was a unitized curtain wall. So we explained to him and said, okay, if you want to build that scoop in a unitized facade, fully unitized, so either you have to, and you want to have this smooth transition from unit to unit, you need to have a bending profile, you would have to have hot bend glass, because the alternative would be that yes, you can do it in unitized and you do a cold bend, but cold bending has some limitations. So in that scoop, the limitations would be too much, hence there would be like offsets. So I'm showing that picture not to say, okay, it's a bad design. I just wanted the specifier, the designer, to be aware of what can he expect if, for example, he doesn't have the budget for for bend profiles, for rolled profiles and hot bend glass, and he goes for cold bend. So he would need to have to deal with these offsets. The next iteration was that, okay, yes, we can do it in a traditional stick curtain wall. However, if you do it in stick curtain wall, obviously you get these kinked brackets. And then again, if you have this scoop, you would need to have a bracket on top and on bottom of the stick curtain wall. Hence, cost effectiveness would be in question. And most of all, it is not unitized. But then we thought, what if we had a system that is parametric, a system that is versatile, a system that is in aluminium, hence can be recircled in the process of production and recycling on and on. If we had a system that gives you freedom of design, a system that is easy to fabricate, which is something obviously that comes with the question of cost effectiveness, a system that is easy to install, again, because you can pre-assemble parts of it, and therefore, with all this said, it is cost effective. So what if we had a system that would allow you, from the grid lines of the designers, to go to the geodesic structural shell of the engineer, from grid to shell, G to S. Now we have it. So what does the G2S, the grid shell system, what's the process behind? So what we do is, first we do the design. We do the design of the mesh model, where we pick up on any 3D surface model. So SketchUp, Rhino, you name it. Any 3D digital readable form surface model we pick up, and we create the mesh model. After we have created or designed the mesh model, we model the profiles, we model the nodes, and then the last part is that we are going to generate the components of it. And by doing that in the process, even in the pre-construction service process, we do also structural pre-analysis, so that in the end of the day, when we offer the product, when we offer the price, the system has been structurally studied, and we have a structural assessment. Now, the really striking advantage of the system is that although you can do all this parametric, all this 3D, the system components are little. So basically what we do have aluminum extrusions. We do have a EPDM gasket system. We have 3-layer gasket system, so where we can drain from one level to the other. We have our toggle system, and yes, and then we have the extrusion and the nodes. That's it. And with that, we can build all these 3D parametric products. Now, if you look into traditionally how such projects would have been built, you would traditionally have, in some way or another, structural steel, and then on this steel you would have an add-on system, be it a stick curtain wall or another add-on profile. What we have done is we have combined those two elements, so the structural and the add-on, into one extrusion. Obviously, a different alloy, a high-strength aluminum alloy that we use for extruding the profiles, and the nodes are CNC'd. They are milled out of the solid aluminum, and this CNCing, the process of creating a node is an aesthetically enormously advantage, because what you get is a star-shaped node. If you now compare a traditional steel node to an aluminum node, now I just give you some examples which I have taken randomly on the steel nodes, and on the aluminum you will see, because it's aluminum, you can powder coat it, so there is no painting on site, there is no touching up, and the node always looks the same, or even you can't distinguish where is the node, where is the profile. And you have a consistent quality, which is an unbelievable aesthetical advantage of that system as well. Now, the system has been tested. It has been tested thoroughly. AMA, we have done EN tests in our lab here in Bielefeld. It has been tested horizontally, it has been tested vertically. Why is it important? Because a system that has been tested horizontally does not necessarily need to perform vertically, vice versa. So it is important that a system that can be installed horizontally and vertically has been tested in both of these applications. We have done that. Sometimes people ask about the strength of if you build it in aluminum, how is it strong? I always put that picture then in front of the people, where you can see during the installation people are walking on the glass. So what we do actually is we incorporate all the loads that we need, that we are aware of, into the structural model, which means even if there is maintenance load, so what we do is we build usually in 850 Newton in the center of the glass as an additional maintenance load, not for walking on the glass, but for people to maintain, to clean the glass. And then you can add the latchway system, the man-safe system, so all that is possible. So yes, the system is a very strong, very sturdy system, and it passes all the structural analysis. Now, coming back to our scoop, remember, the specifier, he wished for an iconic feature, modular. His understanding was unitized curtain wall of modularization. He wanted to have the smooth transition and he wanted to have the cost effectiveness. Now, having said that, and having run the specifier through the options of stick and unitized, we asked him if he would be happy to see if we could provide him a solution in our G2S. He said, yes, please go ahead, and this is what we have done, and this is the result. We have proposed a G2S solution with it. Yes, it is not, it doesn't have the verticality. However, it ticks all the other boxes of having a smooth transition, being unitized in the sense because you can pre-assemble parts of it and then put these parts, lift those parts, those pre-assembled parts in place. And so that the architect or the specifier gets the confidence that he's not a guinea pig. We have even projects where a similar solution had been applied. So yes, he was very happy to see that. Another application, because important it is to know that this product not only, as we said, can be applied on roofs, but it can also be applied on facades. So this was where we got a call from a specifier that, Thomas, we have a very unique project. It is parametric in a sense. It's a 2-floor high facade. It spans 9 meters. It is parametric. We do want to have a very short time between the approved drawing to the installation, so we only have 12 weeks. So what can we do? So we did run through the options, doing in the stick system. If you think about stick system, you would need to beef up the vertical profiles, 9-meter span. It's quite some structural reinforcement you have to do. You probably can't do that within the profile. You would have a secondary structure. So again, we asked him if we can do a proposal in G2S. He was very happy with that, and so we proposed it, and this is what we have done. And again, it has been we have done mock-ups, and it has been already the product has been already applied in vertical applications, as you can see. The next project was a very typical shopping center, and it had a skylight of 8,500 square meters. There, the client himself, his wish was to have the installation as quick as possible. Why that? Because the bad weather season was approaching, so he was very pushing to close the roof as quick as possible, so that during the bad weather season, the interior fit out could take place. So where did we pick up? Yes, the design was a traditional skylight barrel roof. Basically, it had a steel structure. It had tension cables, and then on the structural steel, you would have your add-on system. Now, again, nothing bad about this design or something. It's not about bad and good and bad design or whatever. However, just coming back and reiterating on what the client's wish was. He wanted to have something that can be installed very fast. Now, if you look at that design solution, you would need to come with your steel. You would need to install your steel. You would need to have then the cables tension. You would need to align the steel, and then once you have done this, you would come with your aluminum add-on system and then with the glazing. Leave out that the steel and the aluminum would be even probably to contractors, the coordination. So we said, okay, can we propose something that deviates a little bit from the design, but meets your wish of being quickly installed, which is our G2S. So we proposed, again, we picked up, because the client, he wanted to have these rectangular glasses. So we picked up on that. We presented a model in rectangular, more traditional glasses. But by the same token, we said, okay, let's propose something a little bit more contemporary with triangular glasses. He saw it, and yes, again, it's a different appearance because you don't have the steel there. Yeah, and it had the additional advantage that if you install such a roof with steel, what you basically would end up is with checked up platforms And then you would work from these checked up platforms and install your steel and your glass. Now that in itself, so there is cost, because someone has to pay for the temporary platform, but also it would disturb the way in the ground floor. So the bringing in the material would be a bit of a hassle, because you would have all this jungle of studs. Now, if you do that in grid to shell, you don't need that, because as we said, you can prefabricate parts, and the only place where you need to have access is where you actually assemble those parts together, which is this method of installation. So we install parts between 300 square meters, 350, depends on the availability of crane and site equipment, and then we pre-assemble those parts close to the installation point and then lift them in place. Now, this is nothing new, it has been done, and here you see a picture of a roof that has been pre-assembled in its entirety. If you think that that on a scale, you have like 10, 15 of those parts, so you have these 200-300 square meters of roof, and then you just put them in place, and wherever you need access, you just have a scissor lift, a cherry picker, or whatnot. What can be done? Now, G2S can be a skylight. It can be a big skylight. We have done skylights of spans of up to 50 meters. We are working currently on one which has a span of 70 meters, and that in aluminium. It can be, a big dome. It can be a facade. So that's a building where we have a facade, and it can be anything in between. So it can be a facade and the roof and anything in between. So those are projects where you can see there is no secondary steel required, which have been already installed. We have installed around 150,000 square meters of that product. Another project I would like to present you is, because it also shows you the versatility. That is a project that we recently finished in Dubai, where the specifier, it's an open courtyard, and there is alfresco dining, so outside dining. And the designer's idea was to create a feature above that courtyard, but also, so the iconic feature, but also to have shading. Have shading on in pattern on those areas where the restaurants, where the alfresco dining, where the coffee shops are. So what we did there, and the design when we came there was steel and glass. We said, why steel, why glass? Can we do it in aluminium and fabric? And then what we did, we combined our strength. So we have the G2S, and then on top of the G2S, our engineering office combined the profile, the extrusion, with the facet. So we could offer a product that is actually G2S with facet, and it gives you see now these lively patterns. You see the shade on the alfresco dining area, and the installation was done, as I said, previously with parts of 200-300 square meters, and they were lifting in place with tower crane. Yes, we have done you can have the G2S as shading feature. So we have done projects in that as well. So it can be, yes, features. And last but not least, something that we are also proud, you can have it as walkways, as a bridge. Yeah, so just to give you an idea about the applications of that product, they are really, really, let's say, limitless. And the product is made in Dubai. So yeah, just wrapping up. So the system is fully parametric and fully systemizable. It blurs the boundaries between horizontal and vertically. And what I would like you now, seeing is believing, I would like to invite you to go out to our booth and talk to our representatives who are there to take your questions and answer them. Thank you very much, and I wish you a very successful conference ongoing. Bye-bye.
Xin được trân trọng cảm ơn phần trình bày và chia sẻ trực tuyến đến từ Mr. Thomas. Vì một vài lý do thì Mr. Thomas không thể có mặt ở đây. Tuy nhiên thì tại triển lãm của chúng tôi cũng có quầy booth của Shuko. Vì vậy quý vị hoàn toàn có thể tham quan cũng như trải nghiệm ở quầy booth Shuko tại triển lãm. Kính thưa quý vị, và tiếp nối chương trình, xin mời quý vị chúng ta sẽ cùng nhau tìm hiểu về nội dung, đó chính là chuyện về hai mặt đứng thông qua phần trình bày của Mr. Mohammed Adib, Giám đốc thiết kế Dewan Architects và Engineers. Ladies and gentlemen, it is our last presentation in the morning section, and please welcome on our stage Mr. Mohammed Adib. Ladies and gentlemen, please raise a big applause, please.
Thank you. Thank you very much, Zak World of Façades, for inviting me again. I think my last event in Dubai, actually, I also spoke after Thomas. Thomas is a very big guy. It's very strange to see him so small. So first of all, I'd just like to have a couple of words about Dewan, because we're quite new in the region. So Dewan is an architectural firm started in Abu Dhabi about 40 years ago. Next year will be our 40th year. And moved our headquarters to Dubai a few years later, and we just opened our 8th office here in Ho Chi Minh earlier this year. So I'm going to talk about a specific case, a project that we're working on in Dubai. It's a hotel, it's a lifestyle hotel. It actually just started construction a few weeks ago. Some of my colleagues, Agnes and Thomas, are talking about sort of the new tendencies, the high-tech side of facade. I'm going to take you a step backwards. It's a solution. We had many, many restraints on this project, and the solutions we found and ended up with are really quite old school. So the plot is in Business Bay in Dubai. I don't know if you know it. It's actually an old master plan we did. And it became very successful, and now most of the pocket parks are being converted into plots. So our bit is here, and it really is a very, very difficult plot to make a building on, and let alone a hotel with all the accesses that are required. Plus having 3 sides and roads on 3 sides, the limits to the access are quite difficult as well. The client was very easy, very special case. It's the first time that he was developing a hotel. He didn't know what he wanted. He knew the brand that he was going for, which was one of the Marriott brands, a very sort of low-cost lifestyle brand. And he held a small competition for some, I think we started 8 architectural offices, then ended up 4, and then he chose us. Because he wanted not to see the CV of the architects, but to see what solution they were giving for this plot. And once this happened, he said, this is the budget, do whatever you want, but keep it within the budget. So Dubai and most all cities now, it's very competitive, especially for the hotels. So we had to do something that had to stick out a bit in the city. It had to be open to the public. There's another added problem in Dubai in that basements are very expensive. So people end up building these podiums for the car park and the building above that. And that is really a very, very strong barrier for people. You know, the contact that you have with a building is on the ground level. And this is always a wall or a sort of a shutter or a louver seeing cars, and then the entrance is a small opening. As with the lifestyle, Dubai also is a young city. It's something to be it needs to be a destination, because a successful hotel is in as much as the people that go and stay there, but it's the local people that use it also, make it successful. Dubai changes totally, you know, during the day, during the night, during midday, it changes, and that had to be reflected a bit in the building itself. Obviously, it's a young atmosphere where people want to be seen, want to see and want to be seen. So everything with that we do had to be to the outside a bit. And a landmark. The skyline in Dubai is full of buildings, full of amazing buildings. We needed to do something that could be sort of almost like a beacon that would lead you to the building. Showing the interior of the building is what I was referring. You know, the podium feeling of this barrier. If you show what's happening in a building when you're driving past, when you're on a flyover bridge or something, that sort of tickles your curiosity and makes you go to that building. The title of my talk is the two facades, because we had to treat it in a different way. Having the limitations of the cost, having the limitations of the brand being a 3-star, 4-star thing, we had to sort of almost spend more money on the podium and less money on the tower because of the volume, and try and put together and get into the budget. So we decided from the beginning to treat them in totally different ways. It's a different architecture, it's a different scale, and also to have the podium more sort of human scale, and have the tower something with a beacon, with something on the top that showed people anywhere in the city to go there. The orientation was quite difficult. We had some good views, but also the sun cycle is quite different. Something very interesting in Dubai is the pools are actually used very strangely. You know, most time during the day you can't go to the pool, so you use early in the morning and early in the evening, just before sundown. And this is very, very difficult for the sun movement. You know, they're opposed ends, especially when the plot is so small, and especially when the tower is the footprint is quite large. So we thought, okay, let's raise the tower. Let's raise the tower actually to allow this last hours of the sun to go through to the pool. And also there was a natural breeze because of the master plan that was developed through that. So that will help and cool a bit the top of the podium, which is the pool area. Then we sort of kept the back of house and the parking towards the back of the podium, and did this skin on the outside to have this connection with the city and the connection with the people who are using the hotel. And this is a bit the resulting mass. It's a bit, we'll go into a bit more detail to understand how we did it. So then he loved it, we go ahead, then the cost comes in. So we were basically every single step, we were proofing the cost and having the challenge of fitting the budget. We sort of considered various ways to control the cost. And one thing that through the experiments and the numbers we run is actually reducing the weight. The safety factor in the UAE is quite high for the concrete. So we decided to look for very low weight solutions for the facade to reduce the actual concrete, the steel, everything, and that really at the end gave us a huge saving in price and carbon footprint as well. Low maintenance, obviously, because it's a 3-star hotel, so whatever panels, especially in the high-rise area, should be sort of done, leave it there, no need any maintenance at all. Small windows, sustainable, obviously, as always, and learning from the past. We're talking about, you know, setting the windows back to have a bit more protection from the sun, rotating in the building to minimize the sun factor on it. And modular offsite. I mean, obviously for the interiors, for the last, I think, maybe 5-6 years, everything we've been doing has been based on pods. And exterior, it's more sort of structural elements, but modular facade units is getting more and more popular, especially because the plot is so small and we're occupying almost 90% of it. There really isn't even any physical space on site to sort of deliver materials or to work or do anything. So anything that could be done off site, besides the advantages of the quality and the time, would be useful as well on things. So we started studying the precast, prefabricated sort of solutions, the constraints that we had. And what I was talking about, modular offsite, this is a sort of a difficulty scale of the lower the number, the more difficult it is. the problems that people have on site, the workers have on site. So obviously exterior walls is one of the biggest ones. So we thought, okay, if we can do it totally prefabricated, it will be a great help. Speed up the construction and simplify it. Obviously, the timeline, especially for a hotel, it's very critical because the earlier that we can open, the earlier that they can make money. And having off-site manufacturing allows you to sort of prepare the pieces before arriving and installing it. And especially with the constraint, our idea was to bring them and plug them in at night and when the traffic is low in the area. The global precast market, and especially in the UAE, is not as big as I think it should be. The figures in Asia Pacific, but it's a growing thing, and I think something that we'd like to experiment with and try out more and more. It really is. It's from a quality and from a time thing. It has no comparison. The structural study is what I was referring to. We tried to reduce the weight as much as possible, and really with this last system of the facade we did. This saving of the linear meters that we did on the facade sort of gave us some amazing figures, you know, of concrete, of steel, and just the number of trucks circulating in the city that we could cancel with these movements. We started studying all the possible low-tech, old-school solutions that could be for the facade. We did a bit of a comparison about their sustainability, their carbon footprint, their insulation values, and did a bit of a summary so that we could sort of choose the best system suited both for cost and for solution. We sort of ended up going for a mix of the GRP and the GRP, GRC, and the EIFS. So a bit of a very quick summary of the difference between precast and prefabricated. I'm sure you're all very versed in these. And that gave us sort of the two different, totally different styles of the construction, of the building, and of the look and feel. So the upper tower, obviously, it's a modular system. It's very repetitive. It's actually the same piece exactly, and it's just rotated to give it this dynamism a bit. But it's a full room. It's a 3.8 by 3.8 piece that comes prefabricated and just screws in. The lower part is where we're using a bit more because of obviously it's more prone to impact, it's more prone to movement, so we're using a bit more the GRC and GRP systems. But again, we've sort of modularized these pieces, and actually even the stick out, the sort of this different sticking out modules, they're modular. It's the same pieces that are cut and rotated. So it looks very dynamic, but actually there's 5 pieces, 5 molds that we need for the whole podium area. So we went for the prefabricated, precast, as I said before, EIFS for the roof, and GRC for the podium. So this is a bit the final thing. Is that the last slide? I know. Just as the feel. So as you can see, you know, that the very tight site is actually we just have a little bit of a small drop-off road and the pavement. So during construction was totally impossible, and this is already our neighbor. There's circulation, Moxie, you can see the name of the hotel. So the circulation was a big challenge as well, how to come in and how to get out. So this is the EIFS system, the external insulated facade system. That's what we used. So, I mean, obviously, it's a very old system. The sort of most post-war German buildings are done from that. It's very easy. It's very low-tech to apply. But we wanted to take it a step further and actually make it into panels, into ready panels, which can be taken the full room and just plugged in as a unit. We tested with a lot of solutions, with partially off-site and partially on-site. but ended up with this sort of system where it came totally even actually on the inside. It was finished with the plasterboard, with the window, everything done, and it's just plugged in. There's a filler piece on the outside, and on the inside, it's the internal walls that covered that. This is basically, it was very easy to transport to site. The truck would actually will park on the pavement just next to it, and it would be lifted in and screwed in at night. And they were doing the plan from both sides. There was 2 cranes to be installed on site, and they would do like a floor every evening. So obviously the speed is huge. The room will be already sealed. The pods would have been plugged in, and really everything that's left in the typical floors is a bit of decorating. This is a bit of the look. So this is the crown of the thing, which is the thing that you'd see from everywhere. The top of the podium is the quite active scale. I apologize for the quality of the renders, but because we don't need to sell it to the client actually bought in from the beginning. So it's really just all from our Revit files. We just did them for presentation. And a bit of the dynamism of the podium. There's a bowling alley, there's a bicycle shop, all the restaurants open up to the outside, and there's an internal, very small corridor separating the car park from the outside. And even some of the levels, you can actually see the car park in the background, which is also a nice thing to see movement of bikes, lights and cars. This is the idea of the whole thing. We've got a disadvantage of a little bridge, and then the sort of the highlight, which is this nightclub at the top, and then really the dynamism of the facade. It's a very straightforward facade with just 2 pieces. It's the same piece, just rotating it, and it gives it's quite a dynamic move. Some other views from the other side. A pool is a very important part of this is the Moxie brand. It's a very lifestyle, and this is the thing actually. This is where the sun goes down in the evening, so you get this warm sunlight and at sunset. I leave you with this final. It's lunchtime, so I'll speed up. I've got 10 minutes left, but. The palm tree is actually a law that you have to use palm trees in any plot in Dubai. So they look a bit strange on this podium, but we have no land to plant them, so it had to go up there. And as I said, this is up. Sorry. Yeah. This is what I was saying actually. This was a plot here and a plot here, and these are the 2 pocket parks that they've sold off to developers. That's it, no?
I'd be lying, baby, if I said it wasn't true.
They're showing it again, so.
Slightly hungover, maybe slightly blue.
So just some general figures. It's sort of the summary of what happened in the end. Actually, the cost is working about almost 20% cheaper than traditional sort of hotel in Dubai for the same star rating. And the sort of the planned time scale would shave off about 3.5 months of the opening time, which is quite obviously an important factor for the owner. And that's it. Thank you very much.
Xin được cảm ơn phần trình bày và chia sẻ đến từ Mr. Mohammed Adib. Kính thưa quý vị, và như vậy phần trình bày của Mr. Mohammed Adib cũng đã khép lại cho phiên hội nghị của chúng ta ngày hôm nay trong buổi sáng. Và thay mặt cho ban tổ chức, xin được cảm ơn quý vị rất nhiều. Và xin mời quý vị chúng ta sẽ cùng nghỉ giải lao và ăn tiệc trưa trong khoảng thời gian là 1 tiếng. Và phiên hội nghị buổi chiều của chúng ta dự kiến sẽ được bắt đầu sau khoảng thời gian là 1 tiếng. Ladies and gentlemen, it's now the time for you to take a break and enjoy the lunch. Xin được chào đón toàn thể các quý vị đại biểu, quý vị khách quý, chúng ta đã cùng quay trở lại với sự kiện hội nghị Zak World of Façades ngày hôm nay. Ladies and gentlemen, warmly welcome back everyone to our conference today. Kính thưa quý vị, và mở đầu cho phiên hội nghị buổi chiều ngày hôm nay, xin được mời toàn thể quý vị chúng ta sẽ cùng lắng nghe phần trình bày đến từ Mr. Julian Escobar Uribe, giám đốc của PTW, sẽ cùng chia sẻ với quý vị về chủ đề không gian giữa trong nhà và ngoài trời. Ladies and gentlemen, to open for our afternoon section, please welcome on our stage the director of PTW, Mr. Julian. Please raise a big applause, please.
Thank you. Okay, good afternoon. Thank you, everyone, to be here. Of course, you can sleep if you prefer. Thank you, organizers, and thank you, all of you. It's a pleasure and an honor to share with you and to learn from you. 3 titles: Facades in Vietnam of PTW, some case studies quickly, and some final thoughts. PTW is an Australian company that has been working in Vietnam for around 18 years. I personally started to work in Sydney with PTW around 7 years ago. I'm living here since 4 years ago. So what's a facade? We already saw this morning many photos of this building. This building is maybe the main reason for PTW to be here, because when traveling to do this building in China, I don't know how, people started to stop in Vietnam, and well, my former colleagues, directors, started to work in Vietnam. But it's really interesting because, you know, what's the facade of this building? You know, we saw many photos, even better photos before, so it's the elevation, is what we see from here, from above, from the sides, from inside, sort of, it's an interesting example of architecture from my personal point of view, and I was not part of this project. Chris was with Mark and other people, but this is consistent. Why is consistent? Because you cannot separate the elements that configure that building without killing the building. So is the facade the envelope? Is the surface? Is the interior space? It's all together. If you change the facade, you change the building. If you change the envelope, you change the building. So that's consistency. So we can discuss about what's the different points of view or ideas about what's the exact definition of facade. But I'm pretty sure that we all agree that the facade is the interface between our lives, our buildings, and the local climate conditions. That's for sure. And if we look at this graphic, these 2 red things, red and pink, is where Vietnam is in terms of climate, weather. Is equatorial, monsoonal, so it's a specific type of weather. So for me, I learned a lot from Vietnam, and I highly appreciate how smart and clever people in Vietnam professionals and non-professionals, we are dealing with these local conditions along the time, how buildings from the vernacular architecture, but also from modernist designers, they managed to build excellent architecture that doesn't need air conditioning to work. I don't know if we can say the same about our current buildings. So PTW has been working on many buildings since the beginning. Many are well known, some were mentioned this morning, different typologies, but I can say that my former colleagues in PTW were always sensitive to these local conditions. So local weather conditions, environment, solar radiation, solar impact, in times when maybe that was not part of the agenda. But all these buildings, you can see that have something that looks suitable to Vietnam. So the principles for facade approach, well, are, let's say, universal, things that we need to consider, but the point is how we apply those principles to our design. What is priority, what is more relevant, about orientation, heat, materials, indoor-outdoor connection. So since those examples that are built and are working, we continue working and trying to design and to deliver projects sensitive to the environment and to the local conditions. So I will show some work in progress quickly. The first one is Golden Hills Tower. This is in a building in Da Nang. In this building, we are lead consultants and architects. It's important this about lead consultants because when we in lead consultants, we have the opportunity to propose disciplines for the project and also to propose consultants and to work with them since day one. So we have excellent consultants on board. We have for facade and lighting in Habit, RFR for structure and MEP, LCA for landscape and acoustics del home. This is a mixed-use building. We have retail podium, office, 4 stars hotel, but it's one building. And how we work with that is we design the building in a way that we have a central core, and then we have a structural exoskeleton, and this exoskeleton is separated from what we can say the facade. So the exoskeleton is the facade, and we create an intermediate space that helps us to deal with the particular weather conditions in Da Nang. So we have 3 main functions in this building. We have the commercial part, office, and hotel, but we want to have one building. These functions can change along the way now until the building is built or in the future. So the buildings that look like, so usually I say birthday cakes, with are not preferred from my perspective. So this is one building, different functions, and then these different functions are connected by open spaces that have direct connection with this intermediate space that is not indoor, not outdoor, is in between. So all this generates a specific microclimate for the building, all the facades and all these intermediate spaces. Sorry, because they were really interesting things. This is an interior courtyard for the hotel, and the pool here is not an infinity pool at the roof. It's in the atrium. So this pool can work 365 days a year. Da Nang storms, and that would make impossible that if we put a typical rooftop pool. So we have a rooftop, green, and connects. I'm sorry for the other images, but basically what we have is this structure that has its own shape, generates these intermediate spaces. All the aluminum, glass, and all this highly technical solution is behind. So that's one of the ways to simplify this facade or this building. These shapes can be complicated to make real everywhere, but maybe even more in Vietnam. So sorry for the images that were lost. Another project, so this was mixed use. This is a residential project. Again, sort of lead consultant. Here we have FCD for facade, icons for structure, avoidance, engineering that helped us a lot with the analysis of this, Bell Collins and CIL Vietnam. This project is on hold, but the principles are, let's say, the same. We have a structure that defines the shape of the building, the shape of the towers. We have apartments, branded residences, and the vertical structure defines the shape of the towers, and with these horizontal bands, what we have behind that is a perimetral balcony. Sometimes it's a faux balcony, sometimes it's a real balcony, but we have this intermediate space. And this intermediate space helps us from many points of view. From the aesthetic point of view, we are not seeing the accumulation of units that we can identify. As Chris mentioned before about city garden, you know, we have something that from the design point of view, we have the control of the building, not the units. But all this perimetral thing is generating is a shading device. So avoidance helped us to analyze many different scenarios. So what would it happen if we work with a conventional facade, aligned, you know, to the boundaries of the slab? You can see in terms of thermal comfort, no, everything becomes red, too hot, you know, energy demand, daylight. With this horizontal faux balcony, this 600 millimeters, scenario changes dramatically, and the vertical columns may add something there. So that's something interesting coming from that, those analyses made by Boydens, that only with the design, with the shape, with these balconies, the reduction, you know, thermal comfort, the time that needs to get to the right temperature or energy demand, has significant improvement. If we want to improve that based on materials, type of glass, and this type of things, we have an improvement for sure. But the significant one is here, okay? And this doesn't cost money, basically. Well, we should have some help from authorities, and one day maybe the local codes could consider the CFA in a different way. So the code could one day stimulate the fact of having intermediate spaces. So from the thermal point of view, this transitional space is making the biggest differences, not the materials. We are not relying on the technical quality of the components as in the first instance. That's a complement. Finally, I want to talk about this project. We worked for a while on this Fulbright University campus, and here we have help by Green Viet and Inhabit with facade, and Green Viet with simulations and analysis. That's something interesting in this project. The concept design comes from New York. So it was done by shop architects. And it was great design, okay? So I cannot say anything as an architect. As architects, we always criticize every other architect. No, it's a great design. However, and we talk specifically about facade, what we see in the design intent that is really interesting. This was a single layer terracotta facade with some tiny louvres, you know, and this was applied to all pavilions. We thought that there was some room to improve that significantly. The first thing is that not every orientation deserves the same treatment, okay? Adaptability, flexibility, you know, maintenance, many things. We thought we had some opportunities to improve, and also, of course, cost implications, and particularly for educational facilities, maintenance things. So basically what we started to work is with splitting that single layer facade into two. An extra layer lighter, so we forgot about terracotta in this case, and to work with more suitable materials here, and with a scheme that could vary depending on the orientation. So with more or less louvres depending on the orientation, and also this extra space that is light could help to generate a maintenance corridor, let's say, or outdoor space that in terms of maintenance could be extremely helpful. So basically this is the evolution. So from the design intent or aesthetically point of view, we try to keep what came from New York, but that was the problem. We are not in New York. And so then what we tried is to develop that in a way more suitable to Vietnam, and within Vietnam to the different orientations and the different needs that this building could have. So the result from the aesthetic point of view respect the original design, but the solution we consider is much more suitable for the local conditions. So then, this is, after seeing these few examples, I wanted to talk about this. I started with the water cube. I said this is a good example of consistent architecture. So then we have places, we have trends, you know, worldwide we have and we see. Sometimes our clients go in holidays to some exotic place and they come back plenty of new ideas about how to do their buildings. But sometimes that's not particularly consistent with where we are. So, can you imagine this happening in Saigon? Would you dress like that in Saigon? Would you dress like that if I explain you that this is a super new treatment with composite materials and you will feel fresh with this? I tend to think that no. So I haven't seen, well, I can say that ladies, when they go in motorbikes, they put some layers of things, but not like that, okay? However, this is happening in Saigon, okay? I don't want to be misunderstood, okay? But for me, every time I see glass boxes in Saigon, south of Vietnam, and even in Hanoi sometimes, I feel particularly uncomfortable. So maybe you might have heard about stories of some buildings with 65, 70 degrees inside. So, and we see residential buildings, multi-residential buildings, full glaze, 360. It's like before, no? This particular polar dress. So that's important, okay? Because buildings operation is a big issue. And we shouldn't be confused by the fact that we are living, particularly in multi-residential sector, a highly speculative market based on property only, okay? All the buildings that are not based on property, based on performance, pay a little bit more attention to that. We need to understand that. I think we cannot give the energy for granted forever. Nowadays, we are having restrictions for gasoline for our cars and motorbikes. how long would we survive working or living within glass boxes if we cannot switch on the air conditioning? Nowadays in Europe, they cannot switch on heating systems. So when we analyze what the case studies in a simple way that I mentioned, yes, we can start from a simple facade, single layer, and the different gradation of circumstances depending on how we work with a layer or multi-layer facade. None of them is wrong. None of them is wrong. What can be wrong, in my view, is where we apply these solutions. If we are in Toronto, Canada, that could be great, okay? If we are in Copenhagen, but maybe not in Ho Chi Minh. So this is all about coefficients, energy, thermal comfort, air conditioning, but I would like to go a little bit beyond that because for me, the key thing is about the cultural issue. So what would be the value of this building without those balconies? Would this building work in the same way that is working right now if we remove the balconies? So, particularly in the south of Vietnam, life is what happens within these transitional spaces, under the tree, shadows, alleys, human scale spaces, generally speaking, protected from the sun and from the rain. So that makes more sense than the photo I showed before with people dressed to ski in the snow. So this transitional space and how we work with the facade as space where many things could happen, where we could work together applying different techniques, technologies, more or less advanced, more or less expensive, but this is the approach, this approach that in here, in Vietnam, and in particular in the south of Vietnam, we need a buffer. We cannot be exposed directly to the weather. I was born in Argentina. I lived in Spain, Australia, now in Vietnam. I'm an architect. Wherever I am an architect, you know, I do architecture for the place. So if I'm working here, I'm doing Vietnamese architecture, okay? And that for me is a sort of responsibility. I cannot do or import whatever. Cannot import from Dubai, from New York. This is Vietnamese architecture, and this will remain here. This is City Garden, was mentioned before, and we can be proud about that. So my last slide is a non-winning competition from last year that I was particularly proud about this competition because all these principles that I'm mentioning were reflected. I'm showing some in a way that you cannot identify where and whom and all the things, but here was all about generating every kind of intermediate space from the urban scale to the domestic scale, and because this is a mixed use, but mostly residential. So how to integrate greenery, public space, how to remove cars and motorbikes and allow for pedestrians. So we didn't win. I assume the winning proposal must be better, for sure. Maybe not. I know the original master plan, and I tend to think that maybe one day I will see in that place a group of glass towers. For me, it's not the right way. So from my particular perspective, all the capacities that we have here today, we are perfectly able, I'm more than confident that we can do things correct. We can do things perfect, but we can do the things right. But the important thing for me is to do the right things. I'm not sure if we are doing the right things right now. So we need to do good architecture, to leave a good legacy to our cities, to build our cities. We need teamwork, authorities, clients, all of us, to deliver what our cities deserve. So my thoughts, my short thoughts, and the nap time were only about that. I hope we can work together to do the best Vietnamese architecture possible and to be proud about what we deliver to the city, not only to our chairmans. Thank you very much.
Xin được trân trọng cảm ơn phần chia sẻ và trình bày đến từ Mr. Julian. Thank you very much, Mr. Julian, for your great and insightful presentations in our conference today. Kính thưa quý vị, và tiếp nối chương trình, xin mời toàn thể quý vị, chúng ta sẽ cùng tiếp tục lắng nghe phần trình bày liên quan tới chủ đề, đó chính là thắp sáng mặt dựng của bạn, thông qua phần chia sẻ đến từ hai đại diện của Sahvia Group, đó chính là Mr. Ahmed Sumair, nhà sáng lập, giám đốc của Sahvia Group, cũng như Mr. Tommaso Frizzale, Phó Giám đốc phụ trách phần ánh sáng của Sahvia Group. Ladies and gentlemen, and now we will have the chance to meet two representatives of Sahvia Group. Please raise a big applause to warmly welcome Mr. Ahmed Sumair and Mr. Tommaso Frizzale.
Xin chào Hanoi. So here we are going to speak about the lighting the facade. And we believe light is alive. Whether it's a daytime, in the night, the natural or artificial, to reveal the every object of society, to understand the architectural interior and perform the normal life, we do require both artificial and natural light. Here, without the light, there is no color. You need a source from natural, as I said, artificial, to observe and to enjoy the colors of life. Myself and my colleague is going to discuss about how to light up your facade.
So good afternoon to everyone. Let me start with this lighting journey that we will go through presentation of the lighting in the architecture. But first of all, we want to introduce the concept of light linked with the technology, because lighting is just expression of modern technology. And for this reason, each era has his kind of technology and his kind of lighting. It means that lighting make characterize any kind of age. So starting from that, we can understand that we has done a big improvement, starting from the power of the candle to arriving to the modern LED that can give us a lot of opportunity to express our lighting design in the facade. Then, according to that, we can understanding that the power that we starting from a simple candle that we are having 0.1 lux, that we can arriving to the modern more than 300 luminous lux. Then in this way, a big step we have done in this way in the architecture. So from what we use for our inspiration, because our inspiration starting from the natural lighting, because also natural lighting has his cycle during the day from sunrise to the sunset. This is important because lighting is linked with the human activity.
So let's take a step back in a time where there is no artificial light And whatever the an ancient architecture is designed using a sun path, and also the facade systems and facade materials are completely old, stories of their spiritual and some the kingdom stories and all. This is one of example like Itfu temple from Egypt, where you can see, I can say like this is a completely like a old sort of facade where we have some sculptures, some paintings and all. And nowadays we clad our buildings with the facade, different materials and all. So these sort of ancient architecture, they have used a natural light, they have designed in a such a way where they can get a possible natural light inside to perform the day activity. Also for a good society and aesthetic.
Then also starting with the lighting, we can also thinking about lighting using, for example, for Roman architecture, that they starting to use in a very significant way the lighting, that from the ceiling the lighting can hit the surface of the podium, interior podium, and then in this way design a first kind of lighting design. For this reason also modern teachers that they has using, for example, like Le Corbusier or, for example, Tadawando in the recent years, they're using the facade and the lighting from exterior to design the space, as well as Jean Nouvel in the recent year that also for this reason, he also used facade to enlighten also interior, create a lighting design through the sun. But what happens to architecture at nightfall?
Yes, that's the right question actually. What happens to architecture in the night? Where the architect and the consultant has designed very beautiful architectural, the lot of facade element and features, cantilever balconies, cantilever canopies, some different parametric facade and all. But when night falls, how we are illuminating and how we are enhancing the architecture and how we are integrating and talking to the community with the facade and lighting. So if you see the satellite view, so the intensity of lighting globally, if I talk specifically about Vietnam, so the three cities, Ho Chi Minh, Da Nang, and Hanoi, have a more intensity of lighting, where architectural buildings also contributed as well as the infrastructure lighting. Similarly, globally, when you see for architectural lighting, it's more developed, lot of dynamic design, lot of interactive and communicative lighting has been developed, media facade has been developed, and we believe it's require artificial lighting in the night to enhance more our architectural facades.
So here, let me introduce some our technical and some other artistical lighting regarding some projects that Wind Park, Sunbay.
Sunbay, then King Crown we do have here, Cybertham and Hontre.
For this first project, this is for a Wing Group and this Wing Homes Hotel. This lighting concept, we're starting to thinking the possibility where we can install, in which way we can install lighting. Then starting to that, we had inspiration from a local flower, the plumeria flower, to give a special kind of delicate, very delicate kind of lighting. Very few light, but a great design for that. So very minimal lighting, but important kind of effect, especially for from the rooftop, that remember petals, flower petals for us. And we gave a special kind of lighting to enlight this canopy on top.
Yeah. When it comes generally, the society says the residential projects doesn't have a much facade lighting. It's have some concerns also, and that is true, like the end user should not be disturbed with the artificial lighting who's going to stay in the building. So we design in such a way which is not going to directly affect to any end user for our residents of this building. So you can see some of like for a crown we are highlighting with the different grazers, where the challenge here is like we have a 2200 Kelvin temperature for soffit, and for a RCC band we have a 5000 Kelvin. So two elements, two different temperature we have to maintain there, and with hiding a source also. Then when it comes to entry, we have a cantilever canopy, where the canopy fascia is cladded completely with the ceramic frayed glass, and we are grazing with a simple single RGBW linear. The source is hidden into a aluminum channel here. And also the powder coated with the same finish of ceramic fret. And these are some downlighters to graze the canopy. And fixtures, you can see. Now, when we propose any option, like a multiple option for a client to decide, to understand the budget, to understand, and also play a different scheme on a weekends and working days. Also, we have shared load calculations for every option, where the electrical and MEP team can easily analyze and they can design their electrical consumption accordingly.
The next on-track port, for this project that is a port, we have thinking for going the facade lighting, then also giving a highlight for the column tower regarding concept, and then the domes, the glass dome. Regarding facade atmosphere that we want to give is a kind of atmosphere like underwater effect. And to work on that, we also give to the dome a great effect like fish jelly. Fish jelly, it means that we has inspiration from some kind of color effect. And then regarding special ideas, special events, we linked this with the myth of Poseidon to create also a fantastic story to project like a visionary image also under the dome during the waiting time of the visitors. So this is some sketch that we have prepared, some preliminary sketch. And this is the simulation of the waterfront, that we can see default light for the two frontal tower. Then we can see in the next lighting, this is the lighting that is a full bright lighting without dimmering in this case. Here some bright color and also changing color for the roof of each tower.
And here are some fixtures, the classical form, and also we try to integrate these fixtures emerging with the geometry of the project, also the material and the finishes what we are using in the project from the architect side. We are powder coating all the fixture and integrating and hidden sources. So when it comes to a Sun Bay, this is a hotel and resort project in Ninh Thuan. So here the geometry, the building scheme, we adopted from a dragon, a golden dragon. The geometry also says the curvature and the podium, and when you see the water activity and also it depicts the dragon movements and all. And the adoption and the inspiration we took from a dragon, and we try to come up with some simulation and dynamic lighting which can be very attractive. It's a comprise of a 3,000 key hotel, then service apartment we do have, and water and sports activity. So here you can see the uplighters, the fixture dot lights integrated with male-female connectors we do have. And the other side, we don't have a much crowd to see. And we have a very simple lighting in the balconies integrated in a railing, glass, and some uplighters. And the crown, we have some dramatic light. Whatever activity is going to be happen in the entertainment area, we are going to show on a crown. Then these are some renders we did for the project, different moods, different time, and these are some fixture details. So these kind of dot lights, 100 of dot lights is installing on a facade. It's a male-female connector and all, and with pre-programmed and multiple options.
Then for this other project, King Crown Infinity in Ho Chi Minh, for this project we linked this project with the nature, because the building is really linked with architectural idea of greenery and also a lot of vegetation inside and outside. So for this reason, we linked this with a kind of natural effect. So starting with our sketch, we're thinking for the two front of the building to use that, give us opportunity to use like a waterfall with the technology directly linked with the glass. And then in this way, we are working for abstract this concept.
So here the facade completely is converted into a media wall. We have integrated the glass panels in system. The LED glass panels is an add-on profile we have added, and the add-on media glass panels integrated to them, and completely like in a different panel sizes. So we have around 1.2 meter by 2.5 meter and different sizes also in the project. These are some example like how after installation and commissioning is going to be seen. So we can play any stories and any scheme, and after installation any customization also we can do very easily for that. These are some example like a very thin film of 1.2 mm thickness. It's like a non-hygroscopic layer, and between two glasses going to be a sandwich panel.
And this is what happened for podium. That we try to give a kind of soft light for the wall podium, and then the big lighting screen, light screen in the angle, in the edge, that in the corner, yes, give us opportunity to create also attraction for advertising, and link also the color of the building with the advertising, because this give more opportunity for that. According to that, we has also possibility to create kind of animations that we design some kind of animation specifically for the building to create more attraction.
Here we bring a Cyberthumb. It's a twin towers, G plus 48 story twin towers, and at 36 level we do have a hanging eggshell of 3 floors which act as a transfer floor and observatory and some like a high-end hospitality.
And then regarding that, the observatory in the middle, we starting to focus attention on that to give opportunity to use this kind of egg to transforming our visionary idea of lighting. And we starting to that, we create a kind of world in the surrounding, like a technical and more futuristic vision for the tower. Here there is the simulation that we starting from the observatory, and then we moving on the tower. The tower has a kind of animation that in 3 primary colors, and in yellow, red, and blue. And in this way, give us also opportunity to create different layers of animations.
So this is a project name is a Cyberthumb. So we started inspiration taking like a cyber information transforming into tower A to tower B. And the source is the hanging eggshell. And these are some example where we do have a big vertical fins and smaller fins is staggered form. And we try to adopt the same fin, and we accommodated this LED fixture into it. Like for this is a smaller fin and this for the bigger one. These are some example like during execution where we have closely worked with the facade contractors and facade consultants also here. Like a provision, keeping a provision system. Then now comes to the eggshell. This is completely a free-form structure in a nodal form. On the roof, we do have a complete dynamic lighting. This area is completely going to be observed by the upper floors, and we do have the ceiling also leading in the same time. So the panels are triangulated, double laminated DGU with add-on LED glass panel into it.
And then regarding the ceiling and regarding the floor, we had the opportunity to create a multifunctional kind of floor, because with this lighting floor we can have interaction with people, so the people decide and the people modify the colors, and in the same way in the top and the bottom of this egg we can also have opportunity to create a lighting show. But for this reason, what are provision and challenges for the future?
Yeah, there are challenges and provision we need to have before designing and in the concept stage, and where what we observe and experiencing day by day during our practice is appointment of all consultants should be in the same time, where they can work and they can understand from architect their storyline and integration between the electrical points and facade lighting consultant and facade engineering consultant and the drafting of methodologies. So this is a key factor. If anyone is late appointment, that can affect, let's say like if you have appointed a facade consultant and the architect is already there in the electrical consultant, but no lighting consultant. In the future, when they come up with a design, some concept ideas which is liked by client and architect, but how to integrate, because already facade consultants already done the complete engineering. So this integration is a very key thing here. So we believe the closely coordination in the same time is a key to complete the proper design. Then once contractor on board, all respective consultants have to sit on the same table and draft the methodology to how to integrate it. The reason behind is if we don't integrate and we don't draft the methodology, in advanced stage, when you are going to put a lighting fixtures on facade, there are multiple punctures required for a power supply, for a driver's locations, and which may go in a different direction and will not have a good and right amount of lighting on a facade. Thank you.
Thank you for your attention.
Thanks, sir.
Thank you so much.
Thank you.
Xin được cảm ơn phần trình bày đến từ Mr. Ahmed Sumair và Mr. Tommaso Frizzale. Kính thưa quý vị, và ngay sau đây thì xin được mời toàn thể quý vị chúng ta sẽ cùng lắng nghe phần trình bày và thuyết trình liên quan tới chủ đề đó chính là hệ thống năng lượng BM Windows Facade thông qua phần chia sẻ và giới thiệu đến từ Mr. Roger Karl Scharer là giám đốc kỹ thuật của BM Windows. Ladies and gentlemen, coming up next, I would like to invite and welcome on our stage the technical director of BM Windows, Mr. Roger Karl Scharer. Please raise a big applause, please.
Thank you, ma'am. Good afternoon, ladies and gentlemen. It's a pleasure to show you my company and the presentation about our capabilities. We are BM Window, and we are one of the biggest facade execution contractors in Vietnam. The presentations up to now had a lot of good theoretical know-how, but we think we are the executioners, and we are the ones who make your facade, your skin happen on your building. The contents of my presentation is Vietnam facade industry before 2016, facade system in Vietnam after 2016, and facade industry at the present. I'll walk you through this past few years in regards to the facade industry. Before 2016, in Vietnam, we had mainly small windows or even no windows, just brick and concrete. And then we went to better performance. They introduced glass, single glass. And after that, we had some conventional systems like stick systems with also single glass. These are some buildings where you can see small windows and stick system for high-rise buildings, which is not really suitable. These are unitized curtain wall systems, mainly executed by foreign companies and imported into the Vietnam market. After 2016, BMW was formed, and we also started with simple doors and windows. The design philosophy at the time was contemporary facade system feature, slimline appearance, and high quality design, and the perfect integration of functional units combined with optimum performance. We concentrated on windows, mainly sliding systems here is a big feature for many, many buildings. Then we went into curtain wall system and cladding system. Door and windows and doors and sliding doors, like I said, is still a big topic here, big feature. Everybody wants it. Everybody is looking for high performance on those systems, which is difficult to make unless you are ready to pay out additional money for enhanced performance. We design also our own systems. For example, this is a casement door system where we specifically pay attention to architectural desires. Here you can see some of our details, our custom designs. They are simple but suitable for the Vietnam environment. The concept of the concealed sash fits into the trend of the required architectural concept. This is our custom designed sliding window design, which you can have with double glazing or single glazing. Maximum size we currently can do is 2 by 3 meters with a narrow style interlock of about 30 millimeters. Once again, our system is made specifically for the Vietnam market. After the first 2 or 3 years, we went into curtain wall systems, so-called unitized systems. From conventional to semi-unitized to really unitized curtain wall systems. The unitized curtain wall system, as you probably all know, have several advantages from quick installation to quality and warranty superiority, easy transportability, efficient installation, and highly configurable. Currently, we are executing this building downtown. You can see the actual stage of the project is in about floor number 4. We have completed VMU, PMU, and this is a section of the actual facade. This is another project under execution. This is already on floor 10. Starting facade installation within a month or 2. This is a reference project we have here in Hanoi. You can see here the architect cleverly designed these curves into the glass by different angles of the glass integrated into the unitized curtain wall frame. This is the Viettel headquarters in Hanoi. which we did with Technal together, a very high quality system. We also do cladding. For example, in Hanoi, we did a project where we have terracotta, or this building is aluminium cladding for the Vietel data center. It is actually not an air or watertight facade, it's just a mask or a screen outside the building. This is the terracotta I was referring to before. We have a curtain wall unit unitized and then a row of terracotta. The project here was Kobe Tower in Ho Chi Minh. Vietnam facade industry at present is growing. What you can see here is our factory where we do custom designed facade execution. What we basically do, we buy the aluminium profile, custom designed by us. We buy the glass and we buy the other components and we assemble it all together. This is our factory. You can see here the high-speed circular saws where we cut the aluminium to lengths. Then it's transferred to the CNC machine, which are computerized numeric machines. They have toolboxes of 8 different tools to do milling, drilling, notching. And after that, they are moved, profiles are moved to the assembly line. And the curtain wall unit frames are assembled. We also do structural glazing. Structural glazing booth you can see over here. And when the units are finished, they are loaded and shipped to site for easy and fast installation. This is some structural glazing procedure. Also, we make corner units complicated. How do you go back? Previous, okay, got it. Okay, thanks. Customized facade system. Basically, what we do is we optimize the budget. We are very cost conscious. We ensure time completion and we tackle sustainability as much as possible. In the graph, you can see the different operations we do before we can or are able to supply the units to site. One of the recent buildings which we did is the IFC Tower in District 1, which was a special custom design because it was actually 2 facades on top of each other. You have the main facade here, and we have the triangles which are mounted on top of each other. The main facade and the triangle, which was installed in front of it, and the triangle is operable, so we can go inside and clean the glass. The physical properties of the glass of the facade is shown here in this table. And what is also remarkable is we had about 8 different colors for the triangles. This is a short video clip about the assembly of the triangles. Okay, I think we have no sound here. Go to the next one. We also are very adamant about quality control. All our units leaving the factory have been double and triple checked. You can see here our facade quality control office established in the factory. We have specific procedures, especially to structural glazing, where we get the support from the silicone suppliers. Then the quality control consists of establishing of a construction plan, the construction quality disclosure, curtain wall performance test, quality inspection during construction process, the construction performance test on site, and completion and acceptance, and after-sales service, and hopefully get payment. This is a few pictures during the process of the IFC dragon skin facade. We incidentally completed in 1.5 months. 2,461 glazed panels within 49 days, including 100% quality control and acceptance by the client.
One of the biggest challenges was the time constraint for the execution of the entire project. For this, we had to slightly modify the original facade design concept without compromising the overall appearance of the architect's design intent. This exercise also resulted in having some value engineering effect, reducing the original budget and shortening the fabrication time considerably.
Điểm phức tạp nhất của dự án IG1 Sài Gòn là một thiết kế hệ vách kính Unity cấu thành từ các vách kính góc khúc 178 độ tạo nên mặt cong tổng thể liền mạch, kết hợp trên đó là hệ không nhôm 7 màu vách kính tam giác gắn bên ngoài tạo nên một thiết kế đẳng cấp.
Đối với dự án này thì tổng khối lượng là hơn 20.000 m². Khối lượng này thì không phải là quá lớn đối với BM Windows. Tuy nhiên là tiến độ của dự án là cực kỳ gấp. Tất cả công tác sản xuất là chỉ phải hoàn thành trong thời gian là không quá 25 ngày. Để đáp ứng được cái tiến độ như vậy, trước tiên là công tác vật tư điều phối về nhà máy thì chúng tôi phối hợp với phòng mua hàng của công ty, phòng kế hoạch. Toàn bộ công tác sản xuất chúng tôi phải tổ chức lại mặt bằng, sắp xếp lại nhân sự, tức làm 2 ca, cũng như là đội ngũ.
Okay, as you can see, we are a very serious facade fabricator, and if you do have any project, we be ready to help you. Thank you very much.
Xin được trân trọng cảm ơn phần trình bày và chia sẻ đến từ Mr. Roger. Kính thưa quý vị, và ngay bây giờ chúng ta sẽ có cơ hội được gặp gỡ một vị diễn giả đến từ Việt Nam. Ladies and gentlemen, and next we will have the chance to meet the Vietnamese speaker at the conference today. Và tiếp nối chương trình, xin mời quý vị chúng ta sẽ cùng lắng nghe phần trình bày và chia sẻ đến từ bà Hanna Nguyen, Giám đốc Kinh doanh Toàn quốc của Azo Nobel Powder Coatings, với phần chủ đề đó chính là công nghệ sơn bột tĩnh điện cho môi trường xây dựng. And now, ladies and gentlemen, please welcome on our stage Country Sales Manager at Azo Nobel Powder Coatings, Miss Hanna Nguyen. Please welcome.
Xin chào quý vị đại biểu. Sáng tới giờ chúng ta đã nghe rất là nhiều bài tham luận từ các quý vị đại biểu từ các công ty đưa đến, và hầu hết là bằng tiếng Anh, đúng không ạ? Bây giờ để thay đổi không khí cho buổi hội nghị ngày hôm nay, tôi xin trình bày bằng tiếng Việt và tôi nhờ bạn phiên dịch viên sẽ phiên dịch qua tiếng Anh. Thì tôi là Hanna Nguyen, tôi đến từ công ty AkzoNobel, là một công ty sản xuất sơn bột tĩnh điện hàng đầu trên thế giới. Và chúng tôi có 2 nhà máy ở Việt Nam, một nhà máy ở thành phố Hồ Chí Minh, ở Đồng Nai và một nhà máy ở Bắc Ninh. Tôi bắt đầu bài tham luận của ngày hôm nay bằng một câu chuyện kể về một cậu bé, đó là cậu bé tên là Ân. Thì Ân là một cậu bé 12 tuổi, cậu sống ở trong Bình Dương. Cậu là một cậu bé rất là năng động và rất là thích những hoạt động dã ngoại, cũng giống như là chăm sóc những động vật hoang dã. Thì thông qua tin tức thì cậu được biết rằng là mỗi năm trên thế giới thì có khoảng 1.000 rùa biển bị chết vì lý do là ăn phải chất thải nhựa mà không thể tiêu hóa được. Thì cậu rất là tích cực tham gia vào những chiến dịch của kêu gọi của địa phương, cũng giống như là của trường học về nhặt rác thải ở bờ biển. Nhưng mà vài tháng sau cậu quay trở lại bờ biển thì cậu lại thấy được rằng là rác thải vẫn ở đó. Thì cậu mới tự đặt ra câu hỏi là tại sao chúng ta không tìm một vật liệu thay thế cho những bình nhựa sử dụng một lần. Như là học sinh họ sẽ đem tới trường bằng những chai nước mà sử dụng được nhiều lần. Những chai nước đó có thể được làm bằng từ tre, có thể được làm từ những nguyên liệu là có thể tái được sử dụng nhiều lần, như là bằng nhôm hoặc là bằng sắt thép và sơn lên. Thì rác thải mà sử dụng một lần thật sự ảnh hưởng rất là nhiều đến môi trường của chúng ta. Một sự thật là khi nói về rác thải thì chúng ta thường hay nghĩ đến là làm thế nào để hạn chế việc thải những cái sản phẩm chúng ta sử dụng ra môi trường một lần thôi, mà chúng ta chưa nghĩ đến là cả một cái vòng đời của sản phẩm. Thì tại AkzoNobel của chúng tôi thì chúng tôi lại quan tâm đến cả dòng đời của sản phẩm, và chúng tôi sẽ phân tích sản phẩm từ lúc mà chúng tôi mua nguyên vật liệu cho đến khi sản phẩm đó được sử dụng tại khách hàng của mình. Thì chúng tôi nghiên cứu về cái vòng đời sản phẩm và chúng tôi chia ra làm 3 phạm vi. Phạm vi 1 và phạm vi 2 đó là những ảnh hưởng từ chính nhà máy sản xuất của chúng tôi. Ví dụ như là nguyên vật liệu chúng tôi sử dụng ra thì trong quá trình sản xuất thì tiêu hao năng lượng như thế nào, khí carbon thải ra môi trường là bao nhiêu. Và phạm vi thứ 3 chúng tôi gom lại đó là từ nhà cung cấp và từ khách hàng. Từ nhà cung cấp chúng tôi đó là những nguyên vật liệu đầu vào chúng tôi sử dụng như thế nào. Các nhà cung cấp đó có cùng với chúng tôi mang theo chiến dịch là hạn chế rác thải ra môi trường hay không, hạn chế khí carbon ra môi trường hay không. Và tại từ khách hàng của chúng tôi, từ khâu phân phối và sử dụng sản phẩm. Trong việc sử dụng sản phẩm thì chúng tôi đưa ra những hỗ trợ về kỹ thuật cho khách hàng để làm thế nào để khách hàng sử dụng nguyên vật liệu một cách hiệu quả nhất và hạn chế rác thải ra môi trường nhiều nhất. Thì khi đó thì chúng tôi cũng tham gia và được approve, được duyệt để tham gia vào chương trình SBTI, đó là Science Based Targets Initiative, là mỗi năm chúng tôi sẽ giảm thiểu khí carbon thải ra môi trường. Và cam kết của AkzoNobel là đến năm 2030 thì chúng tôi sẽ giảm được tới 50%. Đối với dòng sản phẩm sơn bột tĩnh điện thì chúng tôi đã cam kết về bảo vệ môi trường thông qua một cái giấy chứng nhận của một tổ chức, đó là giấy EPD Environment Protection Declaration. Giấy này được ứng dụng trong tất cả các dòng sản phẩm Interbonde đạt được tiêu chuẩn của AMA 2603, 2604 và 2605. Nếu như mà những công trình mà sử dụng sản phẩm của Interbonde của AkzoNobel thì được cộng điểm vào để chứng nhận là công trình xanh. Quý vị có thể là sử dụng hoặc là tra thông tin của giấy chứng nhận này trên hệ thống của AkzoNobel hoặc là trên đường link. Thì có một số câu hỏi sẽ hỏi rằng là nếu như vậy thì sơn tĩnh điện của chúng tôi làm thế nào có thể là ngăn ngừa được hoặc là giảm thiểu được cái khí thải ra môi trường. Đây là những cái phương thức mà chúng tôi đang thực hiện. Thứ nhất là chúng tôi sử dụng những sản phẩm về free VOC. Thứ hai đó là chúng tôi hỗ trợ khách hàng tái sử dụng lại những sản phẩm sau khi sử dụng, thì có cái dòng sản phẩm thu hồi thì tái sử dụng lại. Nếu như khách hàng mà sử dụng đúng tỷ lệ theo phương thức mà AkzoNobel khuyến cáo thì khách hàng có thể sử dụng được là cái bột thu hồi đó là 100%. Thứ ba là chúng tôi có đưa ra một cái dòng sản phẩm mới theo cái công nghệ mới, đó là sử dụng nhiệt trong quá trình lưu hóa sản phẩm và sấy ở nhiệt độ thấp so với thông thường. Thì khi chúng ta sử dụng cái dòng sản phẩm thấp hơn để mà sấy sản phẩm so với những cái dòng sản phẩm thông thường thì chúng ta sẽ tiết kiệm được điện năng. Và một trong những cái phương pháp mà chúng tôi đang ứng dụng đó là cái công nghệ về màng phim mỏng. Khi công nghệ màng phim mỏng thay vì là sử dụng là 90 hoặc 120 micron thì có thể mình sử dụng ít hơn, thì cái phần tiêu hao nhiên liệu trên mét vuông sẽ giảm xuống. Và một phần nữa đó là chúng tôi sẽ hỗ trợ khách hàng để lựa chọn sản phẩm phù hợp cho từng ứng dụng của khách hàng. Bên cạnh đó, AkzoNobel cũng tiến tới vấn đề là cải tiến liên tục. Cải tiến liên tục chúng tôi thông qua thành có 3 phương thức. Một đó là chúng tôi tiếp tục phát minh ra những sản phẩm với công nghệ mới, thế hệ mới, với lượng tiêu hao năng lượng thấp hơn so với những sản phẩm thông thường. Thứ hai là dùng những cái nguyên vật liệu sạch. Và cuối cùng là hỗ trợ khách hàng tốt nhất để mà tăng năng suất trong quá trình sản xuất, cũng giống như là làm thế nào để sử dụng bột tiêu hao, thu hồi lại tiêu hao 100%. Thì đối với sản phẩm sơn bột tĩnh điện của AkzoNobel trong thị trường kiến trúc của chúng tôi thì chúng tôi rất là tự hào về dòng sản phẩm là Interbonde. Dòng sản phẩm Interbonde này thì đáp ứng được cả 3 tiêu chuẩn của AMA 2603, 2604 và 2605. Đặc điểm nổi trội của 3 dòng sản phẩm này đó là chúng tôi đều cấp giấy chứng nhận bảo hành cho công trình. Nhưng với điều kiện là những cái công trình đó, những sản phẩm thanh nhôm đó phải được sơn tại những đơn vị gia công được kiểm định và thẩm định và đạt được tiêu chuẩn của AkzoNobel đưa ra. Đặc điểm rất là khác biệt so với một số dòng sản phẩm đang cung cấp trên thị trường đó là việc chúng tôi bảo hành toàn cầu. Nếu như quý vị mà lắp đặt công trình đó ở Campuchia thì vẫn được bảo hành ở Campuchia. Mặc dù là sơn ở Việt Nam, nhưng mà nếu như lắp đặt ở Australia thì chúng tôi vẫn bảo hành ở bên Australia. Cái đặc điểm thứ ba rất là khác biệt của sơn bột tĩnh điện AkzoNobel Interbonde đó là chúng tôi bảo hành suốt cái giá trị từ năm đầu tiên cho tới giá trị của năm thứ 15 hoặc là 25, 35 năm là vẫn giữ không thay đổi. Chúng tôi không có thay đổi theo khoảng thời gian như những một số đơn vị khác là năm thứ 5 thì sẽ rớt xuống 30%, rồi năm thứ 7, thứ 8 thì rớt dần, mà đến năm thứ 15 thì chỉ còn 1 hoặc 2% giá trị bảo hành, mà chúng tôi sẽ bảo đảm được là 100%. Ngoài ra thì tất cả các sản phẩm Interbonde sau thời hạn bảo hành thì vẫn bảo đảm được, đó là về độ bền màu, chống chảy xước, độ phấn hóa và đặc biệt là độ bóng của sản phẩm vẫn giữ. Cứ mỗi năm, 4 năm một lần thì tại AkzoNobel, sản phẩm Interbonde chúng tôi sẽ tung ra một bộ sưu tập gọi là bộ sưu tập màu. Bộ sưu tập màu đó thì được các chuyên gia màu sắc của chúng tôi thảo luận và đưa ra những màu. Thì 4 năm một lần như vậy chúng tôi sẽ thêm vào một số màu đặc trưng theo xu hướng của thị trường và đưa ra khỏi danh sách đó một số màu mà xem như là đã lạc hậu. Những cái màu sắc như vậy thì làm cho những kiến trúc sư và những cái nhà thiết kế có nhiều cảm hứng hơn trong việc mà thiết kế và làm cho những công trình của chúng ta thì sẽ đẹp hơn. Thì đây là một số công trình tiêu biểu đã sử dụng sản phẩm Interbonde của chúng tôi không chỉ ở Việt Nam mà trên toàn cầu. Đây là dự án ở Bangalore, Ấn Độ, hoặc là 2 dự án bên kia là của Thái Lan và một dự án là cũng ở Ấn Độ đã sử dụng dòng sản phẩm Interbonde. Đây là một số công trình tiêu biểu của chúng tôi tại thị trường Việt Nam như là tòa nhà Times Square ở Đà Nẵng, VinFast Office, Chadwick School hoặc là Capital Place. Thì khi mà nói về màu sắc thì mỗi năm chúng tôi lại có một hội đồng chuyên gia cùng với hơn 150 nhà thiết kế và những gọi là stylist, hoặc chúng tôi sẽ dự đoán ra cái màu xu hướng của năm mới là gì. Những cái màu sắc của năm mới đó sẽ đại diện cho một năm. Như là năm 2021 sẽ là một màu khác, và năm 2022 một màu khác, và là sẽ năm 2023 là một màu khác. Thì mỗi năm như vậy cái màu sắc đó nó sẽ tượng trưng cho sự chuyển đổi và chuyển đổi của xã hội, cũng giống như là sự nó ảnh hưởng tác động như thế nào đối với các công trình của bên mình. Thì chúng tôi cũng xin giới thiệu đây là màu của năm 2023 được AkzoNobel giới thiệu. không chỉ cho ngành hàng sơn bột tĩnh điện mà cho cả những cái dòng sơn liên quan tới công trình của mình. AkzoNobel còn có cái dòng sơn Dulux trên thị trường, thì năm nay cũng là cái màu tượng trưng của AkzoNobel giới thiệu ra thị trường là màu lúa vàng, gọi là Will Wonder. Thì bên cạnh cái dòng lúa vàng, cái màu lúa vàng như vậy, nó gắn liền với thiên nhiên, làm cho con người hòa quyện với thiên nhiên hơn, gần gũi với thiên nhiên hơn. Thì bên cạnh đó chúng tôi còn phát triển thêm 6 màu rất là độc đáo và rất là dễ phối. Từ 8 màu này thì mỗi màu nó sẽ là một cái câu chuyện để cho kiến trúc sư của chúng ta truyền ra cảm hứng, và đằng sau mỗi màu đó sẽ là có một cái câu chuyện rất là hay. Thì hy vọng rằng là 8 màu này các vị có thể tìm hiểu của những cái màu sắc bên này ở trong cái gian hàng của chúng tôi bên ngoài sảnh chính ạ. Bên cạnh cái màu của năm 2023 thì chúng tôi còn có bộ sưu tập màu Anodize. Thì khi mà Anodize thì bộ sơn trước đây thì sơn bột tĩnh điện không thể nào có được cái ánh màu của Anodize. Nhưng mà hiện tại thì AkzoNobel có thể sản xuất được những màu sắc tương đồng với lại Anodize. Bên cạnh đó nó có những cái tính ưu việt của sơn bột tĩnh điện mà Anodize không thể có được. Ví dụ như là kháng thời tiết được và có thể sử dụng được ở những bờ biển, ở ngoài biển. Thời hạn bảo hành thời hạn sử dụng sản phẩm và bảo hành sản phẩm dài hơn. Đây là một số công trình đã sử dụng màu Anodize của chúng tôi cho công trình, ví dụ như là ở Việt Nam như là Teddy Museum, công trình ở Thái Lan và một công trình Trump ở India. Khi nói về dòng Interpol D thì chúng tôi rất là tự hào về dòng Interpol D 3020. Đó là dòng Interpol mà đạt được tiêu chuẩn 2604, AMA 2604. Thì với dòng Interpol D, chúng tôi có thể bảo hành cái màn phim lên tới 30 năm và đối với ngoại quan là đến tới 25 năm. Dòng phim này hiện tại vẫn đạt được chứng nhận của EPD, nên những công trình mà nếu như sử dụng cái dòng phim này thì chúng ta sẽ được điểm cộng vào là công trình xanh. Đây là một cái dự án tiêu biểu của chúng tôi đã sử dụng dòng D3020 và công trình này được lắp đặt vào năm 2004. Thời gian là khá dài đúng không quý vị? Và hiện tại thì nó vẫn giữ được cái màu sắc như là ban đầu và cũng giống như là độ bóng hoặc là độ phấn hóa thì vẫn đạt được trong tiêu chuẩn. Dự án thứ hai đó là được lắp đặt vào năm 2016. Sử dụng cả hai dòng, đối với sản phẩm ngoài trời là dòng D3020 và đối với sản phẩm trong nhà là dòng D1010 là bảo hành 10 năm. Đây là một số công trình tiêu biểu đã sử dụng dòng D3020 đạt được tiêu chuẩn 2604 của AkzoNobel tại Việt Nam, như là Viettel. Sáng nay cũng có một đơn vị trình bày rất là chi tiết về công trình xanh này rất là đẹp. Và sân bay ở sân bay Vân Đồn, tòa nhà Pikames Tower, đây là công trình ở bên Campuchia, tòa nhà Chipmunk. Một trong những cái sản phẩm rất là mới và khác biệt đó là sản phẩm về vân gỗ. Thường thì trước đây những sản phẩm vân gỗ của chúng ta thì nó rất là dễ bị bay màu quý vị ạ. Nhưng mà đối với dòng Interpol D, nếu như sử dụng cái nền là sơn của Interpol D cộng với cái giấy phim mà mình ứng dụng trên thanh nhôm đó đạt tiêu chuẩn là bảo hành 25 năm thì cái dòng phim chúng tôi gọi là STF, dòng vân gỗ này cũng sẽ được bảo hành là 20 năm. Và dự án mới nhất trong năm nay của chúng tôi đó là sân bay Phú Bài, chúng tôi cũng ứng dụng dòng sản phẩm đạt tiêu chuẩn 2604. Thì tôi xin kết thúc bài tham luận của tôi chỉ bằng một thông điệp, đó là đối với những cái sản phẩm mà chúng ta không thể thay thế được mà bắt buộc chúng ta sử dụng hàng ngày, nhưng mà chúng ta muốn bảo vệ môi trường, chúng ta muốn hạn chế được rác thải ra môi trường thì chúng ta nên sử dụng những sản phẩm có dòng đời dài hơn và chúng ta tận dụng tối đa cái dòng đời sản phẩm đó. Thay vì sử dụng những sản phẩm chỉ là 2-3 năm và chúng ta phải thay thế thì chúng ta có thể sử dụng những dòng sản phẩm lâu hơn, dài hơn để tiết kiệm nguyên vật liệu trên thị trường, cũng giống như là giảm thiểu rác thải điệp mà bên AkzoNobel đưa tới trong vấn đề là bảo vệ môi trường. Xin chân thành cảm ơn sự lắng nghe của quý vị.
Xin được trân trọng cảm ơn phần trình bày và chia sẻ vô cùng gần gũi đến từ bà Hanna Nguyen. Thank you very much for the very meaningful sharings from Miss Hanna Nguyen. Kính thưa quý vị, và ngay sau đây xin mời toàn thể quý vị chúng ta sẽ cùng nhau tìm hiểu về nội dung liên quan tới việc thiết kế bằng kính cho không gian phòng với phong cách tươi sáng và mát mẻ thông qua phần trình bày và chia sẻ của Mr. Chengde Huang, giám đốc kỹ thuật của CSG Architectural Glass. Kính thưa quý vị, vì một vài lý do mà Mr. Chengde Huang không thể có mặt tại sự kiện của chúng tôi ngày hôm nay. Vì vậy, xin mời quý vị chúng ta sẽ cùng theo dõi phần trình bày của Mr. Chengde Huang thông qua trực tuyến. Ladies and gentlemen, coming up next we'll have the sharings, the presentation from Mr. Chengde Huang, Technical Director of CSG Architectural Glass. For some reason that he cannot be appear today, so I would like to invite all of you to listen to his stories, his presentations through virtual platform. Please enjoy.
Hello, ladies and gentlemen. This is Chengde from China Southern Glass, the leading low-E glass manufacturer in China. Today, I'll talk about our understanding of the performance of low-E glass and the application experience in creating bright and cool room space. Hopefully, it will be helpful for doing projects. My presentation will be in 3 parts, namely effective prevention of heat accumulation, aesthetic effect, and jumbo size AGU. First, let's talk about effective prevention of heat accumulation. As everybody knows, solar radiation contains 3 parts of energy: 47% visible light, 51% air, and 2% UV. In cities, buildings are always surrounded by other buildings. Low-E glass on the surrounding buildings reflects solar radiation. Low-E glass reflection contains about 10 to 45% visible light and 55 to 90% air radiation. Both the direct solar air and the reflected air are shortwave air which can pass through Malvinder glass, entering inside, causing room temperature rising, and then turns into long-wave air which cannot pass through the glass. This results in heat accumulation, and the room temperature becomes higher and higher. The shortwave air is the major heat source of temperature rising. To create a cool, comfortable room space, it's a must to prevent the shortwave air radiation from entering inside. This can be achieved by proper application of low-E coated glass. The long-wave air radiation from the surroundings can be effectively limited by lowering the U value of the window glass. And then the question is, what's the effective approach to limit the shortwave air? When doing projects, glass performance is always specified by G and U value. Let's look at the transmission spectra of 3 different glass products with similar G value. As you can see here on the diagram, the red line represents single silver low-E, the blue line represents double silver low-E, and the green line represents triple silver low-E. The 3 glass products have almost the same G value. That means the same shading coefficient. But as you can see, the energy transmitted inside is different. The 777 low E transmitted the maximum visible light and almost no IR radiation. The single 7 low E transmit the lowest visible light and the maximum IR radiation. The more IR transmitted, the higher the room temperature, and the least the visible light. That means more power consumption. So the same G value does not mean the same energy efficiency. To clarify the performance difference more effectively, we have defined a new term called total solar air transmittance, GIR, to measure how much solar air is transmitted inside. That's to say, focusing on the major heat source of room temperature increasing. With quantitative parallel analysis, we can find the best solution for bright and cool room space. Let's see technical data. In this table, 5 typical glass products are listed. On the top is 777 low E. The second one is 777 low E. Third one is single 7 low E. The fourth is 2 coatings, reflective plus single 7 low E. And the fifth on the bottom, so reflective product. All of the 5 products have almost identical G value, that is 0.29 around. However, when you look at the air transmitted, the GR value, you can see that it's obviously different among the 5 products. 777 low E has a GR value about 3.9%. 777 low E about 9.4%. Single 7 low E about 18.3%. And 2 coatings, 22.7%. The refractive coating, 28%. The higher the GR value, the more IR radiation transmitted inside. That means the higher the room temperature. The reflective glass has a GR value 28%. So it's clear that even with the same G values, about 0.9%, but the GR transmission is obvious different. That means the air radiation transmitted inside is different. The higher the GR values, the more solar air transmitted inside, the higher the room temperature, the more energy consumption for air conditioning systems. Among the 5 products, it's clear that the 777 low E is the best for creating a bright and cool room space. Next, let's look at the effect of variation in coatings and substrate. To meet the performance need of a project, we may have different approaches. In this table, we show 3, just as example. For projects, it's need a G value of about 0.18. In this table, we show 3 different approaches. The first is 777 low E on no iron glass. The second, we can apply double silver alloy on gray glass to achieve a G value about 0.18. And the third approach, we can apply single silver alloy on gray glass to achieve the same G value. But when we look at the GR values, the triple silver alloy on non-iron glass only about 2.8%. The double silver alloy on gray glass has a GR value about 10%. The single silver alloy on gray glass has a GR value about 13.3%. Again, the higher the GR value, the more solar IR radiation transmitted inside, the higher the room temperatures. Again, it's clear that triple silver alloy on no iron glass is the best. Furthermore, let's look at the effect of different substrate on the same triple silver alloy coatings. We apply the same triple silver alloy coating on different substrates. In this table, we use 5. On the top, it's a triple silver alloy on no iron glass. The second is on clear glass, the third one on green glass, the fourth one on blue glass, and the fifth one on light gray glass. As tinted substrate is used, the G values is lower. It looks like the performance is improved. However, when we look at GR values, you can see triple silver alloy on the iron glass has a GR value about 2.9%. If we replace the iron glass with clear glass, the GR is increased to 4.4%. With green glass, the GR becomes even higher to about 8%. With blue glass, 8.4%. With light gray glass, 7.7%. The higher the GR value, the more solar air radiation, the more energy consumption. So the GR values may be lowered by using tinted glass, but actually the room temperature will be higher because of more solar air transmission. If some projects need a lower visible light transmission, we can just modify the triple silver alloy coating itself without using tinted glass. So on the bottom, we show triple silver alloy on low iron glass with visible light transmission about 40%. Similar to the fifth one, triple silver alloy on light gray glass, about 40%. You can see that the GR is about 2.8%. It's much lower than the triple silver alloy glass on tinted glass. The triple silver alloy coating on low iron glass is the best. So from the above data and the analysis, we can conclude that to create bright and cool room space, triple silver alloy on no iron substrate is the best solution. With triple silver alloy on no iron substrate, we can achieve higher visible light transmission, the lowest short-wave air transmission in the most effective prevention of heat accumulation, and to create a more comfortable room space and lower the electrical bill of air conditioning systems. In this diagram, we show a number of triple celluloid glass products, the transmission spectrum. As you can see, no matter the vapor transmission, no matter the color, no matter the reflectivity of triple celluloid glass, they all have a common feature that is it's extremely low transmission in the IR region. That means G value or heating coefficient of triple celluloid glass is only a reflection of the visible light transmittance. Evaluation of energy efficiency by G value or heating coefficient may mislead in design consideration and over investment on air conditioning system. Next, we'll talk a little about aesthetic effect. Aesthetic effect is related to color and consistency, color rendering index, reflectivity, and brightness, etc. One important aspect is the spandrel matching. By applying free pattern on number 3 surface, we have achieved perfect matching for a number of projects with different color and brightness. For different color and brightness, we only need to slightly modify the color of free patterns and the coverage. For example, for these projects, the triple celluloid glass has a green appearance. By applying the free patterns on number 3 surface, the spandrel and the vision glass matches perfectly. This project uses a blue triple celluloid glass. We can also achieve perfect matching between the spandrel glass and the vision glass. This one is a neutral look triple celluloid. This is a gray look triple celluloid. Again, the spandrel and the vision glass matches perfectly. This is a neutral look triple celluloid. By applying free patterns on number 3 surface, almost cannot tell a difference between the spandrel and vision glass. That means a perfect matching. This one, silver gray appearance. You can see that the spandrel and the vision matches very good. This one is a neutral look triple celluloid. You can see that the spandrel and the vision glass looks almost the same. And then the third part, I'll talk a little about the jumbo size AGU. CSG has been in the low glass business for many years. Another year, CSG has supplied Loy glass for numerous projects, both in China and overseas. And then we have do a number of projects with jumbo set Loy glass. In this table, we just list some of the projects and the panel set. As you can see that we have done projects with glass panel size about 3 meters by over 10 meters. These are real pictures. This one, this project is in China, in Wuhan, Hubei province. The height of the low IGU panels over 10 meters. This project is in UAE. You can see that it's the glass has a very good appearance, and the size is close to 10 meters. That's all of my talk today. Thank you.
Xin được cảm ơn phần phát biểu và chia sẻ trực tuyến đến từ Mr. Chengde Huang. Kính thưa quý vị, và ngay bây giờ chúng ta sẽ cùng đến với phần thuyết trình và trình bày tiếp theo trong phiên hội nghị thứ 3 ngày hôm nay. Và Quỳnh Trúc rất hy vọng rằng là tất cả quý vị chúng ta cũng sẽ cùng nhau tập trung tại phía bên trong khán phòng, ổn định vị trí để chương trình có thể tiếp tục và không bị gián đoạn. Kính thưa quý vị, và tiếp nối chương trình, xin mời quý vị chúng ta sẽ cùng lắng nghe phần trình bày đến từ Mr. Malvinder Singh Ruprai, Giám đốc chương trình kỹ thuật cấp cao của APAC Kuraray, với vai trò cũng như thuyết trình về chủ đề thiết kế mặt thủy tinh nhiều lớp với công nghệ xen kẽ tối tân. And now, ladies and gentlemen, for the last presenter in our third section of this conference, I would like to invite on the stage Senior Technical Program Manager of APAC Kuraray, Mr. Malvinder Singh Ruprai. Please welcome.
Thank you very much for the nice introduction. A very good afternoon to all of you. So the bad news is I'm the last one more hurdle that you have to cross before you get your tea or coffee. So I'm here to talk about the various interlayers that have been developed by Kuraray. So laminated glass is not something which is new in the industry, but we have developed some new advanced interlayers. So I just want to make you quickly go through that. Yeah, so we have a variety of interlayers to match the different applications for laminated glass. So just to let you know, not all the interlayers which go in between the two glasses of laminated glass, they are not the same. Yeah. So you can choose the suitable interlayer for different types of applications. And today, I'm specifically going to talk about structural and security applications. Yeah. I think this is quite simple to understand. This is a pictorial illustration of the different types of glass illustrating their breakage pattern. And from here, you can easily make out laminated glass is the most safest type of glass when we talk about the different types of safety glasses. Yeah. So we at Kuraray make this the interlayer which goes in between the two glasses. You can see this is a sandwich, and we make the butter which goes in between the two glasses. This is a simple definition for a layman that what we do at Kuraray. Yeah. So when we talk about different applications of laminated glass, so we say that the glass can be chosen and the interlayer can be chosen depending upon different functionalities of the glass that are required. So different elements of functionality required to be considered by the architects and the facade consultants. So those elements could be, the post-breakage strength, the security, the transparency, the solar and optical performances of the glass. So all these are impacted to a great extent by the not only the type of the glass that you have, but also about the type of the interlayer that you have in between. So it's very important to select the right type of the glass, and it's very important to engineer the glass rightly. So I have some examples over here that why it's important. Yeah. So this is a very good example that, if you don't engineer the glass properly and if you select a wrong glass type, the consequences can be catastrophic. Not good, right? And then another video which is also related to selection of a wrong type of the glass. So which is, you can see from the breakage pattern, it's toughened glass, which is considered to be a safety glass in many countries, but it's not really safe if you are walking underneath such a glass railing application. Yeah. One more. So fortunately, this is not from the ongoing FIFA World Cup. So if any of you are like considering going to FIFA, you can go there. Yeah. So this video highlights that what can happen if the glass barrier is not designed appropriately from the strength point of view. So I think the engineer who designed this, he forgot to consider the crowd loading for which is the basic function of any glass barrier. Yeah. So if we select the right type of glass and we engineer it properly, so here are some examples, some good and bad examples. So this is the post-breakage strength testing video, the swing back test, which we very often call, and we want to check how the glass is going to behave in a certain application. This bag is weighing 45 kgs. It's released from a height of 1.2 meter, which is simulating the impact caused by, let's say, a teenager who is like full of energy, accidentally colliding with the glass. And you will see the same piece of glass impacted from the front angle. So it can be really dangerous because those glass fragments, they have tremendous amount of potential energy to injure the people standing underneath. Not looking good, right? And now you see the same glass railing. It's laminated glass. It's with an applied film on one side. So it's a polyester film which is applied on one face of the glass, and quite often this is done as a retrofit measure on an existing glass railing. It's a cheap alternative of laminated glass, I would say. And now if we have a laminated glass with a PVB interlayer in between, so the glass breaks because of the impact. But PVB has no structural strength of its own, so it can't sustain the self-weight of the glass. Yeah. And then we do the same test on a laminated glass made with a structural interlayer called sentry glass. So because of the impact, obviously the glass will break, but how the glass breaks after its breakage, that is governed by the structural strength of the interlayer. So the glass is rebounding back to its original position after the impact. So the functionality of the glass railing is not compromised. Yeah. So this is like high-speed camera which captures like 1,000 frames per second, but in reality, the glass will immediately come back to its original position. Yeah. So if you engineer the glass properly, this is one example, how you can make the glass to do wonders. Like this is a very thin piece of glass, it's sustaining more than 1.5 tons of load, which was in demonstration at Glasstec in Europe some years back. Some more examples. This is a working seesaw made with 11 layers of low iron tempered glass made with sentry glass. And this is a really working model of a seesaw. Some more eye-catching pictures of a curved bent laminated glass. So some people have a kind of, like I would say, they believe that sentry glass, because of its high stiffness, it can't be bent into tight radiuses like this. Yeah, this is a good example. Then we move on to some unique applications where the glass barriers are being used in applications like this one as flood barriers. So this is a picture on the left-hand side from a testing lab where the glass is being tested for the hydrostatic pressure that will be imposed on the glass barriers. And this on the right, this is the picture of the glass actual in-use conditions from one of the hurricane which was there in September this year only. Another eye-catching project from the Apple stores. You can see this. This is the largest carbon fiber roof that has been built in the world. It's it's floating on this 44 pieces of laminated glass with sentry glass, and it has been designed in such a way that even if the half of the glass panels they break in case of an earthquake, still they have got the enough post-breakage strength to sustain the weight of the carbon fiber roof over there. Another project with curved glasses from Hong Kong. So you can see that glass panels, they are making use of annealed laminate constructions, but they are like strong enough to withstand the wind pressures of as high as like 5 kPa. And why the facade consultants chose sentry glass for this application? Because of the high edge stability of the laminates when they are exposed to high humidity conditions. So here we have a comparison of different laminate constructions made with different interlayers. So edge stability number for sentry glass is known to be like 0 after more than 20 years of exposure to high humidity and high temperatures. And also we have a comparison with standard interlayers like PVB, whose edge stability number goes up to more than 350 just after 5 years. Yeah. Then we move on to some security applications. Security is becoming a big concern these days all over the world. And the threat could be sometimes man-made as well. So let's see what are the requirements for such applications. So when we talk about specifically about the BRG applications, reduction of the weight is one of the requirement, and durability is also one of the big requirements, that they have to be durable enough when they are exposed to extreme temperatures. So the conventional BRG applications or the bullet-resistant glazings, they are making use of polycarbonate as the material of the choice, and quite often they are like quite heavy. So with our advanced interlayers, it is possible to down-gauge the glass thickness, and also you can reduce the weight, and they are highly durable because they are making use of advanced interlayers like sentry glass and spall shield. What is spall shield? It's a PET film which is applied on the protected side of the glass, so that there are no splinter formations. Yeah. So the advanced BRGs, they are lightweight, more durable, and they don't pick up moisture. So I'm just going through this quickly. So if you have more questions, then you can just come down to our booth outside. Yeah. So this is a comparison. So this is a study that we did on the about the resistance of the bullet, resistance of the interlayer to the bullet that is impacting the glass. So we did a study on different types of interlayers, and this is what we call as penetration depth of the bullet in the glazing construction. So this is a shooting block made out of like 1 meter thick interlayer. There is no glass into this, and you can see the bullet has been entrapped into this block. So here we have a comparison here. Trocifol B200 is our PVB interlayer, and then we have sentry glass. You can see the big difference between the penetration depths for these two, and I think the penetration depth of sentry glass and polycarbonate, they are quite comparable. So you can see the penetration depth for polycarbonate is the lowest, but it's not a good choice because it has got limited durability. Yeah, so we will see why it is not so durable. Yeah. Sentry glass, spall shield is known to be highly durable even if it is exposed to high temperatures, like 16 hours of exposure at 100 degrees centigrade temperature. Does not develop any defects, no delaminations. It's also known to be very durable against the commonly used chemicals for cleaning the glass, unlike polycarbonate. And this is a very good example that why polycarbonate is not a good material for such applications. So this is a picture from the Florida airport where the polycarbonate was used for making the glazing as hurricane resistance, the resistant against any kind of missile impact. Yeah. This is the building where the spall shield was used as a material of choice for making the facade resilient against missile impact. So it's looking good even after 28 years. So just to make you understand more that what is spall shield, so I have this video for a BRG construction. So it's a ballistic test. We are making the real use of a shooting bullets on the glass. So it's BR6 is the threat level, and this is the impact side. You can see a lot of splinter formation is there. And this is the protection side. So no splinters on this side. And when you fire the shot number 2, again, lot of splinters. Again, no splinter formation on this side. So BR6 or the EN 1063 standards requires 3 shots to be fired in a triangular pattern. So we see that a lot of splinter formation are there, but the protected side it's absolutely safe. So even if you are sitting next to the glazing, let's say in a vehicle, you are like very much safe. Yeah. So 0 splinter formation on the protected side. Yeah. Okay. Then moving on to next application is the blast resistance. So because of the rising incidents of terrorism, some buildings are required to be resilient against attacks like bomb blast is exploding outside the building. So we can run blast simulation for you. We can assist you in knowing how a glazing is going to behave. If you can let us know the threat level and how you want the glazing to behave in case of explosion outside the building. So we have pictures of this shock tube test and the open arena testing, which are commonly used to study the behavior. The open arena testing is quite expensive to do, and then we have shock tube test as an alternative. Yeah, so we can do this blast simulation for you. Yeah. So you need to know the performance levels as per the GSA standard. So if you know that, then we can help you run the simulations for that. Yeah. And I think this is my last slide. Yeah. So one important slide is like Sentry Glass and SGP. So please be aware that Sentry Glass is the registered trade name for our product. It is not called SGP. So it may happen that you may ask for Sentry Glass and the laminator may supply you SGP, So that's very important to know. So SGP is not Sentry Glass. Yeah. That's all from my side. Thank you very much for your time. Thank you.
Xin được cảm ơn phần trình bày và chia sẻ đến từ Mr. Malvinder Singh Ruprai. Kính thưa quý vị, và như vậy, phần trình bày và chia sẻ của Mr. Malvinder cũng đã khép lại phiên thứ 3 trong toàn thể hội nghị của chúng ta ngày hôm nay. Và trước khi chúng ta cùng đến với phiên cuối cùng, phiên thứ 4 trong tổng thể hội nghị của chúng ta ngày hôm nay, thì xin được mời toàn thể các quý vị, các anh chị, chúng ta sẽ cùng nghỉ giải lao trong khoảng thời gian là 20 phút để có thể thưởng thức tiệc trà, giao lưu, tham quan khu vực triển lãm của chúng tôi. Ladies and gentlemen, before we come into the last section, the folk section, we would like to invite all of you to enjoy the tea break, the networking section, within 20 minutes. Xin được chào mừng toàn thể quý vị, chúng ta đã cùng quay trở lại với hội nghị Zak World of Façades ngày hôm nay. Ladies and gentlemen, warmly welcome back everyone to our folk section in this conference today. Kính thưa quý vị, để mở đầu cho phiên thứ 4 ngày hôm nay, ban tổ chức xin được trân trọng kính mời toàn thể quý vị, chúng ta sẽ cùng lắng nghe về nội dung, chủ đề liên quan tới sống và làm việc trong vùng an toàn qua phần trình bày và chia sẻ đến từ ông Cung Thanh Dat, là Managing Partner tại Boomslager Abele Architecture. Ladies and gentlemen, for the opening section, as in the folk section in the conference today, we would like to invite on stage the Managing Partner from Boomslager Abele Architecture, Mr. Cung Thanh Dat. Ladies and gentlemen, please raise a big applause, please.
Good afternoon, ladies and gentlemen. What an honor to be here to attend Zak Facade conference. And I also would like to say thank you with Shuko, with organization such a second event in here. I also special give the thanks to my college speaker who share with us a lot of innovative knowledge in here. Đến phần tiếp theo thì có nhiều các cái khán giả ở đây là người Việt và cũng theo yêu cầu của bên Shuko thì tôi cũng xin trình bày phần bài diễn giải của tôi bằng tiếng Việt và xin được nhờ cabin phiên dịch. Tôi là Đạt, tôi đến từ công ty mà phát âm khó nhất Việt Nam. Hầu hết các chủ đầu tư và các partner của chúng tôi đều không đọc được tên của công ty chúng tôi. Công ty chúng tôi là Baumschlager Eberle Architecten, là công ty của Áo và được thành lập năm 1985 bởi giáo sư Dietmar Eberle tại Lustenau. Tại Việt Nam thì từ năm 2011 chúng tôi đã được thành lập 2 văn phòng ở Hà Nội và Sài Gòn, và trong 8 năm liên tiếp chúng tôi là top 10 10 văn phòng lớn nhất tại Việt Nam. Hôm nay chúng tôi ở đây thì tôi muốn chia sẻ với các bạn cái công nghệ xây dựng tòa nhà 22A6. Tại sao nó lại là tòa nhà 226? Bởi vì nó có con số rất đặc biệt. 226 chính là nhiệt độ mà dù bất kỳ khí hậu ở đây đâu chúng ta cảm thấy nhiệt độ comfort. Và ý tưởng của chúng tôi là làm thế nào để với bất kỳ cái khí hậu nào, dù có ở châu Phi, ở châu Á hay ở châu Âu, nhưng làm thế nào để xây được tòa nhà mà nhiệt độ trong phòng luôn là comfort 226 nhưng không phải tốn năng lượng về điều hòa và sưởi cũng như là làm mát. Nhu cầu tại sao tôi muốn chia sẻ tại sao mà chúng tôi lại có ý tưởng như vậy thì chủ tịch chúng tôi, ngài giáo sư Dietmar Eberle, ông ấy sinh ra ở một cái ngôi làng trên núi của Áo và ông ấy luôn trăn trở suốt 40 năm là tại sao tổ tiên của chúng ta hàng trăm năm trước chúng ta đâu có cần phải hệ thống sưởi, đâu có phải sử dụng khí ga mà họ vẫn tồn tại hàng trăm hàng ngàn năm như trước. Ông ấy trăn trở và ông bảo làm thế nào để xây được những tòa nhà mà chúng ta không cần năng lượng để sưởi và điều hòa. Và gần đây chúng ta thấy cuộc chiến tranh giữa Nga và Ukraine cũng là hết sức nhức nhối và vấn đề năng lượng. Thực ra các vùng nói tiếng Đức như là Đức, Áo, Thụy Sĩ, Liechtenstein, họ đã rất từ lâu, họ đã mong muốn là thoát được khỏi sự lệ thuộc của năng lượng. Họ muốn tự chủ về năng lượng và đấy gọi là an ninh năng lượng. Chính vì vậy là thôi thúc các nhà khoa học của các vùng nói tiếng Đức chúng chung cùng nhau để xây dựng nên môi trường và phát triển bền vững. Và họ đã xây dựng nên cái mô hình 226 và tôi xin trình bày xem là cái mô hình đấy nó là thế nào. Đầu tiên, cái mục tiêu của 226 là gì? Như tôi đã trình bày, thứ nhất là gì? Làm thế nào để đặt con người vào trong cái điều kiện sống tiện nghi nhất. Như tôi vừa nói, nhiệt độ 226 chỉ là một yếu tố, thậm chí còn các yếu tố về khí carbonic và các yếu tố về thông gió. Và làm thế nào để mà vận hành tòa nhà với một năng lượng tiết kiệm nhất, cũng như là sử dụng thay thế các phần cứng truyền thống bằng các phần mềm, điều khiển tòa nhà thông minh hơn, biến tòa nhà như một cái cơ thể sống. Cái tòa nhà có thể thích ứng thay đổi điều kiện môi trường để đáp ứng với con người như một cơ thể sống. Để đạt điều này thì chúng tôi làm là gì? Chúng tôi đưa ra 5 cái tiêu chí chính để mà nghiên cứu. Thứ nhất, bất kỳ địa điểm nào công trình chúng ta cũng cần các cái yếu tố về khí hậu. Đó là yếu tố climate. Thì chúng tôi có những nhóm nhà khoa học để nghiên cứu rõ các thông số chính xác định tính. Đó là gì? Nhiệt độ trong năm nó thay đổi thế nào? Và thực sự là cần bao nhiêu năng lượng làm mát, năng lượng điều hòa một cách chính xác, không thể là định tính được. Thứ hai, chúng tôi có định nghĩa rõ ràng các yếu tố comfort ở đây là gì. Ví dụ như tôi vừa nói về nhiệt độ, nhưng thực ra nó còn có cả về acoustic, tiếng ồn, về độ ẩm, quan trọng nhất độ ẩm. Các bạn biết là vào mùa này tại sao các bạn lại thấy thoải mái nhất ở Hà Nội không ạ? Bởi vì nhiệt độ chúng ta cũng đang rơi khoảng 226 và độ ẩm hiện tại đang là hoàn hảo, nó rơi khoảng 40 đến 60 và các bạn thấy rất thoải mái. Hay các bạn đi Đà Lạt hay là Châu các bạn thấy thì cái yếu tố độ ẩm rất quan trọng. Ngoài ra thì gì? Về tòa nhà thì nó được định nghĩa bởi các yếu tố gì để chúng ta nghiên cứu. Mỗi một group này chúng tôi có nhóm nhà khoa học. Chúng tôi nói vui rằng thực chất để phát minh ra tòa nhà này nó là cái công cuộc nghiên cứu của rất nhiều tổ chức. Họ đầu tư vào cả tiền của và sức lực vào đây, giống như họ đầu tư để phát minh ra thuốc chống Covid chẳng hạn. Thì đây cũng là một kế hoạch dài hơi mà ông chủ tịch tôi cùng với một số các quỹ cùng phát triển. Một cái group về từ khí hậu cũng do một nhóm nhà khoa học ở 3 nơi, ví dụ Nhật, Đức và Thụy Sĩ để nghiên cứu xem thực sự ở mỗi khu vực là cần các thông số nào. Hay họ có những phần mềm để định lượng tòa nhà về những yếu tố như thế nào, đong đo đếm về các khoảng cách như nào. Hay thậm chí là về software. Cái linh hồn của tòa nhà này chính là chip, bộ chip xử lý trong tòa nhà. Và chúng tôi có một công ty ở Đức là nghiên cứu về bộ chip để mà vi xử lý có thể thích ứng, biến đổi tòa nhà trở thành như cơ thể sống. Ngoài ra chúng tôi có những cái backup system. Ở đây là gì? Làm sao để giữ được tòa nhà luôn luôn ở nằm trong độ 226. Thế nếu nó vượt 22 độ, nó thấp hơn 22 độ thì những hệ thống thích ứng nền nhà là thế nào? Hay là vượt qua 26 độ như nào? Chúng tôi cũng nói vui là khi mà tôi duyệt một số đồ án thì tôi thấy khi tôi đi chấm đồ án tốt nghiệp của một số sinh viên, tôi thấy các bạn thường bố trí khu penthouse trên nóc có một cái thang máy. Thì tôi mới đặt ra là gì? Các em phải nghĩ đến chuyện backup. Bởi vì khi ở trên này chúng ta gửi một thang máy thì làm sao mà có vấn đề thì làm sao sử dụng thang máy thứ hai. Cái vấn đề backup này cũng tương tự. Chúng ta cố gắng đưa vào nhiệt độ vào con 226 nhưng nếu xảy ra những vấn đề như dưới 22 26 thì chúng ta phải backup về nước, backup về pumper, backup nước về các vấn đề về thang máy. Ở đây chúng tôi đi một yếu tố nữa là sự hiệu dụng này thể hiện ở tất cả các yếu tố. Thứ nhất là gì? Hầu hết các câu hỏi của các chủ đầu tư là làm tòa nhà no heating no cooling này có đắt tiền hơn tòa nhà bình thường không? Chúng tôi trả lời là có. Tuy nhiên chúng ta hãy tính đến các yếu tố vòng đời. Một công trình hạng 1 nó tồn tại khoảng 50 năm. Nếu như chúng ta tính toán được, ví dụ với chúng tôi là hiện tại là chúng tôi quy ra mét vuông điện, tức là thông thường các tòa nhà ở châu Âu với chức năng đơn giản như là văn phòng thì nó tốn khoảng 45 số điện trên 1 mét vuông trên một ngày. Nhưng với công nghệ 226 thì chúng tôi giảm được 1/3, trước mắt 1/3 mét vuông. Thì mọi người thử tính toán cái tiền chúng ta sẽ tiết kiệm được trong vòng đời 50 năm đấy là như thế nào? Chúng ta sẽ làm long term. Cái thứ hai nữa là một cái xu hướng mới mà chúng tôi đưa vào đây là thiết kế tòa nhà mở, open building. Tòa nhà mở là gì? Tòa nhà mở là chúng tôi đưa cho chỉ thiết kế gồm có core and shell, tức là gồm có lõi và xung quanh, trong đó là không gian hoàn toàn là mở. Đến sau khi chúng ta có thể công năng nó thay đổi, bởi vì chúng tôi tin tưởng rằng thời gian tới công năng hoàn toàn là mở và có thể thay đổi công năng để phù hợp với cả sự thay đổi nhanh chóng của thời đại hiện nay. Mà khi chúng ta thay đổi đấy thì chúng ta không phải thay đổi cái phần cứng của tòa nhà, phần cứng vẫn giữ nguyên. Đấy là lý do mà chúng tôi muốn combine cái công trình 226 với cả tòa nhà mở. Một cái con số rất hay, các bạn có thấy đây là gì? Tin buồn là gì? Là các bạn thấy là cái chi phí sinh sống nó tăng phi mã, trong khi chi phí trong chi phí mà về nhà ở, về năng lượng tòa nhà thì các bạn thấy là nó không thể tăng kịp cái doanh thu, cái nguồn thu của chúng ta. Và chúng ta thấy là cái chi phí để vận hành để vận hành tòa nhà nó tăng thường là gấp 2, gấp 3 lần so với thu nhập của chúng ta. Vậy thì gì? Câu hỏi đặt ra là gì? Chúng ta phải quản lý năng lượng và chi phí tòa nhà một cách hiệu quả nhất. Đấy là cái phần keywords. Và chúng ta thấy là chúng ta luôn luôn bị conflict giữa chuyện comfort, tiện nghi và những vấn đề chúng ta xem có tiết kiệm được không. Giống như là chúng tôi nói vui là ví dụ như trước đây thì các bạn ở Mỹ thì thường là giá xăng dầu rẻ nên các bạn mua xe to, các bạn mua động cơ lớn. Tuy nhiên ở đây chúng tôi mới đặt ra là chúng tôi muốn đưa ra tòa nhà con người cảm thấy tiện nghi, nhưng mà các cái chi phí vẫn là đặt trong mức vừa phải. Và chúng tôi vẫn muốn đưa ra những cái yếu tố châu Âu họ rất quan trọng nhất là cái mức độ thải khí carbonic là gì. Khi mà làm một tòa nhà Thụy Sĩ thì bạn cần các giấy phép sau. Bạn ngoài những phần giấy phép thông thường, bạn phải chứng minh được tòa nhà của bạn thải ra bao nhiêu khí thải carbonic và tòa nhà tiêu tốn bao nhiêu số điện 1 mét vuông thì chính phủ mới cấp cho tòa nhà để xây tòa nhà. Ở đây thì chúng ta sẽ tìm được mối dung hội là chúng tôi khẳng định với những yếu tố về tiện nghi nhưng các cái phần chi phí nó vẫn không tăng, và cuối cùng chúng tôi sẽ đi vào thiết kế tối ưu hóa tòa nhà để mà can thiệp vào ít technique nhất, và cuối cùng một cái yếu tố quan trọng là mục đích để tiêu thụ giảm cái số lượng khí thải carbonic giống như là biểu đồ các bạn nhìn thấy. Đây là một cái nghiên cứu chính là cái mục tiêu của 226. Đây là cái nghiên cứu của giáo sư Lars ở Đại học ETH Zurich, nơi mà tôi học tập ở đấy cũng cùng với cả chủ tịch của tôi là ông Eberle. Thì ở đây thì chúng ta thấy cái biểu đồ bên tay trái là gì? Là nhiệt độ chính xác trong năm. Rất chính xác trong năm. Thì đây là các cái dữ liệu nghiên cứu của 3 trường đại học. Và chúng ta thấy cái nhiệt độ mà chúng ta mong muốn là từ 25 đến 20. Và trên phía đấy là chúng ta cần gì? Là chúng ta cần làm mát, và dưới đấy chúng ta là cần sưởi. Và ở đây chúng ta thấy được là tách được là năng lượng cần sưởi và năng lượng làm mát ở các mức như 60 số điện một năm trên 1 mét vuông hay là 25 một năm. Và các bạn nhìn xem với các cái phương án của 226, tòa nhà 226 thì chúng ta thấy được Optimize Building, tòa nhà sau Optimize chúng ta thấy ngay là năng lượng về sưởi và làm mát giảm đi rất nhiều. Và chúng ta quay lại biểu đồ kia, cái màu xanh blue line là cái phần nhiệt độ bên ngoài, thì cái này là nó bất biến là tòa nhà đây là nhiệt độ ngoài nhà, chúng ta không can thiệp được. Nhưng cái nhiệt độ trong nhà các bạn nhìn thấy từ đường xanh, màu xanh lá cây trở thành nét đứt, và các bạn thấy nó đã bị kéo về phần 226, và như vậy là cái năng lượng để làm mát và năng lượng làm để sưởi đã kéo xuống thấp rất nhiều. Vậy thì bằng các cái yếu tố và thiết kế tối ưu hóa tòa nhà, chúng tôi cũng chia được các yếu tố đó là gì. Chúng tôi đưa đến là bằng cách tối ưu hóa về sàn, về mái, về các vật liệu. Nhưng những cái yếu tố này thực sự đấy là chúng ta đặt ra, nhưng để có mặt kết quả thì đó là quá trình làm việc của rất nhiều các khoa học. Ví dụ như là chúng tôi đưa ra ở đây là gì? Chúng tôi muốn đưa ra chính xác. Ví dụ như chúng tôi có thể đưa ra ví dụ như là có một cái thông số rất là hay. Tôi nói vui một chút, tức là khi mà các nhóm khoa học mới nghiên cứu là khi mà chúng tôi nhận ra là ở châu Âu thì năng lượng sưởi mới là năng lượng cần nhiều nhất, nó chiếm tới 60% chi phí năng lượng. Vậy đặt ra câu hỏi là liệu cái lượng năng lượng của con người tỏa ra hay là máy móc equipment này liệu có đủ để mà sưởi nóng cho tòa nhà không? Thì đây là một con số rất là vui. Các bạn có biết chúng ta trong 1 giờ chúng ta thải ra bao nhiêu oát không? Chúng ta thải ra 8 oát, năng lượng 8 oát. Và nó còn nóng hơn là cái đèn downlight này. Vậy thì một cái nghiên cứu khác là gì? Trong cái phòng có 20 mét vuông thì muốn tăng nhiệt độ lên 1 độ cũng đúng bằng 1 oát. Vậy là gì? Chúng tôi nghĩ ra là gì? Thử xem năng lượng toát ra từ người và máy móc có đủ để làm ấm tòa nhà không? Và chúng tôi cùng với các kỹ sư về phần mềm cũng nhà khoa học bắt đầu chạy các scenario. Scenario 1 là gì? Một anh đồng nghiệp 80 cân ngồi cùng một chị đồng nghiệp 70 cân và ngồi sử dụng máy móc máy tính là laptop Lenovo và cùng cạnh một máy in. Chúng tôi chạy các scenario và thử test xem các scenario đấy liệu là năng lượng có đủ không. Và kết quả thật là bất ngờ, không những đủ mà còn có con số rất là hợp lý. Chúng ta nhìn thấy phần năng lượng nhiệt ở đây ạ. Ví dụ như đây là chúng tôi lại có một cái bản đồ nhiệt. Ở đây là chúng ta sẽ thấy là nhiệt độ thay đổi trong năm của tòa nhà từng thời điểm trong năm. Và vẫn là cái khoảng chúng ta cần từ 20 đến 25 độ. Và cái nhiệt độ trong nhà là màu xanh, đang tiệm cận dần. Nhưng với tòa nhà 226 thì như thấy là nó đã tiệm cận nằm trong khoảng 226 mà bên ngoài thì nhiệt độ vẫn thay đổi bằng các phần điều khiển. Vấn đề thứ hai nữa chúng tôi đưa ra là cái ánh sáng tự nhiên và ánh sáng chiếu sáng ban ngày. Ánh sáng ban ngày, nhưng bạn thấy là nét đỏ ở đây là phần mà chiếu sáng và phần ánh sáng tự nhiên, và nó lên đỉnh vì đây là địa điểm nghiên cứu của chúng tôi là Áo, nên là cái điểm cao nhất của nó là rơi vào khoảng tháng 7 như bạn thấy. Thì ở đây chúng ta sẽ thấy là chúng tôi so sánh cái tiêu chuẩn của Mỹ, tòa nhà của Mỹ thì là năng lượng về chiếu sáng cho tòa nhà nó rơi khoảng 20 và của châu Âu, còn riêng tòa nhà 226 nó giảm bằng gần 1/10. Đây là những cái phần mà chúng tôi đưa ra. Cái thứ hai nữa là chúng ta nói về năng lượng, ví dụ điện tiêu thụ trong tòa nhà. Chúng tôi đưa ra một cái nghiên cứu rất kỹ càng. Trong tòa nhà này thì thực sự năng lượng điện là gì? Nó chia làm 3 nhóm. Nhóm thứ nhất là nó đưa vào các phần thiết bị. Nhóm thứ hai là nó đưa vào các phần để đo phần carbonic, các cái sensor, các cái cảm biến. Với cái 3 cái nhóm này, khi mà chúng ta tiết yếu tố tối ưu hóa thì chúng ta sẽ thấy cái năng lượng được giảm hơn rất nhiều so với tòa nhà tiêu chuẩn. Sau đây là một số hình ảnh của tòa nhà. Tòa nhà này cũng chính là văn phòng tổng của chúng tôi, head office của chúng tôi tại Lustenau, Áo. Lustenau là một cái thành phố giáp biên giới với cả Zurich. Nó nằm ở một đầu của hồ Constantin, cũng như giáp với cả 14 nước, đi sang Áo, đi sang Thụy Sĩ, đi sang Liechtenstein rất là gần. Và đây là cái tòa nhà đặt trong khu công nghiệp của hãng Zumtobel, nơi mà chúng tôi cũng nghiên. Và đây cái ý thuyết các bạn thấy là tòa nhà trông rất giản dị như những tòa khác, nhưng nó được như một cơ thể sống, nó thích nghi, nó tự sưởi ấm, nó tự bật điều hòa, nó tự thích ứng để mà đảm bảo là nhiệt độ bên trong lúc nào 226. Bên ngoài mùa đông ở vùng Lustenau có thể lên đến âm 20 độ nhưng tòa nhà bên trong vẫn đảm bảo 226 mà không cần sưởi của nhà. Chúng ta có thể xem thấy một số thiết kế tòa nhà. Thứ nhất, cái yếu tố core and shell các bạn có nhìn thấy rõ trong phần mặt bằng. Core là gì? Chúng tôi gồm các cái phần lõi bên trong và shell là phần bên ngoài, dẫn đến không gian bên trong là hoàn toàn tối ưu. Tôi muốn giới thiệu, chúng ta hội thảo này chúng ta nói về mặt đứng thì tôi xin giới thiệu với các bạn hình ảnh này. Đây là một hình ảnh mà đây chính là ý tưởng của chúng tôi. Đây là một tòa nhà rất cao cấp về công nghệ, mới công nghệ tối tân, tuy nhiên nó vẫn mang vẻ đẹp thuần khiết của kiến trúc. Chúng tôi vẫn sử dụng những vật liệu địa phương, vật liệu rất dễ dàng tìm thấy, vật liệu truyền thống của kiến trúc như là bê tông, như là đá, như là gạch, như là gỗ, nhưng ẩn trong bên trong nó chính là công nghệ. Và đây chính là tư tưởng của chúng tôi muốn gửi đến cho quý vị, làm sao để bảo vệ cái sự nét đẹp tự nhiên của kiến trúc mặc dù chúng ta can thiệp về mặt công nghệ. Cái cánh cửa cái đang mở, tôi xin giới thiệu đó chính là cái cảm biến. Cái cảm biến này có tác dụng gì? Nó được điều khiển bởi chip ở trong trung tâm của tòa nhà. Khi mà nó đo thấy cảm thấy thứ nhất là gì? Ở châu Âu thì có một cái tiêu chuẩn tức là 10 mét vuông trên một người ở văn phòng. Tại sao thế ạ? Ở Hà Nội chúng ta do đắt đỏ cho nên các cái diện tích văn phòng chúng ta không đảm bảo được 10 mét vuông một nhân viên. Thế buổi chiều các bạn có cảm giác chúng ta cảm thấy bị đau đầu. Bởi vì chúng ta bị đầu độc bởi chính carbonic chúng ta thở ra. Và cái yếu tố 10 mét vuông đấy là để đảm bảo cái yếu tố carbonic. Khi mà nó đo lượng carbonic đến ngưỡng nguy hiểm thì cảm biến tự nhiên bật ra để mà oxygen đưa ra. Nhưng vào mùa đông ở ngoài là âm 30 độ, làm sao để chúng ta đưa được 20 trong khoảng từ 22 đến 25 độ. Vậy nó có dùng cái giống như là cái kính chúng ta đeo có khoảng cách giữa kính và mắt. và cái khí làm lạnh đấy nó sẽ đi lên phần trung tâm, nó không phải đưa ra ngoài. Như vậy cái năng lượng làm ấm tòa nhà là rất là ít, trong khi là vẫn đảm bảo được thông gió tự nhiên. Và chúng ta có thể xem biểu đồ này. Đây không phải là diagram mà đây là chụp màn hình của chip trung tâm đặt tại tòa nhà. Ở đây chúng ta sẽ thấy là nhiệt độ luôn nằm trong màu xanh ở giữa 226 là nhiệt độ trong nhà. Và chúng ta còn có thấy là một cái thông số quan trọng nữa là độ ẩm. Độ ẩm, ví dụ như dạo này chúng ta, ví dụ tôi nói các bạn là có các căn nhà riêng nhỉ. Trước đây chúng ta đầu tư vào thiết bị vệ sinh, thiết bị vào pha sát, nhưng chúng ta hãy để ý đến những thiết bị điều hòa thế hệ mới, không chỉ kiểm soát nhiệt độ tòa nhà mà nó còn kiểm soát cả độ ẩm. Và các bạn thấy là cái độ ẩm ở đây luôn luôn nằm trong khoảng từ 40-60 là nhiệt độ comfort. Ở đây chúng ta cũng thấy được là khí carbonic trong tòa nhà là cũng nằm trong dao động và cũng điều khiển để mà chúng ta không bị, chúng ta luôn luôn được khí tươi đem vào và không bị đầu độc bởi khí carbonic. Đây là những thời điểm trong năm, ví dụ như chúng ta thấy đây là biểu đồ của trong nhà, luôn luôn giữ nhiệt độ từ 226 và lượng carbonic trong nhà là ổn, không cần phải cái nhiệt độ trong nhà luôn luôn đảm bảo. Và đây là vào ngày mùng 2 tháng 6 và tiếp tục chúng ta sẽ thấy vào các thời điểm như là vào tháng 10, và tháng 10 là bắt đầu ở châu Âu là bắt đầu có những vùng Áo là bắt đầu cũng có những tuyết nhẹ và những nhiệt độ vẫn đảm bảo ở bên trong 226 và thời điểm mà tuần thứ 40. Cái thứ hai tuần tiếp theo chúng tôi muốn đi đến phần cái cốt lõi xây dựng của tòa nhà. Chúng ta thấy những hình ảnh rất quen thuộc là những viên gạch xây đến những tòa nhà. Nhưng bạn có thấy những viên gạch này có đặc điểm gì khác không ạ? Cái cấu trúc bên trong viên gạch nó khác. Để ra được cái cấu trúc này thì chúng tôi phải hợp tác với những nhà khoa học cũng như là hãng gạch lớn nhất thế giới là tại Áo. Các nhà khoa học họ test hàng ngàn solution, nó gọi là thema, tức là cái mặt gạch ở bên trong này. Tại sao lại có hình chéo này, tại sao có hình kia? Bởi vì nó đi theo chuyện là hiện tượng mau dẫn, tức là hai viên nước cạnh nhau, đặt cạnh nhau nó sẽ hút. Sau khi hàng ngàn giọt nước như vậy thì sẽ như thế nào? Với các cái thema gạch như này nó sẽ làm cho tòa nhà thở được ạ. Tòa nhà không những thở được thông gió tự nhiên mà thậm chí nó cản đến những cái phần mà khi mưa tuyết đọng lại phần giọt nước. Thì với các cái vị trí tường xây khác nhau, các bạn có thể nhìn thấy ảnh này. Tôi thấy là các cái chiều xếp gạch cũng như các thema lát cắt gạch khác nhau. Thì đây mặc dù một hình ảnh rất đơn giản nhưng nó là kết quả lao động của các nhà khoa học cũng như là kết hợp để ra các thema này. Và chi tiết xây lanh tô thế nào, chi tiết xây tường thế nào, chi tiết xây sàn thế nào là có khác nhau. Kể cả đây là một hình ảnh thi công trần. Các bạn thấy trần, mặc dù đây là thi công trần, bởi vì người ta cần cái trần rất cao cũng như là các cái kích thước gạch cũng như các thema gạch hoàn toàn khác nhau, các độ lớp. Và thứ hai là đến phần sàn, các bạn thấy là đây là sàn mình gọi là sàn kênh, sàn này lớp để mà set up các cái phần chip cũng như technology ở dưới cũng như là phần kênh. Hai nữa là chúng tôi muốn giới thiệu cái nguyên liệu đá để mình gọi là làm vữa đấy, nó hoàn toàn khác. Cái này nó được lấy từ vùng Hy Lạp. Tại sao lại vùng Hy Lạp? Bởi vì ở đấy đá có lỗ rỗng mà khi làm nên các cái vữa để chát ấy, nó có lỗ rỗng. Và khi cái lỗ rỗng đấy thì vào buổi tối nó có các cái giọt nước nó hút vào, hàng triệu hàng ngàn trăm giọt nước rút vào thì nó sẽ trở thành tòa nhà nó có độ ẩm, nó giữ cho tòa nhà làm mát vào mùa hè. Đây là cái cách mà để làm cho tòa nhà thở. Và đây là cái core, tức là cái lõi của tòa nhà. Ở đây là trong phần lõi chung, đây là bộ CPU là con chip điều hành. Thì chúng tôi có một câu chuyện vui này, tức là trước khi mà làm tòa nhà này thì chúng tôi thuê một công ty về chip design, họ design về chip. Nhưng sau đấy càng ngày nó update liên tục lên thì chúng tôi quyết định là chúng tôi mua hẳn công ty chip đấy. Và bây giờ đến hiện thế này là các anh đang dùng từ là thế hệ thứ 11. Tức là nó luôn luôn update giống như là các cái phần mềm để mà biến đổi tòa nhà. Một cái nữa là ông chủ tịch của chúng tôi thì cũng là chủ tịch của hãng đèn Zoom Thu Bell. Chính vì vậy mà các cái hãng đèn họ lại cùng nhau cung cấp với hãng chip, bởi vì cái chiếu sáng cũng như các phần hệ sưởi trong nhà này nó đi theo phần hệ chiếu chip sao. Và cái chip này nó giống như một cái bộ não luôn luôn vận hành để luôn luôn active để mà tòa nhà trở thành như một cái cơ thể sống. Đây là những hình ảnh của tòa nhà. Tòa nhà thì hiện tại nó là tòa nhà mở và có khoảng 7 công năng ở trên. Tầng dưới là gallery tranh, còn 4 tầng trên là văn phòng của chúng tôi, cũng là tầng trên là một cái văn phòng quỹ. Các bạn thấy là các vật liệu chúng tôi vẫn dùng các vật liệu của hàng trăm năm trước đây, những vật liệu hết sức thân thiện với môi trường, cũng vật liệu rất hết sức là địa phương. Tuy nhiên ẩn chứa trong nó là một cái công nghệ hiện tại thì là các chính phủ như là Đức, Áo, Thụy Sĩ rất là support hỗ trợ này. Họ quyết định là giao cho công ty này xây hàng loạt các công trình về nhà ở xã hội, nhà ở, văn phòng ở châu Âu. Tuy nhiên họ có chính sách hỗ trợ rất là tốt. Ví dụ như là về văn phòng chúng tôi làm được 100% theo philosophy này. Tuy nhiên về nhà ở hiện tại chúng tôi đang test 70, 75 bởi sao ạ? Nhà ở có bếp, nhà ở có bếp nấu. Cho nên cái vấn đề rất khó khi mà bếp nấu thải nhiệt ra để làm mát nó là một vấn đề. Và chúng tôi đang làm tại Áo một loạt các nhà ở xã hội lên đến gần 1 triệu mét vuông sàn. là với công nghệ đấy, nhưng tôi đang đặt target là giảm khoảng 70 đến 40%. Đây là những hình ảnh bạn thấy ở bên trong. Chúng tôi mặc dù là một tòa nhà công nghệ cao, nhưng bên trong hình ảnh chúng thấy hết sức là nhẹ nhàng, và chúng tôi sử dụng vẫn các cái công nghệ hàng trăm năm, ví dụ như là thợ mộc thì những cái phần là không ghép mộng. Thì đây là cái sự giao thoa giữa hiện đại và truyền thống. Một phần tiếp theo nữa chúng tôi muốn giới thiệu nhanh là như vậy là đấy là lý thuyết áp dụng ở châu Âu. Vậy thì ở Việt Nam thế nào? Ở Việt Nam chúng ta một cái vấn đề là cái năng lượng để làm mát, chúng lại ngược lại, năng lượng làm mát lại cần nhiều hơn. Nhưng chúng tôi tin rằng với đội ngũ các nhà khoa học cũng như kiến trúc sư bên tôi, với sự đam mê của chúng tôi và cái phương pháp, cái method equipment nó vẫn như vậy thôi. Chúng tôi tin rằng chúng tôi sẽ nghiên cứu được tòa nhà ở Việt Nam tiêu thụ năng lượng sưởi và năng lượng điều hòa ít nhất. Chúng tôi cũng đã áp dụng vào một dự án của Viettel. Khi Viettel hỏi chúng tôi thì chúng tôi bảo rằng các anh là công ty công nghệ hàng đầu ở Việt Nam. Vậy thì tương lai nào cho các tòa nhà văn phòng của các anh? Các anh phải sử dụng tòa nhà văn phòng không cần năng lượng sưởi, không cần năng lượng điều hòa và thải ra khí carbonic lớn nhất. Và đấy là ý tưởng mà chúng tôi phát triển tòa nhà Viettel. Chúng tôi cùng các nhà khoa học cũng nghiên cứu rất kỹ. Thay bằng chúng ta cứ đi làm các cái cột 800, 600, nhưng ở đây chúng tôi design từng cái cột với kích thước và thema khác nhau để tạo ra những cái áo lớp vỏ ở ngoài để tạo ra mát tòa nhà. Và các bạn thấy là mặt dựng hoàn toàn khác nhau, các hướng độ mở khác nhau, ví dụ như hướng Tây thì dày hơn, thậm chí hướng Đông Nam chúng ta mang tính chất mở hơn để cho gió vào. Và bạn thấy rất kỳ lạ là tại sao cái nhà này có cái hệ cột kỳ lạ vậy? Bởi vì những cái thiết kế này nó một phần do kiến trúc sư, nhưng thực ra là sẽ theo gợi ý của các nhà khoa học. Bởi vì chúng tôi tin tưởng rằng là thiết kế kiến trúc mà dựa trên các cái dữ liệu của các nhà khoa học thì chúng ta sẽ trở chính xác hơn và phù hợp với cả địa phương. Đây là các hình ảnh kiến trúc của tòa nhà. Các bạn thấy vẫn có hệ chip cảm biến, bởi vì các kỹ sư chip của chúng tôi cũng phải có thời gian để thiết kế lại chip phù hợp với vị trí đả nặng và vị trí với các cái điều kiện đầu vào, như là chúng ta là khí hậu nhiệt đới và hoàn toàn ngược với cả châu Âu. Nhưng chúng tôi tin rằng với cái trí tuệ và sức lao động làm việc của chúng tôi hoàn toàn có thể đưa ra thiết kế tốt tối ưu cho Việt Nam. Xin trân trọng cảm ơn quý vị. Cái chuông đấy là...
Xin được trân trọng cảm ơn phần trình bày vô cùng ý nghĩa và chi tiết đến từ ông Cung Thanh Đạt. Kính thưa quý vị, và tiếp nối chương trình, xin mời quý vị chúng ta sẽ cùng nhau tìm hiểu về chủ đề, đó chính là ngăn chặn lửa và bức tường rèm cho vỏ ngoài của tòa nhà. Qua phần chia sẻ và trình bày đến từ Mr. Donel Dippi, kỹ sư kỹ thuật cao cấp của Rise Installation. Ladies and gentlemen, please welcome on our stage the Senior Technical Engineer from Rise Installation, Mr. Donel Dippi. Please raise a big applause to warmly welcome.
Hello everyone, good evening. Zak has decided to keep the best till the last, so that's why you have passive fire protection for external facade types in the end. So those who are not familiar with SideRise is a fire stop manufacturer along with acoustics and thermal solutions as well for facade types for the last 50 years. This is a golden jubilee anniversary, and we've grown from strength to strength in the last 50 years. Facade fire stops are our basic bread and butter, but we also have solutions for acoustics and thermal. In addition to just supplying the product, we also provide value-added services free of charge, such as site installation, training, and also technical support, technical education, etc. We currently cater to around 35 countries in the world, and we are growing each and every day. Our presence is either through local distributors, or through projects, or through contractors in the region. Before we get into the core of the presentation, I would like to take you through some core fundamentals that are required for fire protection. Active and passive fire protection. So these are key terminologies that are used in our daily lives, and it's important for them to go hand in hand. Yeah? It's not that one is exclusive of the other. They need to be used together. There are certain building codes, such as the IBC, that allow exemptions based on sprinkler locations for passive fire protection. This should not be allowed in any scenario, as it is important for the fire to be compartmentalized in the design stage itself, and this needs to be planned appropriately. Common test standards with respect to reaction and resistance to fire. So reaction to fire is basically explaining how a product reacts in a fire scenario, and resistance to fire classifies the amount of duration or time a fire is contained in a zone. When you're talking about test standards, EN 13501-1 is the most popular reaction to fire test standard. Side-rise cavity barriers achieve A1 classification, which is non-combustible, which is the highest classification to this specific standard. You also have certain other standards which are popular in the market, such as ASTM E84 and AS 1530.1. We can supply you with relevant test reports if required. Moving on to resistance to fire, integrity and insulation are the failure criteria for perimeter barriers and cavity barriers in this regard. Some popular test standards, which I will walk you through later, are 1364 Part 4, 1366 Part 4, and so on. So, moving on to a failure for a fire resistance test. So for a fire resistance test, there are 3 failure criteria. So the first one is stability or structural adequacy. Now, because a fire stop is a movement zone, this is not a requirement for a fire stop. However, you still require integrity and insulation parameters. Now, integrity talks about fire or flame spreading through the joint, around the joint, or through joints in the assembly. Insulation talks about the temperature rise on the unexposed side of the product. So this temperature rise could lead to a secondary fire being generated. So stone wool is a very common element in most fire-stopping products. This is because stone wool performs immensely powerful when in a fire. So even in 5 hours in a fire, the product does not melt or its structural adequacy is not lost. However, if you look at the other products in a fully developed flashover fire scenario, aluminum melts at roughly 9 minutes, glass wool in 6 minutes in a fire. In addition to the fire performance, they also give us great dimensional stability, sound absorption, and water repellency as well. Moving on to external wall types. You have 3 wall types which are very popular in the market. One is curtain wall constructions, which a lot of people have already spoken about today. The second one is ventilated facades, and the third is non-ventilated facades. I will walk you through the 3 types and the fire stops that are commonly used in all 3. So the first one we're going to be talking about is curtain wall facades, where the fire stop is installed as an extension of the performance of the floor slab to the rear of the facade. The side-rise curtain wall fire stop is the primary product that we offer as the extension of the floor slab of the performance to the rear of the facade. So if your floor slab is a 2-hour fire rated, then you require the perimeter barrier also to have a 2-hour fire performance. What are the 2 types of fire spread within a curtain wall? The first one's an internal spread of fire, where fire on one floor spreads to the floor above through the cavity. The second one is fire on one floor, breaks the window open, spreads through the exterior of the curtain wall, and enters the floor above. This is termed as a leapfrog effect and is guided by the spandrel panel height of your building. This is from the Vietnamese code within the region. They talk about that the fire resistance of connecting details of construction components must not be lower than the required fire resistance applied to those components. So basically talking about that if your slab is 2 hours, then your perimeter barrier extension should also be 2 hours of your perimeter barrier. Similarly, fire should be stopped from spreading on the exterior of the facade. Now this is written as a generic statement, and how this is going to be achieved is not really mentioned within the code. Currently within Vietnam, this is the common standard that is used for classifying perimeter barriers. So this is an ISO test standard of 10295-2, which is converted or adopted into the Vietnamese standard. This is tested between 2 concrete assemblies, and this does not simulate the movement of a curtain wall, and there is no cyclic movement of the product being done, and also it's not tested in a real-life scenario of a curtain wall arrangement. So we believe the UAE Fire and Life Safety Code is the most prescriptive code in the world, to be honest, where they talk about spandrel heights, and they also talk about the spandrel panel performance. Now, there's a requirement for the spandrel panel to have a minimum height of 914 mm or a horizontal extension of 762 mm to limit the leapfrog effect. Now, this value has been arrived at by multiple CFD calculations that have been conducted. In addition, it is important for your spandrel panel to also achieve a 60-minute performance. So your spandrel is made out of non-fire rated aluminum, and as we saw, aluminum melts in 6 minutes in a fire. So if your aluminum is not protected, then well, your perimeter barrier is compressed against basically nothing, and fire is going to go to the next floor. Just a pictorial representation of what the code shows. So either you have a 914 mm vertical separation or a horizontal extension of 762 mm. Now, obviously, you need your beautiful building, so you need to have continuous curtain walls. So if you're having a continuous curtain wall, then you either have a drop beam and an upstand protecting the spandrel. If you don't have a drop beam and upstand, then you have the spandrel as well protected in addition to the perimeter barrier. The 2 most popular test standards with a curtain wall construction are ASTM E2307 and EN1364 Part 4. Now, both of these are tested with non-fire rated curtain walls and a floor slab construction, which is the real-life scenario that is being installed at project sites. The ASTM E2307 is an open chamber test, which is conducted in the same test chamber of an NFPA 285. It's an ISMA test apparatus. So because there is an open chamber, there is no pressure that is induced within the furnace. But moving on to the 1364 Part 4 test, in addition to the perimeter barrier, it also assesses the performance of your spandrel panel as well. So because this is a closed furnace, there is a possibility, and it is a mandatory requirement as per the standard, to induce a positive pressure of 20 pascals into the chamber. So we have done both the tests of ASTM E2307 and EN1364 Part 4. So this is an image of the 2307 test, where you can see on the far right, which is before the test, and center after the test, after 180 minutes or 3 hours into the test. You can see that all the aluminum transoms and mullions have melted away. However, in the interior of this compartment on the chamber, there is no fire that has breached. Similarly, for the EN test of the 1364 Part 4, owing to it being a closed chamber test, this was more onerous or a more difficult test, as the curtain wall undergoes multiple movements or deflections during the course of the test. But we achieved a 120-minute performance for this specific test as well. As Agnes mentioned earlier, it is very important for a curtain wall to move, and it is important for your perimeter barrier also to conform to this movement. It is not necessary a fire happens in 1 year of the building constructed. It could be after 10 years or 15 years. So it is important for the perimeter barrier to take care of all this movement and still perform in a fire scenario. So what we at SideRise manufactured or engineered is we engineered a vertical fiber-oriented lamella construction, which was pre-compressed at our factory and then supplied. This could take care of the curtain wall movement as well. And this is also a requirement before a fire test is done. So the product is cycled 500 times in a curtain wall arrangement at 30 cycles per minute, and this is done right before the fire test is conducted. Once the cycling is done, this same specimen is shifted into the furnace and it is burnt. We have tested with multiple stakeholders in the market. These are our current partners in the market who we have tested with, and we are growing every day. Currently, what is used in the market in terms of perimeter barrier systems are a steel plate plus infill system. This is obsolete because the steel plate, well, it does not take care of the movement requirements. It's also not a tested solution. So this is obsolete from this part of the world, I believe. Moving on to the two-part sealant plus safing and the SideRise system. These are the two most popular systems that are currently present in the world globally. The two-part system is prone to human error. And this is because there are multiple steps or stages involved in the installation of a two-part system. So you have to cut the thermal insulation, which is horizontally oriented, make it vertical, because only vertically oriented fibers can take the compression. And once this is vertically oriented, then you have to add multiple strips, compress it to 33% of the void size, then install it and apply the smoke seal on top. Now, how does a consultant inspect this? Because, well, when he goes to site, he's seeing a beautiful paint or sealant application on top. So it is difficult for a consultant or a QC engineer to inspect this installation as well. Just some common errors that we see in the market, where there are a lot of gaps in between. They're not tightly packed. They're not in the right orientation. However, once the paint or sealant is applied, everything looks beautiful, and everyone is oblivious to the fact that you're liable to a fire. However, with the SideRise one-part system, because we've already pre-compressed and rotated the fibers, well, human error is obsolete from this construction. Because all you have to do is you have to cut an extra 10% of the void, insert 2 brackets, and fix it with any non-combustible fixing. In addition to the ease of installation, we are also complying with all the legal requirements of all the regulatory requirements. We are certified by all the major certification bodies of Intertek, UL, and Warrington Fire as well. And also, you can rest assured that what you have tested is what you are installing at site. You're not substituting any product from what is tested. Moving on to facade types 2 and 3 for ventilated and non-ventilated facades. Some of the most brutal fires we've seen around the world. I just wanted to take you through them. So the left is from Istanbul in Polat Tower, where, the entire elevation of the cladding assembly burnt out. The second one is in Southeast Asia, where fire developed in the ground floor, and within a minute and 30 seconds, it spread all the way to the roof. And the one on the far right is the infamous Address Hotel Tower, which is on the New Year's Eve of 2015. All these had one thing in common: there was no compartmentation at all present. And because of this, the chimney effect took place, and fire rose from the ground and all the way up to the top. So the approved document B in the UK gives a guideline on how cavity barriers should be installed in a project or where they are required as well. There's currently no code in Vietnam that says where cavity barriers are required in a project. So cladding construction is very similar, where you have an external panel. This can be ACP, solid aluminum, GRC, etc. Then you have a cavity in which you have a thermal insulation based on the regional requirements for sustainability. And then you also have your base wall, which could be gypsum, brick, or block. It is important to classify your product as for a product fire resistance and also a system fire resistance. So your product fire resistance is classified individually to standards, which I will take you through. And a system assembly is with the entire cladding assembly for NFPA 285 and BS 8414s. So where your entire assembly is put to fire, and that is certified separately. For a non-ventilated system, or where you do not require any ventilation for moisture or rain, then you can have fully filled cavity barriers. So these will be compressed against your panels, and this will stop fire from spreading from one compartment to the other. However, where ventilation is a requirement, there you require something with an intumescent strip, which will allow air, water, and rain to pass through it in the dry stage. However, in a fire, this requires to expand and compress. So SideRise engineered a product called as a RH, or a rain screen horizontal cavity barrier, which has an intumescent strip on its leading edge facing the facade panel. This is an extract, again, from the UAE-FLS code, where it requires the panel as an individual component to have a classification, and also as an entire cladding assembly as well to have a classification. We have done multiple system tests with multiple stakeholders. Currently, we are at 258 system manufacturing tests. So we've tested with different cladding assemblies, different fixation types, different thermal installations, different joint gap, void gap, etc. And we're growing each day. So if you wish to receive some information, please reach out and we'll be happy to help you. In terms of testing and certification, please rest assured that we are tested to the most stringent international test standards and are certified by all the major bodies, Intertek, UL, Warrington Fire, you name it, we have it. This is our UL certification. So we aim to enter a project at the concept design stage, and we understand that every project is different, and we aim to produce or suggest you with bespoke solutions for all these project types. In addition to this, we also have site services and installation support as a toolbox training which is provided prior to the commencement of the project. This is then linked to an inspection app, which I will walk you through, and this is directly also linked to a warranty which you will receive at the end of the project. So inspection after installation is a very important component or aspect which is not really done by any manufacturer. How does one ensure that what is tested is what is installed at site? And to avoid this gap is why we came up with the SideRise inspection app. So this can be downloaded on any Android or Apple phone, and this can be downloaded by anyone. And all you have to do is you have to register yourself one time, and then you can raise an inspection report based on this product you're installing. So you will be asked to enter a series of questions and answers based on what the product you're installing. And also, answering the questions is not satisfactory. You have to attach media or pictures of your project site based on your installation. So once you're raising an inspection, then a SideRise technical team will review your inspection within 48 hours and get back to you. This is an image from our office in Dubai, where we have catered to multiple buildings and have ensured the safety of them in external facades. Like I said, it's important for us to enter the project on the design stage itself. So this is a project called the Dubai Uptown Tower, where we started off with the architects who were Adrian Smith and Gordon Gill. From them onwards, we enter the specification stage with WSP, who were the facade consultants of the project. And then we also catered with B6, who were the facade contractors. So because we were there from the beginning of the project, we were able to specify the project with a protected spandrel. So this was the first project in Dubai where a protected spandrel design was employed and used at site. And also Arup being the fire consultant, they were very stringent and they helped us as well to ensure that the tested system was followed at site. I'm going to keep it short because I've been told that I should keep it less than 20 minutes. Thank you. Yeah.
Ladies and gentlemen, one of the most important part in our folk section is a panel discussion. And for the moderator, I would like to warmly welcome on the stage Mr. Đỗ Hữu Nhật Quang, co-founder and business development director of Green Viet. And ladies and gentlemen, also participating in the panel discussion, I also would like to invite on the stage co-founder of MPN and Partners, Minh Phúc Nguyễn, also technical manager of Hòa Bình Construction Group, Louis Lee. And also I would like to warmly welcome on the stage General Director of Shuko Vietnam, Mr. Hào Hoài Thanh. Ladies and gentlemen, in this panel discussion, and now I would like to warmly welcome everyone, and we can start the panel discussion right now. Thank you.
Xin cảm ơn MC. Xin kính thưa tất cả các anh chị. Chúng tôi rất là lấy làm vinh dự khi mà cho tới giờ phút này vẫn còn rất là đông tất cả các anh chị nán lại trong khán phòng để tham gia cái buổi trao đổi và chia sẻ cùng với chúng tôi. Thì cái buổi chia sẻ hôm nay có chủ đề đó là tính bền vững và sáng tạo trong mặt dựng. Và tham gia cùng với chúng tôi hôm nay thì rất tiếc là không có ông Vũ Duy Khánh đến từ phó phòng đấu thầu của Koltay Công vì công việc đột xuất. Thành ra là chỉ có 4 anh em chúng tôi ở đây thôi. Lần đầu tiên tôi nghĩ là các anh em chúng tôi sẽ giới thiệu một vòng về bản thân mình cũng như là về các cái công việc mà liên quan tới mặt dựng. Sau đó thì chúng ta sẽ đi vào các cái phần câu hỏi. Hiện nay thì cái nội dung nó cũng đang hơi muộn, thành ra là tôi cũng muốn có thể là kết thúc cái phần trình bày, cái phần chia sẻ trong khoảng tầm 30 phút để cho các anh chị có thể có thời gian networking với lại là Suko ở ngoài kia và còn về nhà nữa. Trước hết tôi xin giới thiệu tôi là Đỗ Hữu Nhật Quang, hiện nay là đồng sáng lập của công ty tư vấn công trình xanh Green Việt, và tôi cũng rất là hân hạnh được ban tổ chức Zak World of Façades mời làm chủ trì cái buổi trao đổi và chia sẻ ngày hôm nay. Và chắc là nhờ anh Thanh giới thiệu về bản thân cũng như là về Suko Việt Nam.
Đầu tiên cảm ơn tất cả các quý vị đã tham gia cái hội thảo Zak. Tôi xin giới thiệu tôi là Thanh và tổng đại diện của tổng giám đốc của Suko Việt Nam. Thì Suko Việt Nam rất hân hạnh mang sự kiện Zak đến cho tất cả các bạn ở Việt Nam ở đây. Thì đối với Suko thì đây là những cái kinh nghiệm mà ở quốc tế về lĩnh vực mặt dựng thì muốn chia sẻ cho tất cả các bạn kỹ sư và thiết kế Việt Nam. Suko thì được thành lập ở năm 1951 và chuyên về system supply. Và ở Việt Nam thì Suko đã được hoạt động khoảng 15 năm nay. Mình xin giới thiệu cho anh Phúc.
Vâng, xin được gửi lời chào tất cả quý vị ở đây. Và xin cảm ơn quý vị đã dành thời gian cho chương trình cho tới tận bây giờ. Thì tôi xin giới thiệu nhanh là tôi là Nguyễn Phúc Minh, là đồng sáng lập công ty MPN and Partners. Thì về cá nhân thì trước đây thì tôi cũng đã làm có thời gian công tác bên Anh cho công ty Foster Partners 8 năm, và sau đó thì cùng với 2 đồng nghiệp nữa đã thành lập công ty được 10 năm nay. Thì chúng tôi thì thiết kế là công ty kiến trúc, và chúng tôi thiết kế quy hoạch kiến trúc nội thất tất cả, và trải rộng từ trường học cho đến resort cho đến bệnh viện. Và cái công trình mà gần đây nhất và gần cái khách sạn này nhất đó là công trình Hồng Ngọc Phúc Chứng Minh. Bệnh viện Hồng Ngọc Phúc Chứng Minh thì là do chính MPN thiết kế, và gần đây cũng đã đạt được rất là nhiều giải thưởng quốc tế và đã được đề cử vào shortlist của World Architecture Festival vừa qua.
Vâng, lời đầu tiên xin gửi lời chào đến tất cả mọi người đã tham gia trong cái buổi hội thảo hôm nay. Thì cũng xin cảm ơn ban tổ chức đã mời tập đoàn Hòa Bình, và đại diện là tôi sẽ tham gia cái buổi chia sẻ cùng với mọi người. Thì trước tiên tôi sẽ xin giới thiệu qua về tập đoàn Hòa Bình một chút để cho một số những anh chị ở đây chưa biết đến Hòa Bình thì có thể biết một chút về tập đoàn Hòa Bình của chúng tôi. Thì tập đoàn Hòa Bình chúng tôi là một tập đoàn xây dựng tư nhân cũng thuộc top 1 của Việt Nam và đã có kinh nghiệm 35 năm hoạt động trên lĩnh vực dịch vụ xây dựng. Mặc dù là nhà thầu thi công nhưng mà cũng là rất là tiếp xúc và làm việc rất nhiều với đối tác là các đơn vị liên quan đến hệ phát sát. Do đó thì chúng tôi cũng rất là hứng thú và tự hào khi được tham dự cái buổi hôm nay. Thì tôi là Lê Phước Đức, là trưởng phòng kỹ thuật, phụ trách các cái giải pháp thi công cũng như là các cái công nghệ liên quan đến thi công xây dựng của tập đoàn. Xin cảm ơn.
Cảm ơn Đức. Thì hôm nay ở trên sân khấu các anh chị thấy là cũng có tương đối đầy đủ các cái thành phần, nhưng mà rất tiếc là không có chủ đầu tư. Tôi nghĩ là một cái thành phần rất là quan trọng của dự án, nơi mà chủ đầu tư có thể quyết định cái mức chi tiêu cho, đặc biệt là cho cái mặt dựng của mình. Thì không biết là ở dưới khán phòng có anh chị nào là đại diện cho chủ đầu tư còn ở đây không ạ? Các anh chị có thể giơ tay lên để cho khán phòng gọi là có chút niềm tin ạ. Không thấy anh chị chủ đầu tư nào luôn. Thành ra bây giờ chúng ta cứ gọi là luận với nhau, rồi có gì khi nào gặp chủ đầu tư thì chúng ta tính tiếp các anh chị nha. Tôi nghĩ là đầu tiên về mặt phá sát thì chắc sẽ phải bắt đầu với lại kiến trúc sư, bắt đầu với lại cái công tác thiết kế. Thì tôi muốn hỏi anh Nguyễn Phúc Minh là khi chúng ta thiết kế phá sát, đặc biệt là trong cái gọi là khí hậu ở Hà Nội nó cũng khá là ảnh hưởng, rồi ở thành phố Hồ Chí Minh cũng không phải là dễ chịu, thì các cái yếu tố nào chúng ta cần phải quan tâm, cũng như là làm sao để chúng ta thiết kế ra được một cái hệ phá sát mà đẹp thì mà chủ đầu tư mới chấp nhận. Sau đó rồi thì nó phải đạt các cái yếu tố về bền vững, tiết kiệm năng lượng, rồi đem ánh sáng tự nhiên vào nhà, rồi cuối cùng cũng phải vượt qua một cái vòng cuối cùng, đó là chủ đầu tư phải chấp nhận cái chi phí, thì công trình đó mới xây lên được. Thì với kinh nghiệm của anh Minh có thể chia sẻ với lại khán phòng ở đây những cái tip nào để chúng ta có thể vượt qua được tất cả những cái rào cản đó để về đích thành công.
Vâng, tôi cũng xin được chia sẻ như này. Tức là ở MPN Partners thì chúng tôi không coi cái facade nó chỉ là một cái chỗ mà chỉ là một cái vỏ của công trình, là nơi để ánh sáng đi vào, hay là để nhìn view ra ngoài, hay là để bảo vệ công trình, mà khi chúng tôi thiết kế facade là chúng tôi bắt đầu từ bên trong. Đấy, thì chúng tôi bắt đầu bên trong, tức là chúng tôi đặt ra mục tiêu là cái facade ấy, khi mà con người đứng cạnh nó, họ tương tác được gì với cái facade đấy. Chúng tôi start bên trong, bởi vì chúng tôi coi như một công trình nó như một cơ thể con người ấy. Thì khi mà chúng ta sinh ra thì chúng ta từ một giọt máu, sau mấy tháng thì giọt máu đấy thành cái tim, đúng không? Trái tim và nhịp đập, và sau đấy mới ra chân tay. Đấy, thì chân tay và da thì chính là facade. Do đó mà khi chúng tôi thiết kế thì chúng tôi bắt đầu từ bên trong. Và khi chúng tôi đã đặt được cái mục tiêu và đặt được các cái idea là làm thế nào để cái facade nó tương tác từ bên trong đối với con người rồi, thì lúc đấy là tự nhiên cái bên ngoài nó sẽ sinh ra. Thì cái này nó hơi ngược so với một chút so với tất cả các cái chúng ta đã biết truyền thống. Nhưng mà thực sự khi áp dụng cách đấy thì nó tự nhiên nó sinh ra và nó sẽ độc đáo và đặc biệt. Tất nhiên là cái gốc ở đây ấy, là khi mà một công ty kiến trúc hay là một kiến trúc sư mà nhận đầu bài của chủ đầu tư, thì cái cốt lõi là phải phân tích về chủ đầu tư, phân tích về khí hậu, vi mô của cái khu vực, của khu đất, nắng gió, tất cả những cái đấy phải phân tích. Đấy thì thông thường thì trong cái triết lý thiết kế của MPN thì chúng tôi luôn luôn là gắn liền với cả thiết kế bền vững. Thì những cái sự phân tích kỹ như vậy, chúng tôi còn có cả các cái chuyên gia như chắc anh Green Việt biết, anh Quang cũng thạo về cái việc này, là chúng tôi cũng hợp tác với các consultant về năng lượng. Thì tất cả các consultant đấy thì họ đặt công trình vào các cái vị trí cụ thể theo tọa độ đấy, và họ phân tích tất cả mọi thứ về khí hậu tại khu vực đấy, và họ đều tiên lượng và họ đưa ra các cái vấn đề để cho chúng tôi có thể nhìn thấy là cần phải giải quyết cái gì từ bên ngoài. Sau khi chúng tôi đã có những cái big idea, những cái ý tưởng mà tương tác được của facade từ bên trong, thì đấy là cái bức tranh tổng thể mà khi mà MPN Partners thiết kế. Đấy. Còn đối với cái khí hậu của Việt Nam thì tất nhiên là khi mà chúng tôi có các sự hỗ trợ, trợ giúp của các cái tư vấn chuyên gia về năng lượng, rồi về phân tích về khí hậu, cộng thêm kiến thức về địa phương của mình nữa là vật liệu gì. Đấy, rồi cái routine khi mà con người hay là người sử dụng ấy, và cộng thêm với phân tích của chủ tư nữa là chúng ta hiểu là con người hàng ngày họ hoạt động như nào. Đấy, thì những cái đấy nó sẽ tự nhiên nó sẽ được tích hợp vào trong cái quá trình thiết kế thôi.
Cảm ơn anh. Thực ra bắt đầu từ bên trong thì tôi nghĩ nó là một cái bắt đầu khá là an toàn cho công trình. Tức là khi mà cái công năng cũng như là tất cả những cái vấn đề về kỹ thuật được giải quyết. Nhưng mà đến khi mà ra bên ngoài rồi, ra cái gọi là cái hình dạng, cái render bên ngoài rồi, thì anh có gặp khó khăn gì với lại là chủ đầu tư khi mà thuyết phục họ về cái hình dáng của công trình, hoặc là về cái màu sắc cũng như là cái thẩm mỹ của cái mặt dựng không?
Vâng, thì cái cách mà MPN làm là chủ đầu tư chính là người lựa chọn. Thì tức là khi mà sau khi đồng ý với nhau để hợp tác thì MPN Partner có rất là nhiều cái phân tích về dự án và về chủ đầu tư như vậy, và chúng tôi chia team ra để làm các phương án khác nhau, hoàn toàn khác nhau. Đấy, chứ không phải là từ một phương án mà na ná ra hai phương án kia. Thì ít nhất là 3 phương án, đấy là policy của công ty. Thì tự nhiên là từ một cái khu đất ấy, nó hình vuông vắn như vậy, nhưng mà chủ đầu tư tự nhiên lại nhìn ra được, không ngờ lại nó lại có nhiều cái tiềm năng có thể phát triển ra cái hình khối và các cái facade nó phong phú đến như vậy. Và song song với cái việc tạo ra các cái thiết kế như vậy thì chúng tôi cũng đã tích hợp thêm là tư vấn thêm chủ tư là đối với từng cái option ấy, là công trình nên hoạt động hay là có thêm các cái business operation có khác biệt gì so với những cái thuần túy đơn thuần hay không. Đấy thì khi mà chủ đầu tư họ được đưa ra tất cả các option như vậy, ví dụ như bệnh viện Hồng Ngọc là chúng tôi làm 8 option ban đầu, thì chủ đầu tư họ chọn trên tiêu chí là thứ nhất là hình thức vẻ đẹp bên ngoài, cái thứ hai là công năng bố trí bên trong, cái thứ ba là cái tiềm năng tiết kiệm năng lượng của từng option, thì cái facade nó sẽ là đóng vai trò rất quan trọng. Đấy thì dựa vào ba tiêu chí đấy thì họ sẽ biết được là cái chi phí, cái tiêu chí, cái option nào là nó hội tụ được ba chi phí option, ba cái chi phí đấy, ba tiêu chí đấy. Và cái thứ hai là nếu mà họ không chọn được ngay một option thì họ có thể kết hợp tôi thích cái điểm tốt của option này và điểm tốt của option kia, và chúng tôi sẽ lại combine lại thành một option khác và lại trình bày lại, tức là luôn luôn là đưa cho chủ tư các potential, và chúng tôi đóng vai trò là y tá đỡ đẻ chứ không phải là người mà tạo ra cái dự án đấy, chủ đầu tư mới là người tạo ra dự án đấy.
Cảm ơn anh. Tôi muốn đặt câu hỏi cho anh Thanh, tức là trong quá trình thiết kế hiện nay liên quan tới mặt dựng thì không biết là Suco với một cái bề dày kinh nghiệm rất là lâu đời như thế và có rất là nhiều các cái hỗ trợ về kỹ thuật, thì không biết là Suco có các cái hỗ trợ gì cho các cái đơn vị tư vấn thiết kế hoặc là nhà thầu hoặc là chủ đầu tư trong cái việc định hình cái mặt dựng cũng như là tính toán các cái thông số.
Thì cảm ơn câu hỏi của anh Quang. Thì trước khi chia sẻ thì mình sẽ nói xíu là background mình là kiến trúc sư, nên đôi khi mình sẽ trả lời câu hỏi á, mình sẽ thêm chút xíu nào cái ý tưởng về thiết kế để chia sẻ cho tất cả các bạn. Thì mình cũng là dân thiết kế, và khi mình gặp 15 năm trước mình gặp cái mặt dựng của một cái đơn vị thiết kế nước ngoài, mình không biết làm như thế nào hết, không biết tại sao mà họ vẽ như vậy, không biết gia công như vậy, làm như thế nào. Thì Suco đã offer mình một cái job mà mình nói cuộc đời kiến trúc sư mình là bước ngoặt của mình chuyển qua đây. Thì khi chuyển qua đây thì mình mới hiểu được là bây giờ dựa trên cái thiết kế của bên kiến trúc sư, làm sao mình có thể đưa ra những giải pháp mà có thể khắc phục được những cái mà không thể nào làm được. Thì Suco cho tất cả các kiến trúc sư và chủ đầu tư cái giải pháp. Thứ nhất là họ có bề dày về cái hệ thống của họ, là đôi khi có một số cái thiết kế nó đã tồn tại rất là lâu thì Suco đã có hệ thống catalog thì có thể follow tương đối là hoàn chỉnh hết tất cả. Tuy nhiên gặp một thiết kế của một các kiến trúc sư có một chút xíu mình gọi là bay bổng, thì Suco có thể đưa ra những cái giải pháp dựa trên những cái thiết kế đã được tồn tại và phát triển hơn. Lúc nãy các bạn thấy được cái giải pháp Rip to Sell của Suco, thì thật ra giải pháp Rip to Sell là một phát triển mới của Suco dựa trên Paris Design. Là cách đây gần 7 năm Suco đã ra một cái mô hình thiết kế dạng phi đầm. Cái đó là cái mà để cho các kiến trúc sư có thể bay bổng trong cái thiết kế của họ. Tại vì hồi xưa mình cũng học, mình thấy là thiết kế đang bị gó buộc vào trong một cái kết cấu. Bây giờ thì khi mà Suco đã nghiên cứu ra những giải pháp mà mình có thể làm freedom và mình có thể đáp ứng được tất cả những cái nhu cầu của kiến trúc sư và đôi khi là ý tưởng của chủ đầu tư. Đó, thì cái đó là mình thấy rất là happy. Và thật ra thì hiện tại trong 15 năm mình mang tư tưởng kiến trúc sư và mình đi tư vấn và mình đi hỗ trợ tất cả các chủ đầu tư và các kiến trúc sư ở Việt Nam trong tất cả các lĩnh vực. Và đôi khi bên Suco sẽ đưa ra những giải pháp tiết kiệm về chi phí, và bên cạnh đó là có những cái phương thức làm sao quản lý được chất lượng của sản phẩm lắp đặt ở công trình, làm sao có thể bảo dưỡng công trình đó hoàn chỉnh. Cái điều đó là cái điều mà Suco đang mong muốn mang tâm tư của mình ở thị trường Việt Nam. Tuy nhiên tất cả cái gì nó cũng có về cái giá cả và cái mức đầu tư của chủ đầu tư. Bao giờ Suco cũng tư vấn tất cả những option trên bàn cho chủ đầu tư, và chủ đầu tư sẽ là người quyết định con đường nào họ đi đến cái giải pháp cho mặt dựng của công trình của họ.
Một câu hỏi nhanh cho anh Thanh, tức là trong cái quá trình mà đơn vị thiết kế họ bắt đầu thiết kế dự án thì Suco mong muốn tham gia vào giai đoạn nào của quá trình đấy?
Thật ra thì nếu mà thời trước thì bao giờ Suco cũng đi vào đến giai đoạn tender, đấu thầu. Tuy nhiên khi mà mình lead thị trường Việt Nam, mình nói là mình bây giờ cũng muốn đi vào từ concept. Trong quá trình thiết kế mình có giai đoạn tiền khả thi, thì đôi khi Suco cũng có thể ngồi xuống build up được ngân sách của cái thiết kế cơ sở đó cho chủ đầu tư, để chủ đầu tư có thể định hình được cái mức đầu tư chi phí của họ như thế nào. Dĩ nhiên những cái gì mình định nghĩa ra thì bao giờ phải kết hợp với bên kiến trúc để hiểu được tâm tư của kiến trúc, để mình có thể ước tính được cái ngân sách vừa đủ cho khách hàng. Và khi đến khách hàng approve được cái ngân sách đó, và khi kiến trúc họ phát triển những chi tiết detail, thì bên Suco cũng có thể hỗ trợ tất cả những bản vẽ concept detail liên quan đến sản phẩm của Suco. Và trong quá trình tender thì Suco cũng có thể viết tất cả các specification và gửi cho tất cả đơn vị để có thể hỗ trợ trong quá trình tender của họ. Và bên cạnh đó, nếu mà Suco may mắn trúng được dự án đó, thì toàn bộ nhân viên Suco kể cả từ headquarter thì bao giờ cũng có một cái quy chuẩn về gia công lắp đặt, bảo dưỡng như thế nào để gửi cho đơn vị gia công nhân kiến của hệ thống Suco.
Cảm ơn anh. Liên quan tới chi phí thì chắc tôi sẽ chuyển cái phần câu hỏi cho anh Lê Phước Đức, đó là hiện nay là trưởng phòng kỹ thuật của tập đoàn xây dựng Hòa Bình. Thì trong quá trình mà bên anh nhận được các cái dự án từ các cái đơn vị thiết kế cũng như là từ các cái chủ đầu tư, thì không biết là vấn đề về mặt dựng nó có làm cho anh quan tâm tới nhiều trong cái phần về chi phí cũng như là về phần kỹ thuật, hoặc là anh có những cái khó khăn gì trong quá trình khi mà mình tiếp nhận các cái thiết kế như thế không ạ?
Vâng, cảm ơn anh Quang, cảm ơn câu hỏi của anh. Thì thực sự là phần phát sát của dự án là một phần cũng rất là quan trọng để mà khi mà có chuyển đổi từ một cái bản thiết kế sang một dự án thật, thì cái phát sát chính là cái mà các cái khách hàng họ sẽ phải quan tâm đầu tiên khi mà nhìn thấy cái sản phẩm của mình. Thì trên vai trò là nhà thầu thì bên phía chúng tôi cũng rất là tìm hiểu rất kỹ về các cái hệ phát sát đang có hiện tại cũng như tương lai. Đặc biệt là khi mà trải qua 35 năm hoạt động trong lĩnh vực xây dựng thì thực sự Hòa Bình gặp hầu hết các cái loại sản phẩm có các cái hệ phát sát khác nhau. Do đó kinh nghiệm mà chúng tôi tích lũy được cũng rất là tốt. Thì cái hệ phát sát thì chúng tôi nó liên quan đến cái giải pháp thi công mặt ngoài của dự án là chủ yếu. Và Hòa Bình cũng tự tin là luôn luôn tiên phong trong vấn đề giải pháp công nghệ, đặc biệt là công nghệ thi công dự án. Do đó thì khi mà có một cái dự án có hệ phát sát đặc thù thì chúng tôi cũng phải nghiên cứu rất kỹ để mà đưa ra một cái giải pháp thi công cho cái hệ đấy cho nó phù hợp và đảm bảo cái chi phí của chủ đầu tư. Bởi vì khi mà thi công cái hệ phát sát giống như là việc chúng ta mặc một chiếc áo ấy, thì cách chúng ta mặc chiếc áo như thế nào cho đẹp cũng là cái mà chủ đầu tư và khách hàng rất là quan tâm. Hiện tại chúng ta không thể là đợi thi công hết phần thô rồi sau đó mới quay lại mới đi là lắp dựng cái hệ phát sát được. Nhiều lúc cả cái công nghệ thi công hiện tại có thể đáp ứng được vấn đề là vừa thi công phần thô vừa có thể hoàn thiện cái phần phát sát đồng thời song song luôn. Do đó thì khách hàng và chủ đầu tư có thể nhìn thấy được luôn là cái tiến độ hoàn thiện của dự án cũng như hình dạng thực tế của dự án trong giai đoạn thi công. Thì vấn đề này cũng đòi hỏi Hòa Bình cũng phải tìm hiểu và nghiên cứu kỹ. Vâng, cảm ơn anh.
Có bao giờ mà anh nhận được một cái thiết kế facade trong đó nó có sản phẩm Suco nhưng mà cuối cùng là chủ đầu tư không chấp nhận hoặc là vì chi phí dự án không chịu nổi, anh phải chuyển qua những cái sản phẩm khác không?
Em nghĩ chắc là có. Và vì Hòa Bình cũng có 35 năm kinh nghiệm thì làm rất nhiều dự án, hầu như là toàn bộ cả thị trường nước ngoài lẫn thị trường nước, nên chắc chắn sẽ có cái dự án đồng hành cùng với Suco và có dự án không được đồng hành.
Rồi, cảm ơn anh. Một câu hỏi nhanh cho anh Lê Phước Đức là hiện nay là cái phong trào mà gọi là design build nó hiện nay nó đang rất là phổ biến. Thì không biết là trong cái quá trình thực ra design build thì nó cũng rất là phổ biến rồi, nhưng mà design build gần đây thì nó cũng nảy sinh ra nhiều vấn đề. Thì trong cái quá trình mà bên anh làm đấu thầu hoặc là bên Hòa Bình làm design build thì cái việc liên quan tới facade nó sẽ như thế nào? Nó có giống như là các cái dự án bình thường khác, hoặc là có cái khó khăn gì mà chúng ta có thể đem ra đây trao đổi? Và đặc biệt là tôi nghĩ là phía bên dưới chúng ta không có chủ đầu tư, nhưng mà tôi tin là có rất là nhiều các anh thiết kế, các anh kiến trúc sư ở bên dưới.
Vâng, cảm ơn anh Quang. Đúng là Hòa Bình là đơn vị tiên phong trong design build cũng rất lâu rồi. Thì bản thân Hòa Bình cũng làm rất nhiều dự án design build từ Hà Nội đến Sài Gòn. Bởi vì là khi mà tiếp xúc và làm với rất nhiều dự án thì cũng các cái đơn vị tổng thầu lớn như Hòa Bình cũng tích lũy được rất nhiều kinh nghiệm liên quan đến cả thiết kế từ thiết kế cho đến thi công và cả liên quan đến concept của chủ đầu tư hai bên cũng nắm rất rõ. Do đó thì cái việc mà chuyển đổi từ bid build sang design build là một cái cách thức để mà có thể tối ưu hóa cái chi phí cho chủ đầu tư trong giai đoạn thi công. Tuy nhiên thì design build không phải lúc nào cũng thuận lợi, bởi vì nó vấp phải rất nhiều cái khía cạnh lợi ích từ các bên, cũng như là đối lập về mặt quan điểm, nhìn nhận về dự án. Design build không có nghĩa là luôn luôn mang lợi cho nhà thầu, mà là mang lợi cho tất cả các bên. Do đó thì khi mà họ bên làm dự án design build thì không phải là cứ chăm vào vấn đề là làm sao để thiết kế một cái dự án mà có thể dễ thi công nhất và chi phí là thi công rẻ nhất, mà chúng tôi sẽ hướng đến một cái dự án mà nó hài hòa lợi ích cho các bên. Khi tiếp xúc với những chủ đầu tư họ cầu thị thì cái vấn đề này tương đối dễ xử lý, bởi vì khi thuyết phục họ bằng những dự án mà họ bên đã làm rồi thì họ và những cái kinh nghiệm dự án. Tất nhiên những dự án đã làm rồi, có những dự án gặp phải một số vấn đề thì sau khi chúng tôi correct lại thì những dự án sau sẽ không gặp lại vấn đề này nữa, thì chủ đầu tư hãy hoàn toàn có thể là đồng hành cùng với nhà thầu được. Tuy nhiên cũng có những chủ đầu tư họ rất lo ngại vấn đề về, ví dụ như một cái giải pháp mà chúng tôi đang làm hiện nay, đó là giải pháp tường mặt ngoài bằng shear, tức là toàn bộ tường bê tông mặt ngoài bằng shear, thì chúng tôi sẽ kết hợp với giải pháp thi công cốt pha leo để đẩy nhanh tiến độ cũng như là đảm bảo cái tính đồng nhất toàn khối cho kết cấu của dự án. Thì giải pháp này thì giai đoạn đầu thì chúng tôi cũng gặp một vài case study liên quan đến vấn đề xử lý facade mặt ngoài làm sao cho vấn đề đảm bảo chất lượng, có một số vài vấn đề liên quan đến chất lượng của cái hệ đấy. Và thứ hai là liên quan đến hiệu năng của dự án, hiệu năng của công trình, liên quan đến vấn đề cách nhiệt, cách âm. Thì chúng tôi cũng phải là có bỏ một thời gian nghiên cứu, bởi vì Hòa Bình có một trung tâm gọi là trung tâm đổi mới sáng tạo và một phòng gọi là phòng R&D chuyên nghiên cứu và đi xử lý những vấn đề đấy. Chúng tôi kết hợp với những cái bộ phận đấy để đưa ra giải pháp và correct lại những cái vấn đề mà đang tồn tại. Thì hiện tại thì cũng đang hoàn thiện dần, những cái phiên bản sau này nó sẽ tốt hơn.
Một câu hỏi rất là nhanh cho anh Lê Phước Đức là khi mà anh làm design build thì cái phần facade anh sẽ thuê một cái đơn vị thiết kế facade hay là anh sẽ thuê luôn cái nhà thầu facade để thiết kế và thi công, báo giá?
Vâng, cảm ơn câu hỏi của anh. Thì giai đoạn đầu thì đúng là chúng tôi phải kết hợp với một số đơn vị để thực hiện việc này. Nhưng mà hiện tại thì chúng tôi đội ngũ tương đối là hùng hậu. Chúng tôi có một phòng thiết kế với số người lên đến là khoảng từ Nam đến Bắc là khoảng đến 60 người chuyên về thiết kế, và có một đội phòng BIM cũng gần 100 người làm về BIM. Thì trong thiết kế có đầy đủ các bộ môn kiến trúc, kết cấu, MI. Do đó thì hoàn toàn có thể cover được tất cả những cái yêu cầu kỹ thuật cũng như là các cái ý tưởng của chủ đầu tư.